infrastructure development. To learn more, please visit our website at www.f4f.space or reach out to any one of our team members on your screen. I have the pleasure of introducing our morning speakers today, beginning with our co-founders who will kick off today's event. Tim Chrisman is Executive Director and co-founder of Foundation for the Future. A former CIA and Army intelligence officer, Tim supported the National Space Council and the Joint Staff at the Pentagon. He holds master's degrees in intelligence studies and international relations and affairs, both from American University. Mr. Chrisman is the author of the book Humanity in Space and of various articles about the expanse of our civilization in space. Tim's next challenge and mission is to make space accessible, survivable, and ultimately routine enough to be boring. Tim?
Thanks, Lee. Yeah, so I'm coming to you from Akron, Ohio, where we're taking conversations on the road. Last month was our first on the road event where we go to towns across America that are emblematic of America's past, that led a certain facet of our economic or social growth, and who are otherwise left behind. Too often when we talk about underprivileged and underserved communities, we don't think of those communities that were once vibrant centers of commerce and industry, like Scranton last month, Akron this. And so I'm excited to be here today talking to you all from Akron, Ohio, the former rubber capital of the world, and now home to one of the fastest growing renewable energy sectors in America. So I'm talking to you from the Glendale Steps. These are a public works project from the Great Depression era that we chose in part because they're called steps to nowhere. You can't see, but I am looking out over literally nothing. There are trees, but they're $20,000 worth of carved stone steps going down a hill here that were done as a project during the Great Depression to give jobs. And the idea was to allow Akron residents to access two sides of this hill. It wasn't terribly useful because, as I mentioned earlier, they are to nowhere. There's a cemetery on one end and a parking lot on the other. But the point of them was there's a need for infrastructure. How can we do it? And in the Great Depression, where so many people were out of work and there was a desire to just buy jobs, this was the sort of project that was considered good and worth it. And so now as we as a country are starting to talk again about major infrastructure investments, there's a desire to ensure that those investments don't go to stairs like this, to bridges to nowhere. I grew up in Alaska, and so I know a little bit about wasted infrastructure projects. And so we're here this month to talk about energy and space. And one of the infrastructure investments that has a phenomenal track record of investment return and is also quite likely the key to unlocking not only the US's economic and energy independence future, but quite likely unlocking our ability to lead the world in solving global crises, whether it's humanitarian disasters, climate change, or really you name it. If we are able to deliver energy from space to the ground, it changes everything. So as I mentioned, I'm here in Akron. It's one of those left behind, sort of underserved communities. Right now, its unemployment rate is about twice what the rest of the US is. Its expected growth rate over the next 10 years is about 10% less than the rest of the US. And it's not because of any structural weakness. Ohio, and specifically Northeastern Ohio, have been leaders in the aerospace industry since the Wright brothers. pieces of the Apollo lander were made just around the corner here at a Goodrich and Goodyear factory. And the workforce here is well educated, is skilled, has access to the international logistics chain, but somehow it's left out. Somehow it's growing slowly. And so our message here, as we've presented it to the Scranton Chamber of Commerce, to the Scranton Mayor's Office and school districts, is the space economy offers a chance for Akron to come back and be the leader for the next century of manufacturing and aerospace development. Historically, Akron was known as the rubber capital of the world, back when tires were king. Last night I ate at a spaghetti factory, spaghetti warehouse, I think it was called. Turns out it was not actually a warehouse of spaghetti. I was exceptionally disappointed. It's an old tire warehouse. And those are scattered all over town. You don't need that sort of manufacturing or warehouse capability anymore. For the most part, that's been outsourced. But that expertise in making polymers and advanced materials is critical to unlocking new forms of space vehicles, new and advanced solar panels, and new ways of interacting with everyday things like our cars and, yes, even our tires. So ironically enough, Akron's expertise in polymers and advanced materials may allow it to once again use some of those abandoned warehouses for tires. But these ones that are supplanted with space age technology like they use for the space shuttle and others, whether it's graphene, carbon nanotubes, or other advanced composites, they have a chance to put themselves back on the map. And that's what we want to help do here. So if you're a speaker and you're talking today, think about how is it Akron can use what I'm talking about? How is it they can make this? How is it the workforce here in Akron, consisting of well-educated, whether with trade schools or undergraduate degrees, who are excited about revitalizing their economy, how can they play? We're having a business plan competition where teams are submitting ideas for new and exciting opportunities in space. If you're one of those teams, can you make it here? If not, why not? There may be a good reason. You may need access to the ocean. But if not, is there something Akron could do to win you over? Because at the end of the day, we want to be able to deliver to this town a roadmap to revitalization, not one based on useless platitudes about how in 5 more minutes they'll grow up and be real kids like Pinocchio or something. But instead, how can they be useful contributors in the broader space economy and America's future? So think about that. If you're a participant, think about what is it that you're hearing today, and how could that apply to your town? Maybe you grew up in a small town like me. I grew up in Alaska, middle of nowhere. I often think about how could the space economy play in my town? As a kid, I was positive there was no way it could. In the middle of Alaska, it's cold all the time. We didn't even have power or water all the time. So there was no way we were launching space shuttles or helping build new rockets. But now as I look back, I realize whether analog astronaut training facilities, the ability to adapt, innovate, and overcome, or just the isolated nature of my home gave the people I grew up with an inherent advantage if they ever wanted to play in the space economy. My neighbor growing up is now the county mayor. And I've talked with him recently about how our county almost wholly dependent on the military frontier town, uh, vibrantly participating in space. I haven't convinced him yet, and I plan on using footage from this event, which is in a town about the same size as our whole entire county, to show him, look, Bryce, we built forts as kids growing up. We carved ditches in, cut logs together. We know what it's like to build basic infrastructure. Now, granted, we were 13 years old, and so basic infrastructure had a different meaning. But at the same time, we knew we have a general sense. Space needs that. Space needs people who are able to figure it out, to build it. And I'm excited to be looking for those people where they live, places like Akron. So once again, thank you for being here today. This is our first Conversations for the Future event. Lila's going to talk more about sort of the structure and mechanism of how we're doing these events, why, and sort of, what is it that makes these special? But a lot of it's in the name. This isn't meant to be a monologue to you, although that is exactly what I'm doing now. It's meant to be a conversation where we talk, you talk, and we find out, do the speakers here truly have the best ideas, or do they need to run into some more to improve themselves? How can we learn from you as much as you learn from us? So thank you for being here. And I'd like to hand it back to Lila, who will probably tell me I need to go for several more minutes, which is okay.
Not at all. Not at all. That was great, Tim. Thank you. And I don't think you could have picked a better backdrop. That's spectacular. It's both visually stunning and appropriate.
Yeah, I didn't. This was entirely Ashley, who's running the local ground game here. I'm standing on the X where she told me to stand. So this is there. I would have stood facing a tree or something.
Yeah, come on now. Come on.
Ashley.
All right. Well, I will pass it back to Lee, who I think will then intro me, and then I'll, probably intro someone else and go from there. But Lee, before I start, I just wanted to call you out on something. Last month, you did promise that you would show up in Princess Leia hair today.
Yes, I am working on that. Amazon is a little bit late with a delivery. I'm hoping it will get here by the end of today.
Oh my gosh. I'm on pins and needles. I can't wait to see that. Thank you.
All right. So thank you, Tim. What beautiful spot. Great comments as usual. Now we'll go to Lila Gislason. She is co-founder of Foundation for the Future and leads marketing and development efforts. Ms. Gislason is a seasoned marketing executive with an extensive knowledge of change management, design thinking, and brand alignment. She previously worked in marketing roles across Fortune 500 companies and is passionate about helping teams bring out the best through cultural development. She studied industrial design at the University of Michigan and is joining us from Ann Arbor. All yours, Lila.
Thank you so much, Lee. Well, first off, I just want to thank everyone for being here. Your support means a lot to all of us. We have a small and growing team, and we're just overjoyed that you're here. I'll begin just by giving an overview of the day, and then I'll drop into a higher level overview of what we're doing here at the foundation and what our goals are. As you can see, Tim is in Akron, so we will be touching on a lot of Akron-themed topics. And I want to really kick off by mentioning maybe not quite the elephant in the room, but this event used to be called Blue Marble Week. So I still have to retrain my brain to call it Conversations for the Future. We call it C4F for short, but this is a monthly series that is inspiring conversations to advance space access for everyone. So if you've been tuning in since December 2020, which is when we kicked off our first Blue Marble Week event, you'll know that the event will not be changing much, but we do want to, as Tim said, make it more conversational. We've incorporated some more conversational elements, and of course, we want you to drop notes in the chat, and feel free to reach out to each other, and just keep it relaxed, if you will. So our goal at the foundation is to make space accessible to everyone, not just astronauts and billionaires, as people like to say. So what we're trying to do is we're trying to accelerate the United States' space infrastructure development. So this is kind of the building of the roads and rails of space. And again, like Tim likes to say, to make space boring enough to be routine. We're doing that through education, advocacy, and through collective voice. And really, most importantly, urgency. If we want to see progress in space in the coming years, 3, 5, 10 years from now, we really need to make changes now. Luckily, we are proposing a solution to this acceleration. It's called the Space Corporation Act, which is a bill that we're currently proposing to the 117th Congress. We are excited to report that over 80 representatives and senators are in early support of the bill. So a lot of support, a lot of buzz. It's really exciting. So the foundation and this event itself has a big vision and big goals, which I'll dive into later. And we'll talk more about the Space Act. I'll also talk more about the event's slight shift in focus, obviously the name change and the rebrand. But first, I will provide a quick overview of the day. As Lee mentioned, the month's theme is energy in space. We'll touch on the various energy sources within space. And yes, of course, we'll discuss space-based solar power, the infrastructure and policies required to activate it, and the workforce will need to enable it, and really the whole ecosystem. I don't know that anyone here is from Akron. Usually you can see a hand raise or a wave or yelling or something, but it's unlikely, and it's unlikely that you know much about it. So yeah, I'm again super excited to have Tim there, and he'll be educating us on how Midwest towns like Akron can become a part of the space economy. I think typically that's associated with Florida, California, now Alabama, but we hope to change that, and we hope that throughout this event we can uncover why towns like Akron are exactly what this industry needs. I don't think Tim mentioned it, but I thought this was an interesting fun fact. Akron is already on the space map. Judith Resnick was the second woman in space, and she was also one of the astronauts who tragically died in the Challenger explosion. But I think she's still a popular name there, and yeah, it's funny how small this country is and how connected it is, and how anyone can come from anywhere and rise to greatness. So anyways, today is lined up to be a very engaging day. We will start this morning with Coyote Smith, who is the associate professor at the U.S. Air Force Air Command and Staff College. He will dive into his report about space-based solar power and strategic security. If you want to get a sneak peek of that report, do go to our website. It's on the event page. If you scroll down and find his bio, you'll see a little link there that you can click on. We'll also be joined by Peter Gerritsen, who is a senior fellow in defense studies from the American Foreign Policy Council, and then also retired Lieutenant General Stephen Quast of the U.S. Air Force. He's very dynamic. He's spoken at our events here before. And then, but before we let them go, the three of them and Michael Lane, of course, will jump into a conversation starting at 11:30, where they'll collectively discuss space-based solar, and really more from a defense and national security perspective, and an energy scarcity perspective, which is interesting. So definitely tune in for that. And then starting at 12:30, Dallas Bienhoff will speak. He is the founder of Cislunar Space Development. He will be joined by, he will then be joined by, sorry, let me take a sip here of water, by Paul Chang, who is the founder of Fuse Ring, and they will both talk about hardware and the tools necessary to support infrastructure of space-based solar. So, we'll squeeze in some more segments from Tim. And then starting at 3, this conversation I'm very excited about, we'll be hosting the dynamic Rick Tumlinson of the Space Fund and many other ventures. He was also one of the producers on the High Frontier documentary about Gerard O'Neill, which just came out recently. And he'll be joined by Will Henry, who's the executive producer of the film. Really excited. I did have the pleasure of watching the film when they showed it live a couple weeks ago, and I've got to say I was really impressed. I wasn't surprised by the quality of the film, that was a given, but just how it shifted my perspective a little bit on kind of our size and scale in the universe. And check it out. It's on Apple TV. If you have a moment, I think you'll be more inspired to do so after the conversation. And before we close, this cannot be missed, and I think the majority of this will be tomorrow, but Tom Olson of the Center for Space Commerce and Finance will give us a preview of what to expect from the business plan competition. This is a kind of Shark Tank style event where a couple of entrepreneurs will go head to head to win the competition. It's super exciting. So definitely tune in. And of course, we'll continue to ponder the space economy and all of these things. So energy and space, love the title, love the theme. Yes, the default is the obvious space-based solar and some other resources in space, but energy can come from various forms, no? And I think while harnessing the energy in space has the potential to change everything, our collective energy here on Earth also has the potential to do the same. In fact, it has to if we want to see progress towards space access for everyone in our lifetimes. I assume that's why we're all here. I think that's definitely something we all share, is kind of a bigger and broader vision for what our place in the universe can be. So one of my favorite quotes is from anthropologist Margaret Mead. She said, "Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it is the only thing that ever has." So thank you for joining the conversation here today. I'm now going to kind of switch over to presentation mode. Let me share my screen. I think I'm the first one to attempt to do this, so let's make sure it works. All right. One moment, sorry. So does anyone else have any May the 4th anecdotes? Michael, I'm surprised.
So I made a very conscious decision to not wear my Chewbacca t-shirt for this event, but it was a close call. I mean, I am wearing little fuzzy furry animals, but I chose not to wear my my shirt says party animal, but when I wear it, the only thing anybody can see from this screen level is party, and it didn't quite work. So
Too much party.
yeah, I chose not to wear it, but it was a close thing.
All right. All right, sorry about this.
Bring out the Inara's lightsaber. Thanks.
Awesome. All right. Why am I having technical difficulties now? Okay.
While Lila,
right.
you're doing that, do you have it?
I think so. All right. I think I do. I'm just trying to minimize it now.
While you're doing that, I'm just going to throw out a shout out. I'm seeing a lot of old but familiar names and faces on the channel. So thank you everybody for joining us, and definitely a shout out to the National Space Society. I can see that I think about 4 or 5 or 6 of y'all are here. So thanks for that. I presume that's because of Randy talking later today, but really glad to see y'all here. Thank you.
All right. I think I'm good here. But sorry, I don't usually have this issue. All right. You know what? I'm just going to send this to our dear friend Fabio, and we can do it this way.
Would you like me to introduce Emily while you're working on that?
You know what? If Emily is ready, that would be great.
Emily, are you ready to go?
Yep, all set.
All right.
Thanks,
So
Emily.
we'll be excited to get back to Lila when she has those issues worked out. But before we move on to our next speaker after that she gave us that rundown, I want to offer the screen to Emily Mishler in the Development Office for Foundation for the Future. Specializing in business development, creative strategy, and fundraising, Emily launched her first company at the age of 22 and has since raised and distributed over $20 million of private investment for private clients, for-profit entities, and NGOs. She runs a group of impact-driven companies called the Cultivated Group and is on a mission to ignite and empower individuals and organizations to be the change they wish to see in the world. Good morning, Emily.
Hi, Lee. Thank you so much for that generous introduction. It's wonderful to see you all. A lot of familiar faces. Great to see you back, and also great to see some new ones. So thank you all for joining us in Conversations for the Future today. As these relationships continue to grow and progress continues to be made, it's becoming more important than ever before to have the infrastructure in place to support the foundation for the future's growth. And we're positioning the foundation to be able to continue this important work for years, if not generations to come. From the conversations that have already been had today and will continue to be had today, it's becoming abundantly clear that our work is disruptive, necessary, and the time is now. And that means the Foundation for the Future needs your help. The comprehensive vision, expertise, dedication, and momentum of the speakers today, and the vision of the Foundation for the Future, the powering force behind Conversations for the Future, is more impressive and important than ever before. The future the Foundation is building is inspiring and worth investing in. This future, in space and beyond, as Lila had mentioned, is being built one relationship, conversation, and connection at a time. In order to continue this momentum in building and contributing to this caliber of event, conversation, and building community, we need your help. We need you, our allies, attendees, partners, advocates, and friends, to spread the word about our important work through social media, invite like-minded and like-hearted peers to our events, and to help us connect with philanthropists and organizations who believe what we believe, that our future in space is ours for the building, and the time is now. We're so excited to announce 3 different avenues to become involved if you're interested and curious in supporting our financial work. On the corporate level, we have the opportunity to sponsor Conversations for the Future. For more information, please visit our website, f4f.space. And you can also sponsor and support the foundation at large on a corporate level on a monthly and annual basis to support this important work. If you, your friends, or family are inspired to support us, secondarily, we welcome your contributions to support personally building space infrastructure and economy. The foundation has also recently launched a corporate and individual membership program whose mission is to connect like-minded and passionate individuals who see near-term space potential. We're recruiting everyone from students to CEOs to join us in creating a dynamic ecosystem of young enthusiasts, investors, entrepreneurs, organizations, and larger industry partners inside or outside of the space industry. You will see the QR code on that screen if you want to give it a little video. Inside or outside of the space industry, we'll welcome all who want to join and contribute to this urgent conversation which impacts us all. More information is again available on the Foundation's website, f4f.space/membership. So what is the ask here? Help us in making space boring, because the time is now and the world can't wait. If you have any questions, please don't hesitate to reach out to myself, Lila, Tim, or any affiliate of the Foundation for the Future. Our emails are our first name at f4f.space. Our contact information and a link to donate is also available at the QR code that's on the screen and through the website. I'll be happy to stick around and field any questions that y'all may have in the chat. And thank you so much. But for now, I'll turn it back over to our MCs and Lila for our regularly scheduled programming. Thanks so much.
Thank you, Emily. Appreciate it. Thanks for jumping in. Okay, change the screen now. Thank you, everyone, for your patience. So yeah, again, I'm Lila, Chief of Marketing and co-founder of Foundation for the Future, and gave a quick introduction already about what we're expecting during this event, but I want to give a little bit more background about what we're doing, why we're doing it, and talk about some of the initiatives that we're kicking off here with the foundation. So again, thank you all for joining us. As I mentioned, we kicked off this event series back in December with some of our phenomenal partners. And our goal is really to accelerate the United States's space expansion through infrastructure development. We really see it as the first step to creating a thriving space industry and economy. And it's really the first gateway to outer space. Without the infrastructure here on Earth to support and further expand our reach, there is no final frontier. So today, again, I'll share a little bit more about the foundation, our vision and goals, a little bit of background on how this event evolved, and a little bit about our outreach and advocacy efforts. So here are our goals, and they are designed to support our vision of space access for everyone. Number one, to create sustainable space infrastructure that supports economic growth on Earth while securing US interests in space. Number two, to pass the Congressional Space Corporation Act of 2021. And a little more on this will come here, because this is really our most urgent initiative. We are proposing it now to the 117th US House and Senate, and it will hopefully go to presidential signature into law no later than the 60th anniversary of the Communications Satellite Act of 1962. So that's here in the coming year. The Space Corporation Act will provide a public-private corporate structure to finance space projects, and it will offer loan guarantees through commercial lending institutions. This is to support technology innovations. Obviously, this industry is just ripe and I think ready to explode with the right stimulus. It will create an investment fund to provide support to new space companies. It will provide grants to small businesses and other starting entrepreneurs in the space sector, and support for the public benefit of space infrastructure projects through bonds and other financing opportunities. The Space Corporation Enterprise will have 3 offices, next slide please, which together will serve as the linchpin for the planning, financing, and administration of the basic infrastructure. There will be a Space Development Fund, Spaceport Authority, and a Center for Space Studies. So getting back to our third goal, next slide please, to create an ecosystem of commerce for companies, innovators, and leaders who are building the future of America. We're here to start a conversation, make connections, and to ignite a community around our shared vision, which brings us to this event. So this monthly event series is one of the many ways in which we are supporting our vision for space access for everyone. And, you know, again, starting conversations with small, dedicated, like-minded people like yourselves has the potential to change a lot of things. In fact, since December when we started, I would argue that most of the value of this event has really come through the conversations that sometimes follow the event. The people that we meet, the things we learn, the connections that are made, introductions made, it's really incredible. And we're just excited to be a part of this network. So Blue Marble Week, the original concept for our event, it's not disappearing. We're actually going to maintain the name for our December event, which will be a true celebration of the namesake of the event, which is the photograph that was taken by the Apollo 17 crew in 1972 on December 7th. So that's exciting, and that will really take on more of a celebratory, I guess, angle. This more educational, really looking forward to Blue Marble Week being a party. So our goal is to, you know, keep Blue Marble as a symbol, of course, of our organization, but we want to achieve something bigger with the conversations. And as I mentioned, the magic is in the conversations. So I wanted to invite one of our very key team members, Leo Llanos, who is our designer, creative person, digital master, all of the above. He's also one of the MCs for this event. And I just wanted to invite him in to talk a little bit about how we came to the new identity and the new brand for the event. I think I just want to start by saying this is a foundation for the future event, and we wanted to make sure that was clear in the conversations for the future event. So obviously the name is similar. We wanted to keep the branding similar. Leo, are you around?
Yes, I'm right here. Hi, Lila. How are you?
Hey, Leo. I'm great. How are you? Yeah. So you came up with this incredible design. I just wanted to get your quick thoughts on it, because I know you've articulated it so well with a lot of us internally. Yeah, just kind of high level, couple minutes on how you came to this and what it means.
Yeah, of course. By the way, you look beautiful today.
Oh, thank you. You don't look too shabby yourself.
Thank you. I try. So, hi everybody. Yes, my name is Leo Llanos, and I am design manager along with a couple other things here at Foundation for the Future. When, as Lila eloquently put, one of the key factors in what this event is the conversational piece of everything. In designing this logo, I asked myself, how can I put a logo that actually pretty much represents what conversations are? And I looked into my past, on my childhood, and me being an avid comic book reader as a kid, one of the reasons that conversations was obviously put out was in a chat bubble. So I asked myself, well, I want to create a logo that represents the conversational aspect in a chat bubble, but also make it space. So that's why I came up with this logo, which is not just a chat bubble, but it also represents the orbital things, the launch aspect of ideas, of conversation, of that pretty much connection, and have that classical feel of what Foundation for the Future is. And I came up with this, and I was very much really excited to show to the team what I had come up with, because it has roots that are very profound to myself, because I wanted it to represent pretty much what this event does, which is a collaboration of all of these amazing people who come together in this culture as a family of space, pretty much people who are in love with the idea of what space is. Not even if you grew up thinking, okay, I want to become an astronaut, or I want to work for NASA, or I want to work for something that has to do with space, and you didn't actually grow up to be that, that never goes away. As if you're a part of these events, you're a part of a movement. And in doing so, you're aiding us and helping us in bringing together space access for everyone, which is what we are here, Foundation for the Future, we stand for. And we're making possible for everybody, not just a certain group of people, not just an elite group of people who are able to do that, but to everybody who ever thought, what's out there, what's in space. When I look up at the stars and I ask myself, I want to go in and be an adventure and explore. Conversations for the Future embodies all of that. It is a blueprint of all of these conversational pieces. So with this logo, I think that I nailed it. I'm not gonna, toot my own horn or anything, but I'm really proud of it, because when I look at it, I do see what this event represents. So I hope that when you look at this, I want you to ask yourself, well, what does this represent for myself? Everybody has ideas, they're all different, but that's what makes it unique. So thank you so much, Lila.
Thank you, Leo. Appreciate that. And I just want to add that, our goal for this event is not just to be for the space industry. I think initially that's who we are here. We are kind of within the industry, or space enthusiasts, but not exclusively. I mean, I'm new to the industry, and I've been warmly welcomed. Leo as well. He's an artist, creative photographer who's always had a passion for space. So here he is, and we want this event to be welcoming to, not just everyone, but different industries. And I think though many industries may not see how they relate to space yet, they will in the very near future. We're actually co-authoring an article in Foundry magazine, which is for foundry professionals, miners, and starting to have conversations about why this is not just a space conversation. Space will need manufacturers, plumbers, automotive people. So this will certainly be a group effort. So 2 slides ahead, please. So speaking on other skills needed for potentially a new workforce, we here at the foundation are creating a workforce development center. Again, we're going to need skills far beyond the scope of astronauts, welders, logisticians, hospitality workers. And it's really not too soon to enable educators, employers, and parents to understand the full range of careers available within the space economy. So that's something that we're in the process of doing. Also, we are, next slide, please. We are launching a scholarship program, most recently with Langston University, a historically Black college and university. They are helping us find a student who is, again, not maybe the most obvious choice, but really a student who is passionate about space and dedicated, really dedicated to the vision of space. Next slide, please. We are, as I mentioned before, we're kicking off our Center for Space Commerce and Finance Business Plan competition, which you'll learn more about here later today, and tune in for tomorrow to get a better sense of what we're doing there. Also to make a bigger impact, next slide, on the Hill, we are hosting congressional webinars. Those are open to everybody. So far, we've already hosted a number of these webinars and the audience just keeps growing. So it's really great. Our next one will be on May 10th at 8:30 in the morning. You can go online and register for that now. It's going to be about federal appropriations and the future of space development. That'll be really good. So tune in for that. Emily mentioned this briefly, but I just wanted to also talk a little bit about what we're doing to help both spread our message and to create, again, this collective vision and voice. We've recently established a membership program, which will really help us achieve two goals. We will empower our community, and we will also create a sustainable model that will enable us to continue our education and advocacy work, and of course, support our passing of the Space Corporation Act. And we are already well on our way. Next slide, please. Here is a list of our growing members and supporters. We really want to form an alliance here with the collective voice. So between now and May 10th, we are on a sprint to collect to collect support, really, and signatures for an open letter to Congress. And I will read that quickly, and then we'll move on here in a moment. But the reason I want to read this is because I think we'd like to add as many supporters to this list as possible. So as we send this list to the executive branch and Congress, we want, not just SpaceX and Blue Origin at the top of this list, but we want 100 logos of support to show that there is a need for what we're proposing, and that there is support behind it. It's not just one voice, it's really the whole industry. So let me read that to you real quick, and then we'll move on. Dear President Biden and leaders of the House and Senate, for over 60 years, U.S. government and private sector investment in space programs have showcased American innovation, ambition, and accomplishment on the worldwide stage. Space is inextricably linked to our economic prosperity, U.S. national security, understanding of our planet, and everyday American life. As our nation becomes increasingly reliant on space for these endeavors and future technological challenges, the interconnectivity of our three space sectors, civil, commercial, and national security, require public policies and investment rooted in a whole of society approach. Right now, the private sector provides the short-term, generally 10-year and earlier financing for space investments, large and small. NASA and Space Force provide long-term scientific and military investments, but the country lacks a source of long-term infrastructure financing. A solution to that problem is the Space Corporation, a public-private partnership designed to unlock long-term private capital without requiring large government investments. New tools and investments in the space economy will provide stability and continuity to the United States space endeavors, enabling historic exploration and scientific achievements, continued U.S. space industry global leadership, and enhanced national security. Harnessing the space sector's capabilities will help fuel our economic recovery, help solve the climate crisis, and build the diverse 21st century education system and workforce that America needs and deserves. We strongly encourage this Congress and the Biden administration to support the rapid passage into law of the Space Corporation Act. So thank you. If you have a space or space adjacent company and you want to add it to our name, to your name to our list on the open letter to Congress, please drop your email in the chat and I will send you this letter as well as a draft of the Space Act for review. Your support is greatly, greatly appreciated. Yeah, without further ado, I will wrap it up, but thank you again for tuning in. Feel free to contact me at Lila at f4f.space. And I look forward to continuing the conversation. Thank you.
Thank you, Lila. And what an impressive list of members that is on that slide, growing so quickly over the last few weeks. Thank you to our enthusiastic audience here today to hear about energy and space. I think we can feel some of that energy building here in the chat and in the virtual room. Be sure to add your LinkedIn to the chat to leverage the networking benefits of this event. To kick off the technical program, please welcome Michael Lane. He founded the LiftPort group with the idea that an elevator to space could and should be built commercially. The concept for LiftPort was simple: to develop the subsystems and precursor technologies needed for the elevator and to commercialize these as a method of payment for the larger, longer-term project of building the elevator itself. Areas of focus for LiftPort are robotics, nanotech and material science, finance, and media. Michael, tell us more about what we're going to talk about today.
Good morning, y'all. Thanks for joining us. So great to see all these folks on the call currently, and then the folks in the wild, wild west of the internet that are watching on YouTube and Facebook. We're grateful that you're here. I usually do a 30 or 45-minute talk about what I refer to as the grand architecture, but we have so many great guests today and tomorrow that I very consciously cut that to just 15 minutes and then graciously handed over most of that time to Lila. So we're going to do this super duper fast. Let me just share my screen and jump into it. Is everybody seeing the screen? Okay. And that's full. Yes. Thumbs up. Okay, great. Thanks. So I've been working on the lunar.
Presenter view.
Which one are you seeing? Okay.
Sorry.
You're seeing the full screen or the presenter
the big
screen?
and the little with your notes.
All right. Not messing with that. There. We're going to go that way.
That's Notion.
There. Good enough?
Yes, sir.
Thank you very much. All right. We're going to blast through this. So, a couple months ago, almost a year ago, the National Space Council came out with a pretty darned important document. I really urge folks to read it. It is the current federal policy for space development. It is a very dense document that has a lot of stuff that folks in our community should really, really pay attention to. I would normally spend a lot more attention on it, but I want to urge everyone to just go and tackle it. Surprisingly, it's very readable, which for a government document, that's pretty rare. It focuses on 5 main areas. The ones that we're going to pay attention to are commercializing LEO and returning to the moon to stay. Now, this document lays out the near future of what's going to happen in space. And I have about 100 slides. I'm not going to share about that. But the gist of it is it's a very ambitious program, and I'm super excited about it. Later today, in just about an hour and a half, Lieutenant General Quas is going to join us. Unfortunately, the chief scientist of U.S. Space Force is not able to join us, but this is some of the comments that they've made regarding some of these topics. There is a very significant role of government in these programs. They are both a catalyst, and because of all of the private investors going into the community, they are also what we call a lighthouse client. Some folks are familiar with the idea of a anchor tenant in real estate, but a lighthouse client is also the kind of organization that is pointing towards safe passage, and they're saying that this is something the government is interested in, and they have put their money where their mouth is. We're going to skip some of this stuff about hardware business outreach and framework, but that's kind of how we structure everything. And when we talk about the grand architecture, we're usually talking about 4 major actors. Now, there's lots and lots of sub-actors here, but I refer to it as AC/DC, academic, civil, defense, and commercial. So all of those folks are represented in today and tomorrow's conversation for the future. They've been represented in all of the prior Blue Marble Week events. So this is, my opinion about how space is going to unfold in the coming next 15-ish years, 14-ish years to 2035. We've always boxed these conversations around from the ground of Earth to the lunar surface between now and 2035. And it's going to kind of unfold in a very specific way, I think. Launch, that's always been the thing that got everybody excited about. It was the thing that was the hardest problem to solve at the time. I would say with about 10 reusable rocketry companies in America in development, and probably double that number offshore in other parts of the world, I would say that either launch is solved or it is near to being solved, which allows for communications and Earth observation to blossom. That leads us to in-space transportation. Several of our speakers later today are going to talk about components of that, Dallas Bienhoff and Paul Chang. As many of you all know, a pretty big focus of my career has been on space elevator development, specifically the lunar space elevator. I think that enables space stations, ultimately mining, and really the largest part, the hardest part of space is the reason I got into it in the first place. Now, I owe a lot to my good friend, now deceased, Ralph Nansen, who got me on this path of space in the first place. I originally was going to join his team on space-based solar power. We had some long conversations. I'm like, we can't solve the problem. We don't have launch capabilities. So that's actually why I joined the wackadoo crazy idea, and I say that lovingly and sarcastically, about the space elevator, because launch was such an important component about building space-based solar power. I've since transitioned to think that maybe we could do a lot of that from resources harvested from the moon, but that's a little part of a later conversation. So that's what I think the grand architecture looks like kind of going forward. And with that, I am going to close very quickly and pass it back to Lee. Thanks, y'all. I'm happy to chat with y'all offline about this.
All right. Dr. Coyote Smith is a professor of strategic space studies at the Air Command and Staff College in Montgomery, Alabama. He was the director of the Pentagon's Space-Based Solar Power Study Group, which ran from 2006 through 2007. He is here to discuss the history and findings of that report. Welcome, Coyote.
Thank you very much. I'm delighted to be here. First of all, it's fantastic that the Foundation for the Future is doing this series of lectures. I want to first give a shout out to Jeff Kruken, who said something to me back in 2007 during this study timeframe. He said, it's so refreshing to have a group that truly gets it. We don't need to make the case because we understand it. But what the burden on us now is to put it all together so that we can motivate the rest of our nation, our allies, and the world in order to accomplish the great things in space that we see coming. I think it's going to be important for us to start with a disclaimer because I am an employee for the US government. All the comments that I'm going to make are my own. They do not represent the opinions of the United States Air Force, but they ought to. And so now I'm going to press ahead. I'm going to tell you a story. And it's a very compelling story about how this project, Space-Based Solar Power Study Group, got started and how it rolled. And then I'll provide you with the findings. I need to start by saying space-based solar power is foolish. It will never get done. It costs too much. There's too much infrastructure involved with it. And these were my thoughts when my dear friend Peter Garrettson, who you're going to hear from in a few minutes, gave me a call and started discussing this idea with me. And now, without further ado, I'm going to transition and beat you to death with PowerPoint slides and provide witty and entertaining commentary. Do, 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 do.
Consider us entertained.
I hope that you can see my slides. Can you see my slides? Okay.
Yes.
A funny thing happened to me on the way to the Space-Based Solar Power Study Group's final report. You know, it was a hard thing. Let me give you a bit of the history. I'll step you through it. Now as I try to advance my screen. There it is. Okay, so this guy named Mike Hornacek, a student at Air War College who nobody had ever heard of, wrote a paper, and it was called War Without Oil. And in this book, he actually discussed what space could do to contribute to the ability to conduct warfighting in the 21st century if we were starved of petroleum products. And you see, he's already published this book. It's available on Amazon. There is your cheap plug for Mike Hornacek's book. But what's interesting here is the cover. Why the heck would they put a cover like that on a book titled War Without Oil? I'll leave that for you to answer later on your own. Anyway, Pete Garrettson read this book and he gave me a call. He says, hey, Coyote, I'm going to send you a copy of this paper because it was just a paper form at that point in time. And I want you to take a look at pages 67 through 73 or whatever it was to look at space-based solar power. We actually called it space solar power at the time. Interesting story. We started referring to it as SSP, space solar power. Problem was that was sending off the triggers that our security managers used because SSP was a code word for some classified programs that we had. So we had to change the title of space solar power to space-based solar power, or SBSP, so that we could get it through the internet screeners. So he sent me the paper. We met for coffee, and I told Pete, no way. There is no way this is going to work. This is too big, too much. The Air Force is not interested in this type of stuff. They will kill us. And Pete goes, well, yeah, they're probably going to kill us anyway. But, you know, let's give it a look. So, okay, Mike Hornacek, the author of that paper, came and met with us. And we met with John Mankins. Now, John Mankins, and thank you, John. I see that you're on the line with us today. He sat us down and he said, you know, look, I have conducted a refresh study, a fresh look on space-based solar power, and it's really viable. And I'm like, well, what about power beaming? He goes, here's the results from the 70s. Here's the result. You know, the power beaming is something that we do. That kind of surprised me. And then he talked about the size and scale of satellites on orbit, the type of materials that would be involved with this, the assembly techniques. I mean, the infrastructure, the building of this was getting massive. But he had a plan. And John Mankins is not a guy to not have his numbers lined up. he presented a very compelling case about how receiving antennas on Earth would receive this radio transmission, reconvert it back into energy, and feed it into the existing electrical power grid. We even sat there and speculated how in the back part of the 21st century that we wouldn't feed it into the increasingly antiquated terrestrial network of power systems, that we could do open air broadcasting of this power. Nikola Tesla had investigated this in the late 1800s in Colorado Springs. So I said, okay, let's take a look into this. But at that time, I was the chief of future concepts for the National Security Space Office, but I knew that we would get killed if we tried to put this into my portfolio and tried to work this directly. So Mike and Pete and myself, we decided that we would put together a briefing with all the points that we were learning about space-based solar power, and that we would try to peddle this around Washington, D.C. But we knew we couldn't be caught peddling this around DC because they would have killed us. So we were bringing clothes in our backpacks and changing into clothes and running around and giving briefings to different organizations, not only in the Pentagon, but elsewhere. We couldn't get anybody to come to the Pentagon to meet with us. This is an interesting story. I'll tell you the rest of the story, how that turned out. So we realized that we were leading a cabal. It was weird. First thing we did, we went to NASA and we said, who does space-based solar power? And NASA looked at us and goes, we don't do energy. Okay. So we went over to the Department of Energy and we said, hey, who here does space-based solar power? And they looked at us like we were Martians. They had no idea what we were talking about. So we were standing out in the hallway at the Department of Energy, and Mike Hornacek looks around and says, I wonder who does space-based solar power in Washington, D.C. And we just happened to be standing in front of a mirror. And Pete Garrison said, hey, turn around. You're looking at them. And that was the moment that cinched it for us. We realized that we were alone in DC wearing cheap suits, because we were military guys, with bad haircuts, because that's what you get. And we had to try to convince people. But you know, we put together some facts that surprised us. We discovered, based on a meeting with some people from the Joint Staff, in 2006, 2005 and 2006, these are the years we had the data for, 70% of our casualties in both Iraq and Afghanistan were incidental to the convoy of petroleum in and around the battle area. The fully burdened cost of delivering 1 gallon of petroleum to a power plant was between $300 and $600 per gallon. $300 to $600 per gallon. Suddenly, John Mankin's numbers and that infrastructure started to come in. We sat there and started to think about this. The size of the US Navy is predicated on securing the free flow of petroleum in challenged waters. Wow, some of these numbers started to come into us that we were going to have to look at a different form of accounting if we were going to make our case for the investment in space-based solar power. So this briefing that we put together expanded out to, it started with 10 slides and it became 30 slides, then it became, massive. But we had information in there equating some data. We discovered that Douglas Adams was absolutely correct. The answer to life, the universe, and everything is 42. Based on all the advantages that the perpetual power provided by the sun in outer space, with a brief period of time when you end up in the Earth's nadir once a year, 1 square meter of solar panel on orbit equated to 42 square meters of solar panel on the surface of the Earth. Douglas Adams was right all along. He didn't even understand that. And I feel sorry that Douglas Adams passed on before he knew that he was right. 42 to 1. What is amazing about this is we were talking about super thin film solar arrays put up onto orbit that would be several kilometers on a side. Nuclear reactors worth of energy at the receiving site down here on Earth that could be fed into the electrical power grid. Now that is compelling. That was hugely compelling. And with multi-purpose waveform adaptable type of broadcasting antennas, we could spot beam energy to several different locations at once. I mean, these things are possible. We could easily see this. Now, the business case is a completely different animal. Well, okay. We presented this, and at one point in time, we decided that it was time for us to move along in our insurgency and kind of become legit. So I went to my boss, Mike Hornacek, and myself went to my boss, who was Major General Jim Armour, one of the best bosses I ever had. And we gave him our presentation with all of the compelling facts that we stacked up. And he looked at us, squinted his eyes, and said, "Thank you for the briefing." And Mike Hornacek left, and I went back to my little hovel of a cubicle. And I'm like, damn, I was hoping that we'd get more out of that. And then all of a sudden a shadow came over me. I turned and I looked, and it was General Armour. General, he goes, Coyote, this is too important to America, our allies, and the world. I need to have you do a report on that. I need a 120-day report, 4 months, brief me out on this thing, but I don't have a budget for you. And I need your plan in the morning. Yeah, okay. So I'm riding home on the train to Manassas, Virginia that night. And I'm thinking to myself, this is fantastic. My boss has given me direction to solve the world's energy crisis, get us out of Middle Eastern wars, get us out of, solve the climate crisis with carbon contaminating fuels. And give me your plan tomorrow morning, but you don't have a budget. Wonderful. So you can imagine I was a little despondent. So I go home and I'm sitting there and I'm thinking to myself, I gave Pete a call, Pete Garrettson, and we talked a little bit, and I went back in my little reclusive mode, and I typed out a couple of emails, and I realized, I got this thing called the internet, and I've got some friends, and they have some friends, and maybe I can put together a couple dozen people that we can work on this thing in our spare time, because we still didn't have a budget line, and budget line comes with man hours that you can commit and stuff like that. Well, I went in the next day and I told General Armour, I've kind of messed around with some Google products that are available for free, Google Teams, Google Groups. And I can probably pull together enough people that can contribute interesting things there, and we can build a report out of that. And he goes, Coyote, we do not do official government studies online in an unclassified venue. Then he sat there and he thought about it, and he goes, it does hit the budget. And I guess we'll have to do that. And he goes, if anybody and this was the first out of 2 times I ever heard any general officer say this. He goes, go ahead and do it. If anybody tries to get you in trouble, just tell them I told you to do it. The second general that told me that was General Steve Quast. And as a result of General Steve Quast's efforts, we got an independent Space Force. Amazing things are done with the power of yes, and not caring who gets the credit or who gets the blame. It's a wonderful thing. So I said, okay, I'll start a website. And I called a few friends, and they called a few friends. And holy cow, did that grow. What you see here grew into 6 websites. I started with the Google Groups with members only over here. By the end of the first month, I had over 100 people that were contributing to threads and complete discussions about space-based solar power. It was an incredible education. Now, this was a members only group. There was a problem with that, though, because we were just talking inside our own echo chamber. Like Jeff Kruken reminds us, we get it. We kind of needed people that didn't get it. And so I started a WordPress blog like you see over on the far side. Holy cow, we posted everything there that we were doing. We were doing this absolutely out in the open, and we let everybody know that we were doing this out in the open, and we let everybody know that we weren't doing this in an official capacity. We wanted to do a phase 0 analysis of space-based solar power. Now, what is that? That doesn't mean that we're going to do the deep technical analysis. It means we're going to look at whether or not this is technically feasible, what degree of financial possibility exists to get this thing funded, who would be doing it, and also what the strategic benefits would be to the nation. Now, we define security, not in terms of military operations, et cetera. We define security in terms of energy security, job security, environmental security, All of these things were rolled into our conception of space-based solar power. And this is why we wanted to do this public good with complete view to the public. Now, my numbers were growing on these websites, dude, for about a month to 45 days. I didn't get anything else done. I was managing these websites, and I'm not a website manager. I had to break my original Google Groups website, turn that into a plenary session, and break it into 4 different groups and get different managers to manage those groups. One, the business case. One of the leaders of the business case is here with us today, Eva Jane Lark, who did an absolutely brilliant job assisting in developing that website where people would actually discuss what was fiscally responsible and possible. This is really where the idea of public-private partnerships for developing not only space-based solar power in the macro, but to avoid the innovator's dilemma. All those little bits and pieces of technology along the way that build up. Because the innovator's dilemma is this: in a commercial market, every increment must generate a profit, a sufficient profit not only to feed your family, but in order to have something left over to invest in the next increment, etc. This is kind of where the public investment through government is going to be required, because we need to move fast enough to make this worthwhile. We can set in place all kinds of infrastructure that ages out before we're able to get there and monetize those types of investments. So government partnership appeared to be very necessary. The science and technical thing was led by Teddem, the evil Dr. Mankins himself. We called him Teddem by the power not vested in me by nobody that ever gave me any authority, because this guy knew so much about space. He's the guy that knows space-based solar power the best. You're going to get to hear from him, and we are so lucky to have him here with us today. He was taking over the science and technical management, and ideas were going back and forth in that group that was amazing. Our logistics is different than the business case. It's about how you secure the funding and the sustainability of the program over the long term. That was really interesting to us. What we did is we handed this over to a gentleman named Mike Sneed, who in his spare times at the Air Force Research Laboratory was helping and assisting with developing the logistics train. Policy and law. Now I'm sitting at my desk, minding my own business, and I get a telephone call from a gentleman. Hello, Coyote. My name is Art Dula. I'm the president of the Heinlein Prize Trust. What can I do to help you? I said, how would you like to lead a policy and law discussion? He goes, I might be good with the policy side on the business. That would be kind of handy. I said, well, that sounds fantastic. Thank you very much. And I get another telephone call from a guy. Hello, I'm an attorney here in Washington, D.C. I'm out of Chicago. I hear all of my cases in front of the U.S. Supreme Court. I know all the members of Congress by their first name. I charge several $1,000s an hour for my services. I'm like, I don't have a budget. He goes, I know. I'd like to volunteer my time to help your project. Sure. Thank you. I've got a place for you. I have a policy and law site. How about helping out there? And he did. And it grew to 200, by the end of it, 210 members. 170 of them became that first month core. And it was just amazing. Take a look at the numbers. Wow. I'm still blown away by that. And as our websites became more popular, public outreach demonstrated that it was critical. Jeremy Singer, who you see in the upper left-hand corner of this slide, is a journalist for Space News. We embedded him. We gave him complete access to everything that we did, not only the public website, which was not only public for us to have a discussion with the public, but when we found experts that we didn't know were out there, we'd pull them into the members only group, and we embedded Jeremy Singer into our group. And once a week, at least once every couple of weeks, he was putting out very important news stories that generated excitement about space-based solar power. The space show, led by David Livingston, I hope he is a regular in your life, listening to the great commentaries that people provide to him and his radio show every week. I also want to thank the Space Frontier Foundation. Jeff Krukin generously gave me some time. You standing there presenting to the New Space Conference in 2006. I got that wrong. It was 2007. And I'm standing in front of the public website I invited the complete membership of the Space Frontier Foundation to join us on our public website. And there is where we found a great deal of people that we brought into our private group. News interviews became critical, as you see there. And television, the Science Channel, the Learning Channel, started to put together some news stories about us that they wanted to feature us. And of course, the National Space Society, absolutely a critical resource in all of this, not just because of the size of their membership and the diversity of their membership, but they had such tremendous outreach to youth organizations, to international communities. These people a few years later would get President Kalam from India to do a presentation advocating for space-based solar power. We knew for a fact that Kalam brought this to the attention of the President of the United States twice on 2 occasions. Yeah, public outreach was critical. And these organizations, these people were key to making this happen. You know, one of the things that you had to have was a calling card, but we didn't have a calling card. We were just a bunch of 3 nugs, 3 military guys in flight suits that you see us there. And we started meeting at Irish pubs. Our office would become Irish pubs. Of course, that was always after duty hours, never during. And I would tell my boss, you know, look, we're going to be meeting at Irish pubs. He goes, Irish pubs? Why Irish pubs? I said, well, I can get a crowd at an Irish pub. He understood that. He said, okay, well, make sure everybody gets home safely. That's all it took. We started meeting at 4 Irish pubs across Ireland, up at Ballston, the 4 Courts of Ireland. In fact, they liked us so much because we were bringing them business that they ended up pushing a table up against a wall, putting up an Air Force poster, and they gave me a drop from my computer. They even gave me a can for pencils and white butcher paper. We're up there by DARPA. We'd get those guys out, and some of the contractors that supported the National Science Foundation, Paul Verbo, great skills and talents, people that loved us, that were passionate about it, that knew back in the 1960s when Glaser introduced the concept. Actually, it was introduced before that, long before that, by Robert Heinlein in some of his articles. Heinlein said that in order to become a spacefaring species, you need to do a few things. 1, harvest the power of space. 2, harvest the resources of space. And 3, settle off Earth. We were working on that first one. So Art Dula joining our effort was just such a treasure. That was a gift that fell into our lap. You see here, we're drinking iced tea and we're discussing space-based solar power. This is how we rolled. It was exciting. Holy cow. Everybody wanted to talk to us. People, except inside the Pentagon. Nobody there wanted to talk to us about this. Everybody had their project for today, and they weren't going to stop staring at their project for today to think about anything beyond. This is difficult because I was the director of Future Concepts. Trying to get anybody to think like 20, 30, 40, up to 2050, that was impossible. It was hard. So we did. We collected all the information that these geniuses were providing to us. I mean, literally, I had 210 of the finest minds broken into different categories, solving the space-based solar power problems incrementally as we saw them in 2006, 2007. Amazing. We identified the fact that based on the losses that our military had incidental to petroleum, that yes, space-based solar power absolutely presents a strategic opportunity, not just for the United States, but to our allies and the world. We were very clear about this. We didn't care who did space-based solar power as long as it gets done. Because if anybody does space-based solar power, it makes the rest of the world's diminishing resources available to the rest of us at a lower demanded market price. We sought the ability to incentivize job creation in the space sector. We anticipated at one point, and given the numbers, and Pete did this on the back of a postcard or envelope, about 1.2 million jobs could be created by building all of the bits and pieces of the technology to do space-based solar power. We're talking about the large gossamer structures on orbit that need station keeping, positive control, and safety assurances. The types of things, if you can do space-based solar power, we can do virtually every type of role and mission that we have always dreamed about to get us there. Wow. Now, we were also very keen. We had a number of companies that were opportunists that were hanging out with us. And we made sure that all of our discussions were held in public so that they couldn't declare proprietary access to that type of technology. I'll tell you a short story. Back in the First World War, the United States could not produce an aircraft because the Wright brothers held half the intellectual property and Glenn Curtiss held the other half. As a result, we had to fly British and French aircraft in the First World War. Now, after the First World War, the federal government goes, okay, that was ridiculous. They had a payout. They gave the Wright brothers, I think, $125,000 because there was two of them, and Glenn Curtiss got $100,000, and they made all of that technology public domain. We made sure our discussions were in the public domain so that those vital pathway bits and pieces of technology, or the way that you would do it, would forever be in the public domain, so that we could not get locked into those types of lawsuits, although we have discovered lawsuits is oftentimes just a way of life. Just, it's what we do. We also recognize that space-based solar power is extremely difficult, but it's more possible now, and it's becoming ever more possible with every passing day. We truly believe that we needed a government proof of concept demonstration. And we also recommended space-based solar power required proper organizational leadership. Somebody needed to be put in charge, and that project needed to be their baby. We needed a Rickover. Rickover developed the US nuclear submarine program during the Cold War. He was the man. Nothing was built. Nobody was hired without going through Rickover's personal review. You need a Rickover to manage space-based solar power, to get it done in a time reasonable way, and in a way that moves technologies to the commercial providers, because the federal government has got no interest in being a space-based solar power provider. We sure do want to be a customer, and we sure wanted the government to step up with pre-purchase agreements to make good on all that type of investment that will be put out there. We also believed that broad interest in space-based solar power existed outside of the US government, with our allies and with the rest of the world. Think about what providing space-based solar power to sub-Saharan Africa could mean, or to the United Arab Emirates, Saudi Arabia, the ability to drive desalination plants and to turn those deserts into brilliant oases of verdant green production. These are the types of things that space-based solar power makes available. Wow, I get so excited about this. I love this. Oh God, this is great. So here are our recommendations. And I'm not going to list through these because I've kind of covered them already. The bottom line is we do seek public-private partnerships to go forward, but we need the government to step up and do it. We need the government to step up. We need the commercial market to let them know that we are here for the government and we want to work with you in an open and transparent manner. This is not, see, here's part of the problem. There are communities out there who, just because this started with a bunch of Air Force guys, this must be a weapon. This must be designed to hurt people. No, it's not. Absolutely not. That's one of the reasons why we did this study broadly open. Every word that we ever did, well, except for some of the discussions in some of those Irish pubs, it is right out there for everybody to see. We have no chicanery, no underhanded, no trickness. We are happy to have anybody in the world take a look at this. We're delighted that the National Space Society has what they call the Space Solar Library, where virtually every important study and research that's gone into this project has been posted. I encourage you to go to the National Space Society's Space Solar Library. And, we had to do a rollout. Fabulous rollout. Buzz Aldrin came to help us. You see some of the key figures here. And these folks were absolutely essential to laying out our report, our study, absolutely done in public at the National Press Club in Washington, D.C. Next to Buzz, you see up here in the right-hand corner, a Marine. You have to have, we insisted we put him in his all-North uniform because that's kind of resonate. Paul Plato Damphus, who later would join the Caballeros. You see our own Tetum, the evil Dr. Mankins down below. He points out that he only has a master's degree. No, dude, I have conferred upon you by no power invested in me by no authority anybody ever gave me. You are a doctor of space-based solar power, sir. You see Greg Whitesides up there on the top. He, of course, was executive director of National Space Society at the time. Now he's with Virgin Galactic, I believe. You see Charles Miller in the middle of the right. Charles Miller represented the Space Frontier Foundation, who gave us our first platform to actually speak to the broader community. And you see Mark Hopkins, who is the institution of the National Space Society. And we're so happy for the work they gave us. The report was a stunning success. It was time for tea and medals, ladies and gentlemen. We received at the 2008 International Space Development Conference, sponsored by the National Space Society, the Pioneer Award, which I'd like to point out was awarded to the entire space-based solar power team, not just us. It did not include just us. It included 210 people that made it even possible. They were the geniuses. All we did was bind and tie it up and print it out. There's two people here today, Eva Jane Lark, who I mentioned earlier, and Dallas Bienhoff, who did key edits and reviews on the document before it was ever published. And I want to thank them both from the bottom of my heart, our hearts, for the good work that they did and the passion that they put into it. Because space-based solar power, it becomes obvious. You see over here on the right-hand side, the four of us standing in front of a model of a space-based solar power design that was actually operational. It could use the lights in that room to concentrate the power and broadcast that power via radio to a receiver and demonstrate that the concept worked. We even had people at that conference at that time who thought it was technically unfeasible. We said, would you like to come over and see the model? I love this concept. It is just so great. I'll tell you that a year later, based on the success that we had, I led a project at the US Air Force Academy called the One Light Bulb experiment. What we wanted to do was do space-based solar power in reverse in order to stimulate people's thoughts about the concept. We wanted to put a satellite up in low Earth orbit with a light bulb on it. And we would simply broadcast energy from Earth up to that satellite to illuminate that light bulb to verify to people through telescopes that space-based power beaming works. Now we're doing it in reverse. You have a hell of a power problem when you're broadcasting from Earth up to a satellite. So that group of people, dude, we had Ivan there, we had Marswell, we had evil Dr. Mankins, Dallas Bienhoff, I think you were there. We had, dude, when we went out to dinner, I mean, those guys were the future concept shop for our national space program for a long time. It was terrific. John Kennedy said one time that, sitting with all these geniuses around the White, he was there with Einstein and Fermi and all these guys, that such brilliance hadn't been there since Thomas Jefferson dined alone. Dude, for me to be a fly on the wall while those guys got together and just talked about what could be. We live in a treasured time. We live in a treasured time. Those guys are heroes of mine. So we turned the experiment around. We said, look, let's put a satellite in low Earth orbit, small satellite, tiny. So let's get a free ride on a ring up into orbit. The satellite will collect the energy, store it, and then it will broadcast it down. Because broadcasting down saves a whole lot of energy because of a phenomenon called shower curtain effect. It's kind of like when you're standing next to a swimming pool, you can see somebody underwater, but when you're underwater, the diffusion causes you so you can't see quite so well out of the water. It's the same principle. Well, anyway, we tried to do that. We priced it out. We did a good build. It was going to cost about $10 million. We had the United States Army was going to make the receiving antenna. We had people lined up to actually pay the $10 million. And then the Chief of Staff of the Air Force intervened and directed that we would cease and desist any discussion of space-based solar power, that it would be a threat to the Air Force's laboratory system and to our national laboratories. The Air Force had to press ahead with the F-22 and the F-35, which had much higher priority in that organization than space-based solar power. And we had specifically asked that the Air Force have nothing to do with it at all and not spend $1 or one research piece of time. We wanted it done in a public-private partnership with the commercial sector taking the lead. And that is how something funny happened on the way to space-based solar power. I'd like to just give a little bit of a finishing story. September 2007, I left Washington, D.C., and I went over to pursue my PhD in the United Kingdom. The first thing I had to do was buy a used car. So I went to a used car dealer, and he said, "You're a Yank. What are you doing here?" And I said, "Well, I'm in the Air Force. I'm getting ready to start a PhD program." He goes, well, that's interesting. He goes, well, what do you do in the Air Force? I said, well, I used to fly, I did missiles, do space, but what I really do is space-based solar power. He goes, what? Space-based solar power? I said, let's go online, I'll show you. So I brought him to a couple of our websites, and some of our friends, Mavic Studios up in Canada, had put together videos on this. People were volunteering and giving us treasured service to advance space-based solar power. What a gift. And so I showed him a couple of the videos, and he goes, stop. Hey, all you guys, he had like 6 guys that worked at this car dealership. They all came and they stood around him and they're watching it. And he goes, that's what this guy does. And then they showed a little video of me doing a news interview about it. And I'd already negotiated the price of the car for 3,500 pounds. And he goes, I can't take your money. He goes, if you write the check, I was already writing the check for 3,500. He says, I'm not going to take a profit off it. Write that for 3,000. And that's what that car cost me. He even showed it to me. I'm giving it to you at cost because this is too important. And according to John Mankins, the evil Dr. Mankins has confirmed that was the first positive cash flow that ever came from space-based solar power, was buying a used car in the United Kingdom. And now you know the rest of the story.
Coyote, that was wonderful. Thank you so much.
Amazing, Coyote. I want to point out when you were writing this and you were interviewing, and Charles Radley was on the call, is on the call here too.
God bless you, Charles.
My dad was in Iraq, one of the people that was one of the convoy managers. And so when you were writing this thing and we were talking about elevators as maybe alternative systems for building this thing, it was very, very near and dear to my heart that you were focusing on the convoys, because my dad took shrapnel. He didn't die, but he took shrapnel from that exact experience. So, you really brought that home to me back then, and it reinforces it now. So really, truly amazing, amazing tech.
I went and I visited some of the wounded and burned soldiers, sailors, and airmen that were at Walter Reed Hospital. And as soon as I met them, this became conviction.
Personal. Yeah. All right. Tremendous. Stick with us, sir. We're going to pass it over to Lee, who's going to introduce Pete. Thanks a lot, sir.
Yeah, I actually had a quick question for Coyote as well. I obviously immeasurable costs there that you were just talking about, but I love that you ran the numbers against oil. Can you give us a sense for the break-even oil price with the cost of space-based solar?
That's an interesting thing. That's a real interesting thing. The short answer is no, because it changes.
Yeah.
No, because it changes. Sometimes there's an invaluable quality of energy. Think about what happened in Katrina, where New Orleans became flooded. The power grids went down. Nobody could get those power grids back up because the hurricane moved just north of the city and stalled. The ocean fronts were destroyed. You couldn't port there. But we had the ability. If we had the ability, we would have been able to broadcast power and bring the energy grid back up so they could recover far more quickly. Think about what happens in places like Haiti, Puerto Rico, et cetera. These are places that are home or close to home, where think about the rolling brownouts in California. Think about when cities go dark and, violence breaks out in the middle of the night because of it. If we could provide the type of energy through spot beams so that places like, as Texas experienced this year, those rolling brownouts don't need to happen, because we've got an adaptive, supplyable form of energy that is safe and clean. I think it was, I can't remember a great gentleman's name who helped us a great deal. Gary Olson, who I also saw on here, was one of the advocates for this and made this argument. Energy is like a diet. There's some things that we eat that have high energy, like meat, but it also comes with a lot of bad stuff. And like petroleum and coal, it's fabulous, lots of energy, but it comes with some bad stuff in the form of like carbon emissions, et cetera. Space-based solar power gives us a solution for safe, clean energy. And it's just a fantastic opportunity for us to pursue. Going back to that petroleum question, The first meeting that we had, that the Caballeros had, was with the Greater Houston Partnership. Our good friend Jeff Kidder, Jeff Kidder at the Marshall Institute in Washington, D.C. at the time, hosted the Greater Houston Partnership for us. We met with their representatives, and we were expecting guys in cowboy hats and stuff like that. It's not like that. They're all financiers and lawyers that manage it. We had Royal Dutch Shell, Exxon, Sunoco, all these other companies whose names you know. And we said, we would like you to think of yourself as energy companies. And we think petroleum and coal, because we have big coal there as well, and coal is going to become the tobacco of the 21st century. You're going to need a get out plan that leaves you in place being energy companies, with your lobbyists still in place, with your executive board still in place, with all your workers transitioning from petroleum and coal to being space-based solar power folks. Your companies stay intact, your profit lines, all of your customers remain the same. You just get into instead of drilling down, you drill up. They weren't interested in it, all save for one, British Petroleum. British Petroleum goes, yes, this is for us. This is exactly where we want to go. We have to go to places in the world where we don't like going in order to get a petroleum product that takes us so much pain to get back here to the country where we use it. We really would like to go space-based solar power. And then they had the disaster in the Gulf, and all of their investment capital went into environmental remediation for that huge oil spill that happened down there. Yeah. And I haven't heard from them since. So I'm sorry if that's a long answer to your question, but there you go.
A good change to beyond petroleum. All right, well, thank you so much, Coyote. We look forward to chatting with you more in a few minutes. Pete Garrison is here to break down the current and future landscape of space-based solar power. A senior fellow in defense studies at the American Foreign Policy Council, Mr. Garrison is an independent strategy consultant who focuses on space and defense. He has 33 years of experience working for the Department of Defense and served his country in the U.S. Air Force, including as director of the Space Horizons Task Force at the U.S. Air Force Air Command and Staff College. He is currently working on his PhD in public policy and has a master's in aviation and human factors from Embry-Riddle Aeronautical University. He is a former member of the National Space Society Board of Directors, a thought leader in the area of space development, and he's currently writing a book on the Great Power Competition for Space Resources. Pete, you have the screen.
Thank you so much. Can you guys all hear me?
Yes, and we can see your slides as well.
So, what a wonderful presentation by Coyote. It brings back so many memories, and it would be nice to be young again and be going through that all over again. At the last minute, I wanted to add, I used to start all my presentations on space solar power with this quote from Marshall McLuhan, that only puny secrets need protection, that big discoveries are protected by public incredulity. And so much of the conversations that we had about space solar power were fundamentally about an inability to think big enough. So I want to talk about space solar power, and I want to first of all, just put forward that in my view, this is a different conversation, right? This is not just a conversation about a space exploration program. It is not just one of many business ideas, right? This is an idea that links fundamentally to the chances of humanity to survive on this earth and flourish both here and beyond. So I want to kind of start with, where is the current conversation today? So we have had a change of administration, and astoundingly, the major pieces of US space policy have stayed intact from two extremely different administrations. They have kept the Space Force, they have kept the NASA Artemis program, they've kept an awful lot of the space policy in place, and they have kept the National Space Council. And now we have a new vice president that is about to take over that. And of course, one of the focuses is climate change and business. At the same time, we have a paper that has recently come out, but from aerospace, and I view that as significant because aerospace is a trusted partner across both NASA and the Department of Defense, saying that space solar power is a near-term investment decision. And I truly hope, just to be upfront, that space solar power will be one of the first big ideas considered by the new National Space Council. The most recent report that came out on the government that mentioned space solar power was the State of the Space Industrial Base report. And I think Michael's got all the links for these. But it essentially said that we've got no identified coordinated vision and roadmap for space solar power. And as a consequence, we are not postured to compete. Now, at the same time, there was a process going through where one of the other speakers in Conversations for the Future, Dr. Namrata Goswami, had given a presentation to the U.S.-China Economic and Security Commission. They had published their report last year, and then they got it into the law for this year that says that the National Space Council shall do a comparative report on the U.S. and China, and specifically look at the viability and environmental impacts of space mining, on-site exploitation, and space-based solar power, as well as the strategic interests in cislunar space. And I think this is, fairly major. Now, just to be upfront about what I would like to see, come out of this. First of all, I would love to see a space policy directive come out of the new National Space Council, specifically on space solar power. I'd like to see another one come out on manufacturing objectives for the Artemis lunar base, focused on production of materials for space solar power. I'd like to see a presidential finding on space solar power and space resources in Defense Production Act Title III. And of course, I would like to see passage of the Space Corporation Act that would create a way to fund not exploration, but actual development and infrastructure. And that requires government-sponsored research portfolio of many different approaches to retire technical risk. It will require COTS-like private partnerships to create industries, not just technologies. And a big part of that is for the government to be an anchor or lighthouse customers, as well as to reduce the cost of financing and enable patient capital off the federal budget through things like bonds, and to be able to fund and expand existing programs, of which you'll hear me talk about two. One is Air Force Research Lab SPIDER, and the other is a Secretary of Defense program run out of Naval Research Lab that's not called PRAM-FX, but that's its most recent fruit. So I want to talk, first a little bit about space solar power and why it's so significant, right? You have to ask, what if there was a chance to do something truly, truly ambitious in both energy and space? What if you had the ability to unlock really unlimited renewable energy? What if it was autocatalytic, meaning it would build many other infrastructures? What if it could mean as many as 1 million new jobs and a prosperous green future and many things beyond that? Would that not be worth doing? And in case no one's explained it, right, the idea of space-based solar power is this concept for a revolutionary energy system that involves placing into orbit stupendously large orbital power plants, kilometers across, which collect the sun's raw energy and beam it down to the point of need on Earth. And in theory, space solar power could scale to meet all humanity's energy need, providing virtually unlimited green renewable energy to that energy-hungry world. Now, let me just pause for a minute to talk about why this vision is exciting. At this point, probably, even if you are not a believer in climate change, you recognize that there are environmental costs of having a combustion economy, and that there is utility in having electricity. It's easier on your lungs, it's easier on clean air. If you're concerned with carbon, you're concerned with the amount of carbon that's being put into the atmosphere. But the problem with doing anything in renewables is that they're intermittent. They're not appropriate for city baseload energy. And so today, if you want to power industry, if you want to power our, computation systems, which are approaching 10% of our electrical bill, if you want to power cities and industry, you've got to have 24-hour power. And terrestrial solar and wind struggle with that. Nuclear power has trouble scaling because of its need for cooling water. Fusion would have the same problem. So here we have something that if I just take those solar power, those solar arrays, and if I could magically move them up into geostationary orbit, they're in the sunlight 99.9% of the time, and I can beam it down with radio waves to where I would need it. So when you hear people, talking about trying to use space to green the earth, to move, like Jeff Bezos says, to move industry off Earth, or the need that you might need to, to allow the developing world to have the kind of lifestyle that we are enjoying today, right? You don't have to do that at the cost of the Earth. And in fact, I'll talk a little bit about how you could use space-based materials in order to construct it. So this creates then a competitive vision, because we're not just talking about building one. And in the lower left, you see a picture of John Mankin's Space Solar Power Alpha satellite, a modular design. And you can see, he had a collaboration with Justin Lewis Weber, who had looked at how you could use self-replicating systems on the moon to supply the material to build that. But we're not talking about just building one, right? We're talking about building, 3,000 of these that scale to the approximately 55 terawatts of energy that a fully developed world of 10 or 11 billion people would need. One that would allow us to be 100% green, completely off fossil fuels, with the kind of power that our civilization actually needs. Now, how did I actually come to this? Well, it was in 2005, and I was playing a war game sponsored by the great Andy Marshall, who has now passed. A wonderful book about him, Last Warrior. And I had become very concerned about energy as being a potential trigger for great power conflict. And at the same time, I was enjoying my job as Chief of Future Technology, where I was sort of the long-term trends and technology scout for Headquarters Air Force. And I came into contact with people from the X Prize Foundation and Brad Edwards who had just written a book on the space elevator and had gone to the STAFE conference. And I kept hearing this idea of space solar power. And I was doing some research. I looked it up. I found out that at that particular moment in time, and for perhaps the next 3 or 4 months, there was a program at NASA run by John Mankins. And so I asked John to come out and brief at the Pentagon. And John introduced me to this idea of space solar power. And I just thought it was beautiful and aesthetic. And the idea that we could innovate ourselves out of the problems of energy scarcity, out of the problem of sustainable development, out of the problem of great nations competing over power, and into this world of massive in-space manufacturing was amazing. And it stroked my ideas of ambition because, just to give you a sense of comparison, right? That satellite you see at the lower left, when you compare that to the International Space Station, that's approximately 24 times heavier, approximately 100 times longer across, and about 50,000 times more power, right? The International Space Station is about 420 metric tons. It's about 100 kilowatts of power, and it's about 73 meters across. A solar power satellite is like an aircraft carrier. It's 10,000 metric tons. It's producing not a megawatt, but at least 1,000, 2,000, 5,000 megawatts, so gigawatts. And then, it is like 7 kilometers across. And you're not going to build just one of these, right? You're going to build on the order of 3,000 of these in geostationary orbit to give the world the kind of amazing infrastructure that it deserves. And to me, this really spoke to me as a vision that was worthy of the ambition of our nation, right? Something that is orders of magnitude larger and more significant than what was done in Apollo, and something for which all the pieces are there, right? There's nothing cosmic about what you see there. That's just rockets launching components that are essentially, lightweight reflectors like you'd buy in a birthday balloon for your kids, with transmitting antennas that are like in your cell phone, and solar arrays like you might have on your house, right? I mean, yes, they're more sophisticated, but in truth, those are the basic pieces, right? Rockets, mirrors, solar cells, and radio transmitting elements. So it's not like fusion where we don't understand the science. It's more like you were a kid and you had built your first mud dam, and then somebody wanted to hire you to go and build the Hoover Dam. This is a massive, massive amount of engineering detail work, but it's all based on principles that are well understood. So you've already heard this wonderful story about, how four of us and then a huge army behind us sort of did the very first crowdsourced open source study. And one of the things Coyote didn't mention was that he also gave the first ever virtual press conference in Second Life. But we provided this this study, and we really hoped, this was sort of we had a transition. We were able to at least get in and stroke the interest of the White House, but not enough to get action. And it was the same repeated in the Obama White House. We thought we were going to move forward more than once. There was a wonderful white paper that Charles Miller and the Space Frontier Foundation had on change.org. We thought that was going to pick up. There had been a study at the time led by Air Force Research Lab, sponsored out of my office, that unfortunately was not continued, actually out of fear that the Obama administration might like it and create an unfunded requirement for the Air Force. And then there was a later opportunity later in the Obama administration to start a partnership with India that came within one vote of moving forward, but it didn't. And I won't repeat sort of what happened here. But Michael, are we able to play this pitch video? Do I need to surrender the screen here?
Yeah, pass it over to Fabio, please. Thank you.
So, I'd like to thank Chris at Mathic Studios for having put together this, but we tried, in order to sort of bring together our thinking at the time in this little pitch video that we have. Nope, not that one. This one should be space-based solar power, a solution to the carbon crisis.
Okay, working it. Keep talking. We'll get there.
All right. So let me take back the screen for a moment. Do you need that link again? It should be in the chat.
I've got it right here.
Okay.
You know what, Fabio? I will cover it from here. I'll just run it. Is it full screen?
Yes.
Okay. Do you have sound?
Renewable energy sources scale large enough to displace fossil fuels and provide constant power. Space-based solar power
It's very low sound.
sun in space and transmits that power 24/7 to antennas on the ground,
Okay.
known as rectennas. Building them economically requires low-cost transport into space. Recent developments from SpaceX are a start, with additional technologies on the horizon that will continue to decrease both cost and risk in the future. The system relies on an in-space electric transportation infrastructure to move material from low Earth orbit to a construction orbit. Once complete, about 10 power satellites per year can be built. However, in order to have a rapid effect on atmospheric carbon dioxide, it is necessary to scale up to a high production rate as soon as possible. A rate of 315 5-gigawatt satellites per year may be possible, which would make fossil fuel combustion unnecessary within 15 years. At the maximum rate, we are moving 15 million metric tons to low Earth orbit per year. This represents about 1 million flights per year, which is equivalent to only 2.7% of the commercial airline flight rate. Current projections for CO2 show an unavoidable conclusion. We are in trouble. Inaction will result in billions, if not trillions, in negative impacts to the US economy. While moderately expensive to start up, a space-based solar power system will have a concrete and permanent impact on global CO2 production. It will ultimately bring CO2 production to zero by replacing oil and natural gas with synthetic fuels. It also self-finances after phase 2, while providing a significant return on investment for the initial outlay. At approximately 3,000 satellites, or 15 terawatts of delivered power, we will have replaced the need for all current power sources on the planet. Fossil fuels will no longer need to be burned, and high-cost alternatives can be avoided. There are additional orbital slots for several times as many satellites, leaving room for further growth and dedicated power for actively removing carbon dioxide from the atmosphere. Much like the transcontinental railroad built in the 1800s, our satellites represent a new opportunity. Where the railroad provided a transportation infrastructure and contributed to national security, space-based solar power will provide energy infrastructure, contribute to international security. By providing a global energy solution, international pressures that lead to conflict will be eased. The standard of living for all can be increased without the environmental pressure of fossil fuels.
All right, you can give me back the screen.
Right on.
So while I'm bringing up my screen, I see a question from Brett about what happens if the beam misses where it's going. So the way these actually work, and I'm sure that John Mankins would be a better person to answer these questions than me, but essentially, you have a pilot beam that comes from the Earth that is required to sort of time and focus the beam. And then, because these are electronic circuits, like in a modern fighter jet radar, we're talking about the ability to adjust or realize something is wrong on the scale of milliseconds. So, work didn't stop. I went on to spend 1.5 years in India, where I wrote Sky's No Limit, talking about how we might be able to do a partnership. General Santee, who took over space policy, asked me to sort of lay out the strategic case for space solar power in Strategic Studies Quarterly. And of course, several people were involved in the Fast Space Report, which basically laid out the case for the United States to invest in reusable launch vehicles to kick off this virtuous cycle, and the decreased cost that comes from industrial learning and high flight rates that you see on the right. We basically laid out the vision that has now become the Space Development Agency vision for proliferated low Earth orbit command and control. And we discussed, how this virtuous cycle could lead to cost-effective space solar power. And this was, of course, we started the report before the true successes in reusable launch. I should also note that 2 of the other participants in the study, Mike Sneed, has written Astroelectricity and has a number of truly terrific educational videos on why the United States really has to turn to space solar power. John Mankins, who you'll hear later today, has the wonderful book on the case for space solar power. Paul Jaffe led a team, to look at the opportunities and challenges for beaming to remote installations. That was very helpful in creating the two small programs that the United States has today. And of course, if you want to hear more about the geopolitical implications and the broader than the book by myself and Namrata Goswami that just came out, Scramble for the Skies, covers space solar power in depth. There was also an effort called the D3, the Defense Diplomacy and Development Challenge, that was run by the State Department, the Department of Defense, and USAID, where many teams and many ideas competed. And a team that Paul Jaffe and I put together actually swept that, winning, most of the awards. And you can understand why, because an idea like this is amazing for international development. It's amazing for US security, and it's amazing for diplomacy. If you could truly be leading the world towards, infinite green energy that solves so many different global problems. Paul, of course, has done, magnificent work. He had a small wireless power beaming experiment broadcast for STEM education on the International Space Station. He recently orbited this piece of hardware up here, PRAM-FX, on the Department of the Air Force X-37B space plane. And he's done this PTROL, or power transmission over laser. And of course, you will hear later on about the very ambitious attempt by Air Force Research Lab to break the 1 meter barrier with ultralight sandwich array modules. So something similar to what you see on the top right here, but ultra thin. But, of course, another consequence of this report that Coyote and I did was that it interested our competitors. And so China has this very coherent vision that they want to exploit Earth-Moon space, using lunar resources to construct solar power satellites that would beam energy back to Earth, part of this larger project of Chinese rejuvenation. And they have a wonderful video that won an international competition that I will post in, showing their design for in-space construction of this 11-kilometer across thing. And of course, they recognize that the moon is crucial for sustainable development, and whoever conquers the moon will benefit first. So, they have a complete roadmap with multiple different designs, and they are funding a significant sort of development park with major infrastructure in order to advance space solar power. On the other end, we also have domestically, probably not everybody caught this, but when Jeff Bezos unveiled Blue Moon, he had up in the corner a news clipping, and the news clipping was of his first interview, where he said that, if he were a space entrepreneur, he would construct solar power satellites to make the world peaceful and affluent through cheap, abundant energy. It wasn't what he chose to highlight in the public, but it was there. So it may hint at his longer-term ambitions. Space solar power also creates an industrial base that unlocks unbelievable things that you probably could never purchase on your own. I mean, just imagine that today, we spend less than 0.5% of our federal budget on all the civilian space programs, right? It's a tiny fraction. And that's, maybe somewhere around the order of 30% of GDP. So we are spending, less than 1/3% of GDP on space. But energy is at least 8% of global GDP. And so, $100 trillion economy means that somewhere on the order of $10 trillion goes for energy. And if you were doing most of your energy from space, you would have an annual revenue stream for your space program on the order of $10 trillion, which is many, many orders of magnitude larger than what we can afford on the public budget. Once you have created the ability to do massive in-space manufacturing, massive space logistics for these 10,000 metric ton satellites, you now have an infrastructure that would allow you to build real estate, large space stations. You have the infrastructure you would need to send interstellar probes to see what's on other planets, including to be able to build large generation ships within reasonable time cycles. You have the power available to, burn up or deflect asteroids, and you have the infrastructure you would need to do, complex management of the Earth's biosphere to maintain life, like the proposed Sun-Earth L1 sunshade. And all this contributes to, broad national power. So in the same way that, the discovery of replaceable parts for a production line in petroleum and internal combustion engine, few people could have foreseen how those simple parts at the top could scale to be this unbelievably massive infrastructure below that gave rise to national wealth and power, and upon which our platforms for national defense rests. Many people have difficulty seeing how these simple technologies, of RF antennas and solar arrays, rocket ships and mirrors could lead to something infinitely vaster than what's contemplated today. Many things have happened since this was first considered. Of course, reusability and high launch tempo completely alter the cost of launch, but satellite cost, and satellite mass has come down. And so the ability to think about these types of reductions, these slides are from Paul Jaffe, open up a world of possibility in terms of making this not a technical possibility, which it's been for many decades now, but an economic possibility. You may hear a similar point made by one of our later speakers, but there's already an amazing proof of concept of how this can be done. So Starlink now has launched in the last year 1,300 satellites, each of which has about 6 kilowatts on board. And if you combine that together, that is 7.8 megawatts of power in space put up by one company in 1 year with an enormous reduction in cost. And so, again, a slide from John just showing what industrial learning curves do to the individual cost of something. So you cannot think about scale and the chicken and egg problem the same when you're talking about something this massive. And of course, we've talked about reusability. Let me just get out of that there. And of course, what's coming, with potentially extremely low cost for Starship. This is sort of what we had looked at the time, is that, we could imagine, from where we were then with fully reusable systems, first a 3x reduction, and then depending on the number of launches. And some of this, launch may seem, crazy to people today, but it's such a, tiny piece, drop in the bucket compared to what we do in transportation, in airplanes, on roads, and on water, that, getting to, a daily launch, of about 300, plus launches a year, that gets you to a kind of 10 times reduction, not with any kind of, technology change, just in the amortization of your overall costs, is pretty exciting. You get down to the cost of propellant, which might be somewhere around, $25, per pound. And all this enables this broader cislunar econosphere, of being able to, move with reusable in-space vehicles to and from the moon, and to be able to source resources from the moon, to be able to do these kind of advanced in-space manufacturing and production that could allow entirely different types of designs. And of course, to access materials to be able to do this and build it in space rather than bringing it from Earth in, say, the second or third generation. Just to give you a sense, right, one asteroid Apophis would allow you to build 150 solar power satellites in terms of mass. And there's the possibility here of robots building robots and electromagnetic launch from the moon, other large infrastructure that could be there. And it's going to be necessary, right? If we have a societal goal of trying to cap carbon, we have to have something that can scale and can scale rapidly. And I think space solar power offers the possibility of doing that, as well as an amazing possibility, for jobs. I think this was 5 million direct jobs that was in the IAA report, if I remember right. And if you look at markets, this was Ivan Becky who done this for the NDU space power study that Coyote and I actually met in this. But this is a logarithmic scale. And the important thing to realize is this is the amount of projected up mass from Earth to space. And the biggest line there, the one that dwarfs everything else, is this green line, and that's solar power satellites. So of all the possible markets that we can imagine today that, let's say, aren't, O'Neill colonies in the long term, this is really the big up mass possibility. John may show you a slide similar to this, but just showing that if you do apples to apples comparison of space solar power, it is, as Coyote said, it's an amazing difference in the effective power to the grid. And, John may cover this too, just how much a single power satellite could cover in terms of power shifting. And then, in terms of carbon, it's amazing. Not only is its energy payback in weeks, but the carbon you have is just to manufacture the solar power satellite, and after that it's gone, and you can use that to bootstrap. So it is truly friendly. And of course, this aids as part of this broader interplanetary, multiplanetary aspiration. Why does this work? Well, the sun puts out this amazing amount of energy, of those yotta watts of energy, 120,000 terawatts hit the Earth's surface at the equator, at the equator in peak sunlight, you get like 1,000 watts per meter squared, but you get nothing at night in the same place. And of course, you're going to be reduced by seasons and weather, so that most temperate places like the United States are getting just 125 to 375 watts per meter squared. Now, if you could just move that up into space, you now suddenly, collect 9 to 11 times as much, flux over time. And then you have much greater availability. You don't have to worry about, spring and summer and weather and all that. And you beam it down to these rectennas that can be, multi-use. You can have, agricultural, pastoral underneath. It's about the size of a small airport. The land is still good for agriculture. The beam is shaped in a way such that it's like somewhere on the order of 1/6 the intensity of sunlight in the center, and tapers off to, safe levels at the edge. And because it's collecting all the time, not just for 20% of the day like a solar power satellite is, it ends up being like at least 6 times more power, even without the specifics of weather or back and forth. So again, the significance: 24-hour baseload appropriate power. Almost no renewable can say that. Maybe sorry, I'm losing my my train of thought here. So a giant hydroelectric could do that, but we just don't have enough hydroelectric opportunities. So it's urban appropriate. It's got the scale, it can displace coal, that can reduce the need for nuclear proliferation. And most importantly, it can scale to all global demands 6 times over with just the georesource. So that's why it's significant. We had we had calculated that, AFRL had calculated that the resource was on the order of 330 terawatts. And we wanted to sort of give you a sense that if you were to you wouldn't do it this way, but if you were to build, a 1 kilometer band around GEO, the amount of energy you would collect is the amount of energy that's in all remaining oil in all resources, which is, just an astounding amount. So like I said, super simple components, things that we're very familiar with. It just takes a lot of them. And let's see, some of these are there. I will say, Michael, should I give up the microphone here, or you want me to keep going?
Let's bring you and Coyote back in, and we've got about 10-ish minutes to chat before General Quast gets here.
But I am really excited to hear the rebuttals to Musk's arguments. That'd be helpful.
All right, then let me just provide those really quickly.
So I'm going to start with just asking, it's been nearly 15 years. How are you feeling now? Right? You planted this flag. You got a lot of people behind this idea. You took some arrows in the back for pushing the idea. How are you doing now?
Well, I'm more optimistic than I've been in the past. I think what has been done what the first report did that Coyote and I collaborated on was to move the idea out of an extremely narrow group of people, basically just the National Space Society and the Space Frontier Foundation, into the broader popular consciousness. And we've started to see, press stories on it. We started to see this become sort of part of the popular consciousness. We utterly failed with 2 administrations to get any real action taken forward. But for the first time, we have congressionally directed work that in its first year was still a pittance compared to the potential payback, but it was finally in the tens of millions. And that work, though at a reduced rate, continues today. And the other thing that has happened since is there's been an international renaissance that hopefully John will talk about, and a renaissance really around sort of the traditional allies and members of the Quad and the Pacific. So the fact that we now have an institutional home, this was the big problem. We couldn't get the DoD to be interested in it on its own because they viewed it as a distraction from core warfighting and not the security they wanted to do. And we couldn't get NASA to be interested because they thought that's why we had a Department of Energy. And we couldn't get the Department of Energy interested because they thought, well, that's why we had NASA. And of course, we didn't have anything like a space corporation that could look at it like infrastructure. But at least right now, Congress, sort of honored the Space Force by giving it, putting the money in the Space Rapid Capabilities Office budget, and then the Space Rapid Capability Office, honored Air Force Research Lab by deciding that they were the key performer to move forward with Spider. And so at least we have, small as it is, a national program that's getting people used to and familiar with the idea, with the credibility of the Department of Defense. And at the same time, as I said, people are waking up to the fact that China's taking this very seriously. Their book that they published on space solar power is very clear that it's been all the way up. That has the formal approval of President Xi. So it is, So that has become, clear to the U.S.-China Economic and Security Commission, and it's become clear to Congress in their tasking to the National Space Council. So I suspect, particularly, well, fundamentally, I don't know how a administration whose, one of their top couple priorities is tackling climate change can fail to mobilize and make use of the aerospace industry on space solar power. It would not look good, and it would be, here we have an immense industrial base that can be mobilized in favor of green energy, in across the board. And it's not just, Air Force Research Lab and the Space Force with their research. There are many players, from Department of Commerce, to what NASA's doing on the Artemis Space Station. We need an interagency coordinated national policy on space solar power, not like our fusion energy program that's just a technology program, but with the goal of enabling the private sector to provide baseload power at scale for a global market.
Okay, terrific. There's some questions in the chat relating to Musk. I'm going to kind of break that into kind of two parts. I've been referring to the Starship Singularity as the idea that we don't really know what happens when that new technology comes online. So can you talk about, both of you, can you talk about, if there was a patron billionaire, if there was a massive capability of uplift, what does that future look like? And I want to break it into, what does that look like in 5 years? Alex, I hope that answered parts of your question there.
If I might, I'll step in here with regard to Musk. I have a slightly different perspective than many other people do. I don't think Musk has given his last word on the topic of space-based solar power. Steve Jobs said 3 days before he introduced the iPhone 3 at Comdex that Apple would never get into the mobile phone business because it was too far outside their core competency. I suspect that a company such as SpaceX, which has an awful lot of very young people who are highly motivated to do great things in space, that this is something that company is looking at. I imagine that they will pursue it when they hit certain criteria. I don't know what those criteria are, but I think that's what is going on there. I am interested in why Bezos and Musk both haven't attacked this more aggressively. They certainly have the analytical power and the wherewithal to get that done. While you may be concerned that they have all the resources in the world and would only pursue it if it was meaningful or valuable, we don't know what other outside influences they have going on inside their companies. Something that we are concerned about on the defense security standpoint, we receive an awful lot of foreign messaging aimed at our American public. We are a democracy. And in order to prevent space-based solar power from becoming a real thing, an adversary simply needs to sow the seeds of discontent with the idea, fear-mongering with it, to prevent it from developing the necessary consensus between two political parties to get done. One of the problems that we have is the pathway to 2050, which is the timeline that we identified in our Space-Based Solar Power Study Group report, is that it is going to be filled with Democratic and Republican administrations, which, for whatever reason, politically speaking, in their interest, they tend to polarize issues. What one administration favors, the next administration will trash. And this seems to be kind of the ebb and flow of where we're going.
Do you think, so I have a very strong opinion on this, that democratization of space means spreading risk, that if you have, I mean, financial risk, that if you have a few patron billionaires, which is kind of how the market's evolving now, that I believe that tends to focus effort, but I also think it kind of tends to have a herd mentality that folks tend to not take big risks because they're writing checks out of their own checking account. I don't think the patronage model for space-based solar power is an appropriate model. I'm curious if y'all have any thoughts on that. I know you're coming from a perspective that that's not your typical answer, so just curious where you're at with that.
Well, I don't know that it can't be a patronage model. I mean, in truth, I could certainly see how, Elon Musk, could surprise us all. I mean, it would not be, a big step, to, do a lightning fast, megawatt class demonstrator. I mean, he could essentially, take something very much like his Starlink satellites, have some kind of simple, robot, stitch them together and show that he could beam a significant amount of power, to the ground. And that would open many eyes to investment. You could imagine, I wouldn't expect that Jeff Bezos, would take exactly that similar route. I would suspect he would probably figure out a design that he thought was capable and, an initial customer base that he thought, was reliable, and get a contract, from them, and then start launching those on his own system. If you had asked me that a year ago, I would have definitely said no. I could not imagine. But what's happened with Starlink has really sort of changed my opinion about what even a single billionaire could do for space solar power, if they wanted to. And I think, once, in the same way that people sort of doubted that there would be a market for Starlink, you could have a bold, billionaire who, would bet, that despite what everybody thinks, there would be, a market for, something initially. Maybe it would look not unlike what Japan was thinking about with SBS 2000, where they were just going to be servicing equatorial nations initially, and would be a part-time. There's this, I see Paul has asked, wouldn't space solar power be a competitor with Tesla? I don't think so. First of all, Tesla itself, is principally, a car company. And of course they have, his power wall and solar cells, but those aren't, 24 hours, and they're not going to scale to city level. And, there are many places where, powering, your gigafactory, or powering, your ultra fast chargers would benefit from having, 24-hour power. And, to really affect, climate change, for instance, it's not just going to be one. You're going to have to be building, all of it simultaneously. And there's always going to be a desire to have power infrastructure close to you that you control, that's a useful backup.
Can you answer Alex's question about, taking photons, turning them into DC, and then turning them back into power? I think that's
That is a question best left for the evil Dr. Mankins.
I'll take a stab at that, right? So the answer is just point blank, because you get more at the point of need. So, first of all, you have to consider what is the relative, in fact, let me just share a slide here, because I think it's easiest to just go, with a slide. So this is, Elon's argument for why this is the stupidest thing ever, right? So he says, maybe, you're getting, maybe you've got double the energy conversion, it's got to be better than panels on Earth. you get more solar power, maybe twice as much sun, but then you have to do the conversion, right? So the first part is just wrong because, compared to what you're having on Earth versus the equator, you're getting not twice as much, you're getting 5 times as much. And compared to someplace in a temperate climate, you're collecting 12 times as much energy, right? And then, you also have to consider, all the losses along the way, including what you would need for round trip energy storage. So you're doing way, way better, even after conversion, it's like 18 times better. And then, I like to point out that the problems that we're facing are pretty significant in terms of what the world energy consumption is going to be. And if it's compounding, around where it is now, as Jeff Bezos says, we're somewhere between 2 and 3%, you'd have to cover the entire surface of the earth for just 500 years, all the while our, energy sources are running out and the carbon's increasing. So, it's got all these wonderful things of being, renewable, scalable to global demand. And Elon himself has said that when something's important enough, you do it, even if the odds are not in your favor. And he, talked about, why are rockets expensive? Just because they've always been historically expensive, but if you could wave a magic wand and rearrange the atoms and the cost of that was zero, they wouldn't be expensive. And so it's a question of figuring out, cleverly, how do you get the atoms in the right shape? But the other, part of this question about reconversion is that if the same piece of land, can be at least 5 times as energy productive because the rectenna is like 85% efficient compared to the solar cell, which is going to be less than that. So on the ground, right, the area that you would have for a solar power cell can be reconverting those photons at much higher efficiency, less waste, with a much higher duty cycle. So instead of a quarter of the time, it's 100% of the time. And instead of, a conversion efficiency of, 20, maybe 50% someday, it's 85% efficient.
Cool. Pete, we're going to turn it over to Lila and bring in General Quast in a moment. Thanks for sticking around, y'all. Appreciate it.
Did you mean Lila or me?
You, I think.
Oh, okay. All right. Thank you, General Quast, for making it here. Stephen Lloyd Quast is a retired United States Air Force Lieutenant General. He last served as Commander of Air Education and Training Command, Joint Base San Antonio, Randolph, Texas. In that role, he was responsible for the recruitment, training, and education of Air Force personnel. The command includes Air Force Recruiting Service, 2 numbered air forces, and Air University. The command operates more than 1,400 trainer, fighter, and mobility aircraft, 23 wings, 10 bases, and 5 geographically separated groups. It trains more than 293,000 students per year, with approximately 60,000 active duty, reserve, guard, civilian, and contractor personnel. Lieutenant General Quast, we're glad you made it, and welcome to the conversation.
Well, thank you. And I appreciate the fact that I have many, many friends on this constellation of 71 participants. And I want to say hello to each of you. And I also know that you've already covered a tremendous amount of territory and with experts that can help talk about this. My only contribution as we go into some dialogue here is to state this as succinctly as is possible for somebody who has studied the arcs of history and the competition between people who are all trying to love their children, all have security and the essentials of life, and do things that make the human condition better. That for the last 20 years, and for many of you, 30 years, there has been this recognition that is the elephant in the room, And I'd like to state it as clearly as possible, even though it is not a statement that is accepted by the bureaucracy, because the bureaucracy tries to maintain the status quo for good reasons, but that status quo can become a trap. And the statement is this, that our society has experienced a secular slowdown in its ability to innovate and to see strategic high ground. And the Chinese and their Communist Party that can focus effort, money, and vision have seen a new opportunity. And it goes to the fundamentals of life, and that is a civilization that dominates energy, dominates the economy. And the civilization that dominates the economy has all the national security, all the political, economic, and military power required to survive and thrive as a civilization. And that this status quo we've lived with since World War II, where we are so unilaterally dominant economically, culturally, socially, that we have literally assumed that tomorrow will be as prosperous as yesterday by just refining the paradigms we have. So Elon Musk is trying to break out of that. Jeff Bezos is trying to break out of that, and 100 small space companies. But the reality is this: space is so powerful at optimizing neural networks to deliver the essentials of life, food, water, shelter, energy, all of the things that matter, and in different ways that we've talked about, that whichever civilization gets there first is going to be able to dominate every other civilization for almost an indeterminate amount of time. Because when you can see and stop, or see and paralyze anything that moves with a neural network in space that can maneuver, bring power to bear and information to bear, it is very hard to get up on top of that hill if you're at the bottom of the hill and somebody else is at the top. So 20 years ago is where this realization took place, where if America does not reach for this lifeline called space to usher in a new dimension of energy, information, and transportation, that we have already been infested in our internal structures as a society by China. China is infested in our energy markets, our agricultural markets, our information markets, in such a way that to try to fix the current paradigm is unaffordable and unrealistic. We are already dead men walking as a society if we do not reach to space first. And I know those are audacious words, and most people that have lived such a prosperous life have never experienced how civilizations fall. But if we do not grab for this high ground of space and invest in an infrastructure of energy, information, and transportation, we will be a second-rate society by 2050. And then the behaviors of China that tend to punish those that do not kowtow to the Communist Party and the communist philosophy, anybody who would have the audacity of stating that individual freedom is actually a positive thing will be silenced or paralyzed. But it'll be subtle, it'll be insidious, it will be nuanced in the innovations of the economy. So this is all about the economy, it's all about energy, and it's all about space. And that's why I'm grateful for all your friendship, because if we as an American society, with our friends across the globe that believe in this value of dignity, that every human being is made of equal dignity and equal worth and to be respected equally, if we believe in that, we need to put our money where our mouth is and optimize the economy of space so that we can deal with anything China might throw at us over the next 50 years. And right now, we are not on that footing. We are on the footing of having to react to whatever China does. And in my business of national security, the number one sentence for job description is, be prepared for the unexpected. And the unexpected would be that China takes its power plants in space, whether solar powered or nuclear powered, and they broadcast them as this is peaceful power beaming to all devices on planet Earth, so everybody has the benefit of energy. But in a millisecond, it can be turned into something that can paralyze our society, paralyze our power grid, paralyze all the distribution of essentials, water, food, and paralyze our ability to communicate with one another. That would be unexpected. But if you are not prepared for that unexpected event, shame on you. So this is why this is such a pivotal conversation, and why we need to convince the political class in our country that the infrastructure bill is not just roads, bridges, trains, and airports. It is a space infrastructure that delivers energy, transportation, and information using the neural network of space and all of the innovations that are percolating in terrestrial business cases to, in our age, build the Panama Canal. But it's this time, it's building the space infrastructure that lets us compete with China. 10 more years of doing nothing or squabbling with ourselves politically, and it will be too late. We still have a narrow window of opportunity, and we need all of you helping educate Congress and the executive branch and companies out there to resonate on this messaging that we are in trouble, and our only lifeline for the prosperity of America to usher in our values is space. Thanks. And we can kind of go into question and answer now, but that's the only thing I think I have to contribute to this, is this broad historic view of what's really going on, and to not be frustrated, but rather be activated.
Thank you, sir. I would put to each of you, Peter, you said you had like 4 recommendations of kind of immediate actions. I would like to know what would be kind of, from each of you, task 1, 2, and 3 of the next, let's really compress it, of the next 2 years. We've got a new National Space Council standing up. What would be tasks 1, 2, and 3 of the next 2 years?
All right, I'll take that on. So, task 1 is the administration needs to decide that the United States will compete with China on space solar power, and will link in its allies into a broader, effort on space solar power, and it will coordinate a broad interagency push via a space policy or national security policy directive. That's number 1. Number 2, we have to be thinking long-term enough. And so it does not make sense to me. I'm a huge fan of going back to the moon, but it has to be for a reason. And that reason has to be the broader industrial base. And so I think that the administration needs to be clear that the Artemis lunar base is a lunar industrial facility that hosts public-private partnerships, and that it needs to have manufacturing objectives. And I think it should be focused around space solar power. And then I think what you have to do is you have to make it easier for America to win at this game. And part of that is a portfolio of research, of funding a portfolio of companies, not just one, to develop different architectures, and to make and to create a market by saying we will buy that power when it becomes available, and that we will reduce the cost of capital by having a Defense Production Act Title III, finding as infrastructure with the appropriate, whatever incentives that can make this as economically viable as possible. Over.
Anything to add, y'all?
Yeah, so I'll add something here. Again, the years of scar tissue working with Congress, and the politics, where politics is local, and it tends to be very selfish, and it doesn't tend to have a long view, but it has the power to crush any idea that's visionary until the crisis comes along. But I agree with Peter Gerritsen wholeheartedly that energy is the foundation of every economy. And by starting with energy first, everything else solves itself. Whether it's power beaming to the transportation modalities and technologies that are buzzing around cislunar space, both within the gravity well and outside the gravity wells. It doesn't really matter. If you own energy, you own the economy, you own the future, you own your values, you can protect them. It's getting the political class to understand, and the political class stopped learning a number of decades ago as the political rancor became more and more vocal. And it's happened in past as well, but this is our age of a political class that is incapable of understanding, or at least having the political courage to turn to a constituency and say, yes, this is going to require your workforce to learn new things and to shift jobs in order to build new things, but we have to do it for our survival. And politicians do not move unless there is pressure. In other words, unless they are threatened by their next election, they will not, they'll wait. They'll try to delay the decision. So I would say each of us in our own way, using our networks to get after the political class and remind them of this stark reality that if in 50 years from now, the American people will turn back and say, who the hell was in charge that let a strategic threat like this kill our values in our Constitution, the values of respecting people, individual freedom and liberty. How did this happen? Who are the leaders? And they will point back to this generation of politicians that squabbled over things and decided to go with the status quo, and the money they spent was on the horses and the candles when we had the automobile and electricity that we could have invested in. Space energy and space transportation and space communication are the horse, the electricity, and the airplane of our day. And it would be like the people in charge of the American political system back at the turn of the last century decided not to invest in the automobile or in electricity or in the airplane because they were protecting the horse industry, the candle making industry, and it's that stark. It is that profoundly consequential to our prosperity. We need to get after the political class so that what Peter said will come true. And that is the law can be written that we are going to partner with these companies that are innovative and give them the non-diluted money to accelerate their journey, and stop being so politically correct and worried about fairness that if you give the money to Elon Musk, it'll make somebody upset and they'll sue you because it wasn't considered fair. Well, it's not fair when China steals your free speech. It's not fair when China charges you more than you should have or blackmails you because of the pharmaceutical stranglehold they have on healthcare. So I'll stop there, but that's the second point I would make is all of us have to be activists, and in our own communities with our own congressional members, our own caucuses, reminding them, hey, you work for me. And there is something going on here that you had better get your education on, and I can give you the people that can teach you. Seek some people you trust and learn what's going on, and have the political guts to actually vote for the kind of law that does a Manhattan type project. This is as big as watching, FDR watching Germany building the bomb and not listening not listening to his scientists. One of the biggest one was Einstein saying, you better do something or they're going to be able to kill you all with one bomb. And the Manhattan Project, and thank God Oppenheimer was the man. There are women and men in this country that could do the same thing for space power, space transportation, and space communication. And we would leapfrog ahead of China, I guarantee it, because of our innovation and how creative we are as a society. But that's not even, in the cards right now, unless we put political pressure on Congress to actually write the law to say, we are going to do this as a nation. This is a national vision. And we can usher that in with Biden saying, this is the way to solve global warming. You can have a power grid that does not pollute Mother Earth. So there is alignment in politics and in survival, only if we are willing to be activists and not be shy.
with the reconstituted and reinforced National Space Council, are there any? Do we have any allies? Do we have any advocates at the National Space Council that are pushing for this? I mean, I love the idea, but is there somebody on the inside?
Well, having lived through the last administration and being very close to the very top level, I will tell you that even if one, we don't have any good advocates. There's a lot of very traditional thinkers on there, save for one or two. But they are essentially, if you don't have the vice president and the president and congressional members that are part of a caucus supporting this, it will never happen. The power flow in the National Space Council and the executive branch and the legislative branch is such that if you don't have the vice president, the president, and key congressional members on board pushing it, it will not happen. So we saw it unfold in the last National Space Council, where they had great documentation, great strategy documents, great vision, but they were unwilling to push the bureaucracies below them, whether it was Department of Transportation, Department of Defense, Department of Commerce, to be more aggressive at changing the way they were doing business, because the problem is riddled down through NASA as an example, where you have a culture that wants to do one thing. Asking that culture to do another takes great political effort, great leadership. And if you don't have the president and vice president and key congressional members on your side, forget about it. So that's why you need this political pressure, this education. And you need the advocates on the inside, but don't think there's going to be a hero and one or two voices on the National Space Council that change the trajectory of a culture that is refining the status quo and just trying to make better satellites.
Sorry, I'm processing that. There's a lot there. Okay, so I'm a big believer. I've risked my whole career on commercial developments in space. What role do they have? What role does the commercial sector have? I mean, most of this conversation has been primarily government centric and government led. What's the role of the commercial sector in developing this new technology?
So I'll let others that are more in the economic realm talk about this, but the short 10-second version is they are everything. But the price of entry to make the business case close is so steep that if they don't have government help at a vision that can beat China, they will eventually succeed, but it will be too slow and China will be there first. So speed to the high ground before China is key. The businesses that will take us there, that should take us there, need help or all is lost.
Yeah, absolutely. Absolutely. I got into this, I was in my early 30s. I hadn't even committed to being in space yet. I was still in kind of that exploratory stage of kind of what I was going to do next. And I came across the idea of space-based solar power, and all of these light bulbs went off in my head. I realized that, without electricity, you can't have advanced medicine. Advanced medicine requires pumps, and it requires refrigeration, and it requires all of these things. So without electricity, you don't have medicine. Without electricity, it's really, really hard to get an advanced education. If you have those two things, if you have education and medicine, the very next logical step is democracy. So to me, the driver was, how can we get energy to the world? And the thing I was focused on was, if you can provide power to the top 300 cities of the world, you can provide power to 40% of the global population. Clean, green, limitless energy to 40% of the population. That is a task worth working towards, right? That is something that that's worth putting your life, focusing your life on. To hear General Quas and Colonel Garretson and Colonel Smith talking about this from their perspective, it's so incredibly inspiring. So thank you, gentlemen. I really appreciate it. We're going to turn it over to Lee and then to Tim Chrisman, but really appreciate it. Feel free to stick around. Thanks for taking the time this morning, y'all. Appreciate it.
Lee, you're still muted.
I'm trying to speak through my phone because I keep losing my internet connection. This conversation is fascinating and motivational. I see why Steve had such success as a recruiter. Want to march up to the front. It's so wonderful to hear from our speakers today and tomorrow who've been the pioneers and early champions of the vision for space-based solar power. But now we have to come back to Earth because we're hosting today's event from Akron, Ohio, where there is space industry activity with active job postings out there right now. We're going to visit with our executive director and co-founder, Tim Chrisman, on site at Firestone High School in Akron, along with Lila Gislason, our other co-founder in Michigan. Tell us what's going on today.
Thanks, Lee. Yeah, so I'm here in front of the Firestone Community Learning Center, formerly the Firestone High School here in Akron, where struggling with her name, it was Judy Resnick, was going to be the second woman in space, was on the Challenger when it exploded. This is where she went to high school. We chose coming here for just that reason, but also to connect with the next generation coming up. So we're here talking about workforce development and education and career paths for people who, like Judy, wanted to pursue STEM careers in engineering and science, and those who maybe admire her work, but aren't inclined to the STEM track and want technical education or other skilled jobs that we're going to need in the space economy. I like to joke that for the next year or two, it's mainly millionaires and billionaires going to space, and not a one of them is going to fix their own Wi-Fi, fix their AC, or make their own drinks. And so somebody's got to do that. And I have volunteered to do at least one of those three. I'll leave it to you to guess. But yeah, we wanted to take some time to talk about the sort of trajectory that we're pushing on workforce development and how we're doing that outreach and sort of go from there. Whenever we do these events on the road, we engage with basically three groups: the local public schools, and community colleges, local politicians, and chambers of commerce. And the rationale behind those is that we're trying to build a sustainable pathway to employment for these local communities. And to do that, you really do have to engage all three of those organizations. And we're particularly animated in this cause, as you just heard from General Quast, the sort of message behind the urgency. And my last job, it was my job to watch China's space programs, among other things. And it was the sobering thing to do, to realize that the sort of things we take for granted every day, whether it's security, economic success, or just going to work and being at home peacefully, are not things we can take for granted. And so the workforce development initiative that we at the foundation are pushing for is one of those things that we can start. We can't change the law all by ourselves. As we heard, we need champions and leaders in the political class. We aren't billionaires, so we can't fund the development of new starships and watch them, I think Elon calls it unexpectedly disassemble rapidly, as he does with Starship. But what we can do is start building a network of schools, communities, and people to lay the foundation for a kindergarten to space educational pipeline. I'm told that when I describe it like that way, it sounds like we're taking kindergartners and shooting them into space. I have had 2 children go through kindergarten, and that was always on the table. They've survived kindergarten, so now they sort of earn their way into permanence. But the idea really is this is something we can do now. We can take this bull by the horns and start working towards it. And so what we're doing now is building a 50-state network of lead schools who have a desire to engage in the space economy, who maybe have, as Lackawanna College in Scranton, Pennsylvania, a history of self-sufficiency and go-get-emness. They were founded by miners looking to better their lives. Or schools like this, who have a heritage of pioneering space achievement. And what we're doing is using that network to collect the educational and workforce development initiatives that are available and organizing them in one spot. From there, we then know what's needed, what we have, and what can be adapted. I was on a call yesterday with Amazon Web Services about some of their cyber training programs and how right now it's sort of a fixed curriculum that they're using. And they want to take it and make it much more modular. And my response to them was, that's exactly where we want to take space content and curriculum, is taking what already exists, whether it's in manufacturing certifications, welding training, automotive repair, or aerospace manufacturing, and making it modular, adding the practical exercise on the end of what would already be useful training for someone wanting to be in the aerospace industry, and applying it to space. And so that's what we're working on with Amazon Web Services, and trying to export that throughout this budding network that we're developing. As we sort of are laying this foundation, we're looking to the work that NASA has done with their space grant program and the sort of 50-state network. And we're building off of that and the existing models that schools like Cal Poly have, where Cal Poly, with its large school, robust set of teachers, is able to have a wide array of certified trainers for different topics. Well, then they reach down to community colleges and partner with them and say, hey, your students want this content, want this certification, we've got the trainees. How can we partner with you to leverage your reach into these underserved communities and our reach up into places like Amazon Web Services and others? And so that's what we're looking to do with our workforce development initiative, and why we're in places like the Firestone Community Learning Center here, trying our best to continue the legacy of Judy. Hey.
My apologies.
But yeah, trying to
wanted to make sure everyone was awake.
Yeah, I can't see my screen. I'm trying this new thing where I just stare at the camera lens instead of using the front-facing camera when I can, so I can watch myself. And so I can't see anything. It's just monologuing here. I feel ideally I look like Stephen Colbert, but I feel like that's not what's going on.
No, you look great. So I just wanted to kind of just, focus on that timeline for a second, because I think, when we hear you say kindergarten to orbit, that still feels that feels like it's so far off. For a kindergartner today to start thinking and learning about space, that just seems extreme somehow, but it's not, because I think within 15 years, probably, that kindergartner is going to be ready for the workforce. That's not that far off.
Well, and it's not even just the idea that we need to teach a kindergartner useful skills for space. I was recently reading a book about how to sort of shape children to be useful members in a diverse society. And the key finding across dozens of studies was exposing them to a wide range of people and experiences inside the home. And the sort of rationale was the home is the safe place for the child and where they feel most comfortable learning new things and where normalcy sets in. And you have to do this young because after, probably 7 or 8, we're pretty well imprinted on the sorts of person we're going to be. But the idea was at a young age, exposing these kids to a wide range of people and experiences so they felt it was normal. That's why we want to start at kindergarten. Space needs to be normal. And to be normal, kindergartners need to see that that's a viable place to build a life and a career. Hearing about people who went there and are doing it and seeing that, no, it's not some wild, crazy thing that they get patted on the head at night and say, yeah, little kid, when you grow up and be a really big deal, you can be in a fairy tale or go to space. No, it should be a real thing. As real as anything their parents are doing or other people in their community are. And so that's really why we're starting at kindergarten.
Yeah, well, and I think also just to open their eyes to the fact that it can really be within any industry and within whatever their interest is. There's actually, I'm sure many of you have, this is my tattered copy of Barron's from last month, but the cover, it shows the next space race. And so this is really more from an economic perspective, but again, all the more reason to start this early. But I pulled one of the quotes from this article from Adam Jones, who's a Morgan Stanley analyst. He says, space touches virtually every industry in a significant way. It's hard to find an industry that will not ultimately be altered or even completely disrupted by the development of the space economy. And I think piggybacking that on what Steve Quast was just saying, I mean, it's, this is pretty urgent, I think, both from an economic standpoint and also a security standpoint and from an educational standpoint. This is not something that we can just sit on our hands on for the next year, 2, 3, 4, 5, and just hope for the best. I mean, we really need to start, hustling, if you will.
No, and that's very true. And I was just working with CSIS on a research project about sort of the urgency around this and how between basically 2016 and now, China has gone from taking up less than 1% market share in the private space economy to nearly 40% of the total investment in the space economy, roughly 2/3 the size of the US private space economy. That's in no time whatsoever. And they're able to do that because they're leapfrogging a lot of the early stage work that the US commercial space companies have done over decades and leveraging a lot of what we're doing, whether it's hardware or technology. But one of the unique strengths of the US is our educational system and the way we generate adults who are able to think, innovate, and adapt to their circumstances. And so this is an area, along with our capital markets, where we can play to our strengths. We don't have to try to beat China at their game of making the lowest cost widget. No, we can develop the highest quality students to innovate in the most challenging arena known to man with access to the deepest capital markets ever in history. And the time to do that is now. You're right.
So what's the delay? I mean, I know we're doing what we can with the Space Corporation Act, but essentially the technology exists, right, for us to live and work in space now. The industry, I think, is at a point. I mean, again, we've got the cover of Barron's here that's ready to explode. We've got innovators, startups, aerospace companies who really want to get in on the action. You know, plenty of passionate space enthusiasts who want to be involved. You know, what's the delay? You know, why is this so difficult to move?
Yeah, so
It's not real.
Oh,
yeah, well,
go ahead.
Yeah, so from a historical perspective, kind of when you study human nature and the nature of politics and power, it comes down to a lack of vision at that level. You know, civilizations died because of a lack of vision, and this is a vision that is not in the psyche of the American people to the degree where the kind of massive changes that nobody likes have to happen. But you don't have to necessarily, educate every American as to the nature of the problem. If you have the right visionaries in the political seats of power that can put money to bear. And it's about structuring public-private partnerships in a way where you incentivize the outcome. So for example, I want a global energy or assist lunar energy delivery system where it can beam energy to any device in space or on the planet, safe for human beings. You know, there are ways of having companies take what we already know they know how to build and giving them the money with the right incentives, and you never down select to just one. You kind of do it like we did the old, NASA Ames COTS, Falcon 9 originally, where you don't have to down select. You can incentivize the outcomes you're looking for and have them prove it, and then the money goes to the winner and the second and third place, and then you reinitiate and you never down select. You keep the competition going through the operational environment. That would be a Manhattan Project in the current environment that would be very easy for the president or certain members of Congress that convince the president to set in motion. That would accelerate this and not give the money to just any company, but force the companies to prove the metal at what they can build. And we all know, having an understanding of that space industrial base, how that will be like popcorn. And the amount of progress that we'll be able to make when there is money put forward with that kind of structure and incentivizing competitive spirit, that's how we do it. The reason it's so hard is there's no vision and there's nobody doing that right now. It's a pickup game and you get a few little things, but even those get killed politically, like COTS Ames, for the Falcon 9, that was widely criticized and ridiculed until reusability actually became a thing.
Yeah. So the Space Corporation Act, as proposed by the Foundation for the Future, is currently circulating the halls of Congress for early support. And it proposes a public-private partnership. Tim, could you speak to how that might address what Steve Quest is just talking about?
Yeah, no, I think it looks to do exactly that. But instead of a single sort of Manhattan project where we're having companies compete there, it's multiple simultaneously, because ironically enough, in DC, asking for $100 million is far harder than asking for $100 billion. If you can prove the urgency and the crisis need around large amounts of money, all of a sudden the sort of long range vision is somehow in everybody's hands. And so that's what the Space Corporation Act looks to do, is leverage public-private partnerships, having a relatively small touch for US Treasury. And so the main outlay from the US government is loan guarantees and bond issuance, but then to create an ecosystem where capabilities are invested in, where like space-based solar power, the proposal is put out. There is a need for X amount of megawatt generation with X amount of coverage worldwide. Top 3 finishers get a contract from US government for supplying troops in harm's way and humanitarian relief. That's the sort of system that then generates the competition we need, the private investment that is going to be needed, and ultimately the success and the economic growth across a broad range of industries, ranging from energy to advanced materials. But probably the most urgent and the one that can most capture the attention and imagination is this space energy, because as we've heard, if you control the high ground, you control it all. And having the ability to generate hundreds or thousands of megawatts of power in orbit means you also then have the ability to use that much power from orbit. And there is not a person in a rival country who I would trust with that much power, regardless of how much they reassure us.
Yeah, absolutely. Well, and I think that's why we're hustling, right? That's why you're in Akron. That's why we're hosting these events. That's why we are hosting our webinars. That's why we, have these various advocacy efforts. I think it is urgent, and again, we thank you all for being here. I think just your support here means a lot. But also, I think I mentioned this earlier, but we are asking for more formal support of what we're doing here. And we're currently circulating a letter to Congress and the executive branch to just to show the industry's support for this bill. And on a side note, we've got a goal of, I think there are roughly 2,000 companies within the aerospace industry. I think our goal is to get as many of those as possible to sign the letter, of course. But in the short term, our goal is to fill at least a couple of pages of logos and just company names supporting our bill, and just not just waiting for Jeff Bezos to make the call or waiting for Elon to make the call. I think this whole group of people, this whole industry needs to come together and show their support. So we are asking for that support. If I will drop, I'll drop a PDF of the letter itself in the chat here. But if you read it and you are compelled to support us, please shoot me an email. It's Lila, it's spelled Laila at f4f.com. I'll drop that in the chat. Or I'm sorry, at f4f.space. And we'll add you to the letter.
And one of the things we try to emphasize with the Space Corporation Act, and really everything we're doing here at the foundation, we don't have all the best ideas, all the right solutions, but we are growing what we have. The Space Corporation Act's on iteration 32 or 33, having gone through these changes because of comments, feedback, and sort of running into better ideas. And the same with workforce initiatives. And so instead of what you often hear from DC political consultants, where there's one way to do it and it's, you stay ideologically pure or nothing, we're really looking for capability at the end. And so when we say the Space Corporation Act, we have a draft bill because we don't want to show up without a solution in hand. But we also know that there's probably people on this call now or that are going to watch this later who have useful solutions to add to it. And we'd love to hear from you. And we'd love to work with you and your companies to make it better, figure out ways to increase the impact and scale of what we're doing here.
Yeah, thanks, Tim. Well, and again, we're not waiting for billionaires and others to build this gateway to space. We're making our voice heard, and hopefully yours as well. So how else you might be able to support the Space Corporation Act and also the Foundation for the Future? We are eagerly awaiting new members. We are on our website, you can click on become a member, and again, the collective voice is stronger than the individual. So your support would help us, and our advocacy efforts would help continue the hosting of these events and our webinars. Tim spoke a lot about our kindergarten to orbit pipeline. That's something we're building out as we speak. And yeah, we're excited to continue all these efforts. So I think we're close to time here, but again, thank you all for joining us. Tim, did you have any last words from Akron?
Nope, this is probably where I should have prepared something wise or witty. I apologize.
It's okay. It's okay. You're on location. It's a lot to ask.
Great. Well, thank you so much, Lila and Tim, and General Quast for jumping in on that conversation. It's great to know the details of those steps to making space accessible for all. And of course, the excitement that's generating is fun to see. There are lots of discussion in the chat, both on the public chat and on the one-on-one chats, at least in my inbox. Great to see that energy. Now I'd like to hand it over to Emily Mishler to fill us in on the philanthropic efforts that tie in with the membership program. Emily?
Lee, thank you so much. Well, it's a pleasure to meet you all and be here today. Thank you so much for joining us with Conversations for the Future. It is absolutely incredible every time I think about and every time I really listen to the vision that Tim and Lila and the board and really all of you allies and friends that we have at the foundation. It's amazing to me to think about the potential that we're tapping into, even in just stimulating these conversations. It is truly unbelievable. So again, thank you for joining us in these Conversations for the Future today. And as these relationships continue to grow and progress continues to be made, it's really becoming more important than ever before to have the infrastructure in place to support the Foundation for the Future's growth, as it is the center point for all of this at the moment. And we are positioning the foundation to be able to continue this important work for years, if not generations to come. From our conversations today, it's abundantly clear that our work is disruptive, it's necessary, and the time is now. And that means we need your help. The comprehensive vision, expertise, dedication, and momentum of the speakers today and the vision of the Foundation for the Future, the powering force behind Conversations for the Future, is more impressive and important than ever before. The future the Foundation is building is inspiring and worth investing in. This future, in space and beyond, is being built one relationship, conversation, and connection at a time. In order to continue this momentum in building and contributing to this caliber of event, conversation, and community, as we've mentioned, we need your help. We need you, our allies, attendees, partners, advocates, and friends, to spread the word about our important work through social media, invite like-minded and like-hearted peers to our events, and to help us connect with philanthropists and organizations who believe what we believe, that our future in space is ours for the building, and the time is now. We're so excited to announce 3 different avenues for you to become involved if you're interested in financially supporting our work from a philanthropic perspective. From the corporate perspective, we have the opportunity to sponsor Conversations for the Future. More information is available at the QR code you'll see on the screen, and the foundation at large on a monthly and annual basis to support this important work. On a personal level, if you, your friends, or family are inspired to support us philanthropically, we welcome your contributions to support building space infrastructure, economy, and community. The foundation has recently also launched a corporate and individual membership program that you've also heard about, whose mission is to connect like-minded and passionate individuals who see the near-term potential in space. We're recruiting everyone, from students to CEOs, to join us in creating a dynamic ecosystem of young enthusiasts, investors, entrepreneurs, and larger industry partners inside or outside of the space industry currently. We welcome all who want to join and contribute to this urgent conversation, which impacts us all. More information is available on the Foundation's website or at the QR code on the screen, f4f.space/membership. So what's our actual ask? At least my ask. Help us in making space boring, because the time is now and the world can't wait. If you have any questions, please don't hesitate to reach out to myself, Lila, Tim, or any affiliate of Foundation for the Future. Our contact information and a link to donate is available at the QR code on the screen and also on the website. I'll be happy to stick around in the chat and field any questions, but for now, thank you so much, and I'll turn it back over to our MCs for our regularly scheduled programming.
Thank you, Emily. We think of everything in space as costing billions of dollars to build, but building a public-private partnership here on Earth to advance space infrastructure development takes small dollars as well as big ones. So thank you to the generosity of our partners, our supporters, and our audiences, some of whom elected to pay the optional registration fee. What an example to set for advancing our mission. So this is my daughter, Tessa, celebrating May the 4th be with you. And I'm glad to have her here today. I am looking forward to our afternoon lineup, which will be introduced by my talented and glamorous co-host, Leo Llanos. Leo is a creative director, designer, and photographer. He has collaborated with Amazon, Twitch, GLAAD, and the Grammys Recording Academy. His work has been featured in Entertainment Weekly, BuzzFeed, Billboard, and Attitude Magazine. He is currently the design manager for Foundation for the Future, where his creative work is helping to brand its mission to accelerate space access for everyone. Leo, you have the microphone.
Thank you so much, Lee. I think you may still be presenting.
Let me stop sharing.
Yes, thank you so much. And by the way, your daughter looked amazing. She was so cute. Again, thank you so much, Lee, and thank you to everyone for joining us here on Conversations for the Future. Our next speaker is Dallas Bienhoff. Mr. Bienhoff is the founder and space architect of Cislunar Space Development Company. Cislunar Space Development Company is a space transportation and logistics company defining a reusable cislunar transportation architecture for satellites, lunar cargo, and human lunar development missions. Their vision is to provide commercial transportation from low Earth orbit to the moon's surface and all points in between. Welcome, Dallas, and thank you for being with us today. The screen is yours.
Thank you, Leo, for the introduction, and thank you, Michael Lane, for asking me to participate. This has been an interesting morning. Before I start, I'd like to share some anecdotes to link this morning's talks with what I'm about to talk about. So I first learned about space-based solar power in 1976, I believe it was, from a Popular Science article. I was working at Rocketdyne at the time, and I took that article to my manager and said, maybe Rocketdyne should get into the space-based energy market, because Rocketdyne was proposing to build the solar power satellites for space station at the time, Space Station Freedom. That went nowhere. Rocketdyne had its rocket engines and its space station project. So that was my first entree. A few years later, I was at the Aerospace Corporation after Boeing and Rockwell completed their studies for NASA and the Energy Department on space-based solar power satellites. And I did a critique for aerospace on the transportation architecture, i.e. what it took to launch and create these humongous Manhattan-sized solar arrays in space, build them in low Earth orbit and take them out to GEO. There were launch vehicles proposed that had over 4 times the lift capacity of the super heavy Starship, 454 tons to orbit. there were space tugs to take 1,200 tons from low Earth orbit to GEO. These were electric powered. And there were people transports that took 70 people out to GEO and rotated them back and forth. This was a massive undertaking. Still exciting. And then I got to work with Coyote, as he mentioned, on this 2007 study while I was at Boeing, and supported that activity. Saw it go nowhere again. They got their cease and desist order. And a few years later, with John Mankins, I was at the UAE for a space-based solar power conference. Went back to Boeing. We also heard about reaction engines, Sabre engine, this space Sabre, synergistic air-breathing rocket engine for a single stage to orbit system. I took that idea and the concept again of space solar power alpha to Boeing and said, maybe we should investigate launch vehicles to build this, should it be funded. That kind of went nowhere as well. On the opposite side of that, Boeing has since invested in reaction engines for the Sabre engine. And I've read that they are looking at point-to-point transport as well as hypersonic vehicles. So not all is lost, not as fast as we would like to see things happen, but things do move slowly in large corporations and in bureaucracy. So that's my link. And then to get to where we are today on space transportation, I was the Boeing project manager for how to implement the vision for space exploration in 2004. And we put together an architecture that used different transportation modes for launch, for in space, and for getting down to the moon. Rockets to get to orbit, separate that from getting from orbit, Earth orbit, to the moon's vicinity, and separate that mode of transport from the moon's vicinity down to the surface. That, coupled with a question from a colleague and friend as to what is a common impedance architecture for getting from Earth to the moon. Common impedance is an electrical term. I prefer resistance. You know, how do you get the same mass you can launch onto the moon's surface? So again, separating out that payload from launch into a payload for transport into a payload for landing. And at the time, the largest vehicle that we had, largest launch vehicle, could put 25 tons into orbit. So the question to me was, what does it take for a space tug to move 25 tons from Earth orbit to the moon? And what does it take for a lander to put 25 tons to the moon's surface? How big must they be? And so that's the whole story behind what you're about to see on a cislunar transportation architecture. And show all windows. Share. So hopefully you can see my presentation.
Yep, that looks good, Dallas. Thank you.
Excellent. Thanks, Leo. So again, to get us started, Leo, you mentioned this, but our vision for cislunar space is to provide safe, reliable, available cislunar transportation for people and cargo. So how do we do that? So we want to commission and operate a reusable transportation architecture to move material, and material encompasses people, cargo, propellant, anything you want to move throughout cislunar space. And that's not just to the moon, it's to geosynchronous orbit, to geosynchronous transfer, relocating things within space, providing the means to do that. So our initial minimally viable concept takes two system developments. An Earth to orbit refueler, which you see on the left, which is really a payload and return vehicle and payload fairing on top of a launch vehicle. I happen to be showing the New Glenn here. That refueling capability is sized to match a space tug, whether that's propulsive or aero-assisted, i.e. using the atmosphere to come back to low Earth orbit. And that can then be the start of a reusable cislunar architecture. The only thing in this concept that is not reusable is a second stage of the launch vehicle. Now, this is going to reflect somewhat on SpaceX and Super Heavy, but we'll talk about that at the end. This is the fully deployed architecture. It has a propellant depot in low Earth orbit, a propellant depot at Earth Moon L1, propulsive space tugs to do non-geosynchronous or non-high energy transfers, aero-assisted tugs to service the delivery to geosynchronous orbit to the operational longitude of the satellite, so they can remove their station or circularization propellant from their designs. A large 25-ton space tug, i.e. payload of 25 tons out to Earth Moon L1, and then a 25-ton payload capability moon shuttle from L1 to any point on the moon at any time, not constrained by orbital mechanics or other delays such as we see with the NRHO gateway. Now, these can also move payloads round trip at less than half the mass that we can take one way. We also operate down below station to pick up payloads to bring them to the depot. We refuel the depot, and these depots notionally are water to liquid hydrogen, liquid oxygen production facilities. And with that, we can service most of, or half of LEO, geosynchronous orbit, and other geosynchronous equatorial orbit, and other geosynchronous orbits, and any point on the moon. So what can we do with this architecture? We can do delivery missions. We can retrieve payloads from orbit and bring them back to low Earth orbit. We can do round trip missions, i.e. we can carry sensors to any place in Earth orbit or out to the moon. We can carry people round trip in our personnel module. And we can do disposal missions. We can go with a toolkit on front of our tugs, we can go grab large space objects that are no longer functioning and deorbit them to improve our sustainability of the LEO environment. But we can do up to 25-degree plane changes and back if we don't change altitude, i.e. in the same orbit. We can go 25 degrees away and come back. Plane changes in Earth orbit are expensive energy-wise. Our tugs can do that. And as we gain altitude, we can do less. We can put up to 210 tons per year per tug onto a geosynchronous transfer orbit. Today's satellite designs, without changing them, we can change the way we do business in space and get 210 tons per year to GTO per tug. That's once every 2 weeks. With our aero-assisted tug, we can put up to 104 tons to GEO per year per tug. Now, this assumes we're operating every other week to GEO and every week to GTO. We also would have a 140-ton propellant plus 140-ton water depot in low Earth orbit to support these missions, to refuel our stages between missions. We could transport 156 people per year per tug in our personnel module, whether that's back and forth or around in low Earth orbit, over to space station, if we have a space station operating point, or just loitering in low Earth orbit. We could push up to 300 tons to Earth Moon L1 per year per tug. People, cargo, propellant, 72 people per year per tug to Earth Moon L1. Bringing in the moon shuttle and a depot at Earth Moon L1, we could put that same 300 tons or 72 people down on the moon's surface per year, per moon shuttle. An architecture has multiple copies, so we have at least 2 in orbit of every item and another on the ground for spare, except for the depots. We'd have a ground spare, but wouldn't have multiple depots for servicing the moon or geosynchronous orbit. So this architecture can service the moon, and it can service geosynchronous orbit, GTO, geotransfer orbit, and any other orbit that's within 25 degrees or less of the depot location, which in our reference is 28.5 degrees due east out of Kennedy Space Center. So operationally or graphically, this might look like this, with the size of the red lines being the flow, the amount of flow that goes to each destination. And this is our reference architecture. So we're basically servicing the moon via Earth-Moon L1 and geosynchronous equatorial orbit via our 28.5 degree propellant depot. Now there's a station out here that's getting serviced. There's other geosynchronous orbits and GPS orbits, global positioning satellite orbits, that can be serviced, and we can reach those from our depot. For our non-aero assisted tug, we have a inverse parabola that can be serviced. For a geotug, we can service all the way out to about 56 degrees in geosynchronous orbit from our 28.5 degree tug. In the Artemis program, we could also have a depot at NRHO and help NASA and their Human Landing System program get down to the moon. We had serious discussions with 2 of the proposers for HLS to put a depot out there and serve as a propellant provider to Dynetics and to Blue Origin. Unfortunately, NASA only selected 1 candidate, and they have an integrated architecture. So we're looking at other ways to move forward. Another idea is a propellant, strategic propellant reserve, and more depots. We can put depots at the space station, and then we can service almost the entire geosynchronous orbit from equatorial up to polar from those 2 depot locations. We could also have a depot in geosynchronous orbit, whether at non-equatorial, and reach them from Earth-Moon L1 with lunar resources should they become available from a third party. And then finally, with solar power satellite, that traffic overwhelms everything that's going on. If we want to build SPS alpha out of lunar resources, there's a huge flow of material from the moon through Earth-Moon L1 and then down to geosynchronous equatorial orbit. That would also support our other depots in equatorial orbit. And it reduces the amount of propellant we have to transport out to the Earth-Moon L1 from Earth. The key is the cost to produce that lunar propellant and get it to Earth-Moon L1. And the price has to be less than what we can get it to the Earth-Moon L1 from Earth. But what about super heavy Starship? You know, that's the big competition in this architecture. With super heavy Starship, Elon Musk back in February in a CNBC article said he believes the operational cost for a super heavy is $28 million. Cost, not price. Who knows what the price will be, but that's cost. To put 100 tons on the moon, it takes a total of 13 launches to do that. 1 launch for the cargo, 12 launches to fill the Starship in orbit with propellant to get it to the moon, to NRHO, with enough propellant to get down to the moon and come back up and come back home. If one is taking 0 payload to the moon, the Starship still needs 9 launches of propellant, assuming that propellant is 100 tons, the propellant capacity is 100 tons. So in essence, Starship can get anywhere in the solar system, at least as far out as Mars, for less than $400 million of operational cost with 100 tons at the end point. Even with that capacity, building something like SPS Alpha is going to take thousands of launches to build just one. But this is the promise that's ahead of us if we start now and move forward into totally reusable architectures and stop throwing things away in space, on the way to space, and on the lunar surface. So Michael, thank you. Let's talk.
I want you to use that last line you just said about not throwing anything away. Just repeat that.
Let's stop throwing stuff away in space, on the way to space, and on the moon. You know, two of the human landing system concepts left landers on the moon or drop tanks on the moon every time they went.
Mm-hmm.
And that was our problem, when I was project manager for Boeing on the vision for space exploration. You know, we left landers on the moon. We only left half of what we used because we reused the cargo one for the crew or the other way around. So we used them twice, but that's a litter box, not a litter box. We don't have cats, but you know, it's a junkyard of hardware that can be used in the future, maybe. But let's stop doing that. Our Cislunar Space Development Company's basic requirement is 20 years of operational lifetime, 240 operational missions as a goal for our system, which means that the cost of our missions is 90% driven by the operational cost of getting propellant to them.
Yep.
Not the hardware cost.
I think that really needs an exclamation point, right? That this isn't about one and done. It's not about flags and footprints. It's not about political power. It's about building an industrial system and an infrastructure that is reliable, reusable,
dependable, and available.
And that, I mean, that shouldn't be new anymore, right? That shouldn't be new,
right.
But that's how we've been operating for the last 60 years of space.
We used 20-ton capacity launch vehicles to put 4 tons of operational mass in GEO today. And we throw it all away except for the operational mass in GEO.
Right. And you have organizations like NanoRacks that are re-proposing an idea that's been around for 30 years, 40 years.
A wet lab.
Of using reusing the upper stages.
Right.
Like nothing about this is new. What is new is that there's a path forward that there wasn't before.
Right. So one of the things that we discovered when I was working the Space Launch Initiative in the early 2000s, you know, we had a requirement I shouldn't say a requirement, we had a study to look at fully reusable launch systems to space station and to service the commercial crew market. And we had a 400 mission lifetime requirement, which was 4 times what the shuttle orbiter was. The biggest issue for making that happen was the amount of tests we had to go through on the ground to certify before we could fly.
Mm-hmm.
A factor of 4. So we had to put the systems through the static test articles through 1,600 flight cycles. We didn't have facilities, we didn't have time, we didn't have the money to even do that, let alone build and fly and operate the system. And you know, the beauty of the space hardware, the space tugs, is their environment that they're exposed to is significantly less than a launch vehicle.
Oh yeah, yeah, yeah. I mean,
They
you
go up
don't have the same
protected.
shake and bake requirements of every single time you come up and go down.
They go up protected,
Yep.
they stay in orbit. They don't see heavy launch loads or aerodynamic loads every time they fly. The thrust is a lot less. I mean, they're just a lot more benign environment, but they are mostly propellant. 80% of what we need to put in space, to put something where we want to in space, is propellant.
Right.
That's a rough number.
So let's talk about that, right? So we've got a really great architecture here. We've got a good design. All of the parts enable the next part, and that enables the next part. So all of this is almost a Lego-like system where each piece integrates with the other piece.
Right.
That's
It's
awesome.
integrated. You got to think integration. You got to think, what can we do not only in reducing the cost of acquiring it. Each tug is a learning cycle for the next iteration or the next size up. The Leo tug and the Moon shuttle are almost exactly the same propellant quantity. So they could be the same vehicle,
right?
Except one has an aeroshell on it and one has legs on it for landing. And the Geo tug and the GTO tug are smaller versions. So they're your early version for learning the systems, the cryofluid management, demonstrating that, the cryofluid transfer, the aero braking, all of that. And all of that grows into the next system.
And that is kind of the hard part though, right? Managing the fuels in that ultra harsh environment, maintaining it, moving it from one vehicle to the next vehicle. That's I won't say it's unknown, because some of it's known, but it is really complicated. So talk about why that's such a big deal and why it's so hard.
So I'm gonna rebut what you said about it being hard. It is probably the most difficult thing to do because we haven't done it in space yet.
Right.
But I don't believe it's as hard as some people would lead us to believe.
Oh, all right. So tell me more about that.
NASA has ground tested cryofluid management devices for LOX hydrogen. They have ground tested cryocoolers for use on things of this scale, both 90K, i.e. liquid oxygen temperature, and 20K, liquid hydrogen temperature. There are excellent insulation materials that can significantly reduce the amount of heat load into the tanks. And so if we're not liquefying a gas, if we're just trying to keep it liquid, we can do that on these tugs.
Okay.
The depots you see in this picture, they are water to cryo depots. So we take water up, easier to ship, easier to handle, easier to transfer. We produce the propellants on orbit and store them. But these depots, that's 500 kilowatts of solar arrays. 5 times what's on space station.
Right, yep.
To convert about 70 tons a month of water to cryo and to liquefy it, to gases and liquefy it.
We've got just time for one more question, and I'm curious. There has been a lot of talk about creating an exchange, a commodities exchange,
Right.
or on space assets.
Right.
Has any of that kind of crossed your radar? Would you participate in that sort of thing? And that, because that would set a price for your product, right?
Well, yeah. Also how we do things today kind of sets a price, kind of an upper price. But I had discussions with Daniel Faber of Orbit Fab years ago about commodities with Bruce Callahan.
Cahan, yep, I know. Yep.
Listen to his presentations and others. My point at the time when I talked with Daniel was, how can you sell something that we don't have a place to store or a user for?
Mm-hmm.
But be that as it may, there's this also subject of the strategic propellant reserve.
Yep.
Troy Bruno at ULA has talked about it. He has discussed it on several occasions online and talks about a $25 billion effort for a strategic propellant reserve. With an architecture like this in place, you could have a strategic propellant reserve for less than 1/10 of what Tori's talking about, because you pay for an added capacity, or you pay for an extra location, or you don't develop the moon's ability or the ability to get propellant from the moon to support your strategic propellant reserve. You start from Earth with what you have, and you expand its capacity so that you have more than what the architecture needs to service what the Space Force might want.
Right.
Less than 1/10 of the number.
Crazy. Terrific stuff. Dallas, you're going to stick around here. We're going to come back and talk a little bit about current events here in a moment.
I will be around.
Turning it over to you. Thanks a lot, Dallas. Appreciate it.
I will stop sharing.
Thank you so much, Dallas, for that amazing presentation and information on space tugs.
You're welcome, Leo.
Thank you. And for being with us today on Conversations for the Future, of course. To continue the networking benefits for this event, Dallas, if you could please just put your LinkedIn link on the chat or comments so we can continue networking. And for everyone listening, thank you for joining us for this Conversations for the Future powered by Foundation for the Future. Conversations for the Future is a nonpartisan event about near-Earth space infrastructure from now to 2035. Foundation for the Future is dedicated to the creation of a public-private partnership for space infrastructure development. To support this cause or to sponsor one of our events, please visit us at our website at www.f4f.space. That's with the number 4. And we are grateful for the support of our corporate and individual partners. Now, without further ado, let's hear from our next speaker, Paul Chang. Mr. Chang worked as an international oil and gas consultant from Algeria to the US. He retired from 2016 from Saudi Aramco. He has an extensive background working internationally for major exploration projects on and offshore, and he also received 2 patents from USPTO and advanced materials, plus additional patents pending. On his off time, Paul likes to garden and cruise Chesapeake Bay to Pecosby in the 1985 Hatteras Classic. Hi, Paul, how are you?
Fine, thank you. And thank you for this wonderful opportunity, Michael.
Thank you. The screen is yours, Paul.
Okay, I think Dallas would love to chat with you more because I think we might dovetail into your area.
That's why I put y'all in this this program, this block, specifically so y'all could chat.
Would love to do that, Paul.
Okay, so let me get going on the presentation. The first part might be history, just to lay some groundwork so that everybody's on the same page. And it's really for my benefit too. I know you guys are miles ahead of me. But just to build a case, and then we'll get talking about the what I like to offer, and then something realistic of making money to keep this thing running. So if I may share the page, Michael.
You have control, sir. It's at the bottom where it says share screen.
Okay, you see the screen?
Not yet.
Okay. Now you got to walk me through how to share the screen.
Do you want me to? I have your files. Do you want me to pull it up?
Please, yeah.
Okay, give me a second.
Yeah.
I didn't have it up.
Thank you, Michael.
Yep.
When my television screen comes on, I'm a happy camper already.
Just give a little bit of background about how this happened. Yeah, we'll talk about the tech in a second. It's going to take me a moment to pull up your slide, but
this is technology that's started with a pipeline and the nuclear. When I first saw this in 2012, I thought, there's a need for it without really understanding how or what's done to it. But so pipeline and nuclear, they want heavy, thick, and powerful. So now to do a 180 to go to space, the thinking has to turn the other way. Miniature, light, small. And so I proposed a demo weld unit to ESA and some folks at NASA to have a demo weld unit on ISS, and it can fit inside the Bishop. So it can be done. So anytime you're ready.
Yep, just pulling it up right now.
Okay. It's old style technology. It's not cool. It's not, code. It's not 5G. It's not renewable, but it is basic fundamental science. So I think it has the, in reference to some of the earlier discussions about the 11-kilometer wide structure that's being contemplated by the Chinese taikonauts, or I've been thinking too small. The biggest structure I've been thinking to date is 1 kilometer. I gotta go bigger. So can I go ahead?
All set.
Okay. Folks,
Everybody seeing this? Yes, thumbs up. Okay, all right.
we can weld in space. Yes, ultra safe. Astronauts can weld without being welders, and that's critical. Next. If I may just read some history by NASA. This a review of welding in space and related technologies, NASA 2020. Deployment of welding and additive manufacturing technologies in the space environment has the potential to revolutionize how orbiting platforms are designed, manufactured, and assembled. These technologies offer the option for repair of sustained damage to habitat structures on space missions, as astronauts will be able to manufacture new parts and weld cracks. An added benefit is that required repairs can be achieved more economically, as new parts need not be shipped from Earth. With further maturation of in-space welding capabilities, astronauts can operate under given standards and weld damaged structures rather than rely on cargo resupply. Next. And this is from the European Space Agency, November 2019. I'll just read a little bit. Welding and joining, and the last phrase, will enhance reliability and reduce the risk of the often observed underperformance and failures. So they're looking for solutions also. Next, please. So just briefly in history, the Russians were the first to weld in space. 1969, Soyuz 6 in the Vulcan welding unit. NASA followed in 1972 with the electron beam. And since then, it all came to a stop. And nothing's been done for the last 45 plus years. My belief is it was never pursued because NASA and Russia deemed welding in space too dangerous and they could not scale. Next, please. So I think it's the aspiration of mankind to travel amongst the stars. And some of these structures on the right are the winning designs given by NASA. But before we do that, next, please. We need support structures, as Dallas mentioned, and a few other folks have mentioned earlier. We need a Pony Express, an outpost, charging stations, just like in the old frontier days. Next, please. Now, if we agree on the assumption that we need to scale, we need to build the Pony Express, the question is, do we do the individual supply flights where we take off, carry the load, land, and leave the infrastructure on Mars or on the moon? Or we load from orbiting stations by lift or by flight? Remember the Jetsons, this is what I call the commuter bus that never lands. So we load from orbit, travel the distance, unload, come back. That's it. It never lands, it never touches Earth or the Moon or the Mars. Next, please. So if we agree we need space stations and infrastructure on Mars and beyond, just like the movies. My first sci-fi movie was HAL, Space Odyssey, 1969, I think. So how do we assemble large structures in space and on Mars or the Moon? Today's options might be prefabricated parts that clip, bolt, glue, or Velcro in place, amongst a few other stuff. Next, please. But the support structures, whatever we build, must be robust. Permanent space stations must withstand vibrations and the odd impacts, because if that bus goes between Earth, Moon, and Mars, one of these times something might happen, it'll bump into something. And how do you repair that? And the structures on Mars must withstand windstorms. If I believe Matt Damon and The Martian, the windstorms on Mars can be severe, but much more to learn about that. Next, please. So there are different options to weld. Welded structures offer strength and rigidity. It can be repaired on site without waiting for replacement parts. This is one of the most efficient, the fastest welding. One of the options is K-TIG by Australia. Welding in vacuum and zero gravity offers challenges, but there are options. Techniques are fast, works for thick and dissimilar material. But this technique doesn't work in zero G. It works in in vacuum, but not zero G, because when they melt the metal, the splatter is cannot be accepted. Next, please. So friction stir welding and electron beam are the current accepted options. The picture on the right, as I'm sure you folks know all about this much more than I do, is electron beam proposed and researched by NASA through a company in I think it's in Florida. The electron beam on an umbilical cord. Electron beam's great, but there's other issues with that. Next, please. Now, friction stir welding, this is aluminum. This is the cross section with today's technology. The process is 1 millimeter at a time. There is a beginning and there's an end, and we need to inspect afterwards. Next, please. So, to get to the heart of this presentation, what if there is a weld that is truly automated, autogenous, fine-grained base to base, in compression, low to no residual stress? That's an assumption for now, being tested and verified by an institution. It resists embrittlement, and there's no fusion line. It is ultra safe and zero toxic fume. For pipeline and confined space, the toxic fume is becoming a very real issue for Earth applications. And the embrittlement is not so important for space because we don't have hydrogen embrittlement out. We have radiation, but not embrittlement. Next, please. So what if we have an alternative that delivers this quality? For the non-welding folks, this is one of the best welds on Earth right now. No BS, on the level. None of our overseas competitors have this ability or the concept to make this quality. Next, please. I'd like to talk about solid state induction. There are three variables. The quality and the integrity is documented in real time at the job site, in orbit, and at HQ, like in Houston or on Mars or on the Moon. There's no interpretations required, strictly by the numbers. The majority of the power is induction heat. It supplies over 95% of the required power to join metal. Shear and forging force comprise less than 5% of the total required energy input. That is significant. So on the comment on the left, this technique welds with technicians, not welders. So astronauts can weld in space without being welders because there's no human input. Once you set the parameters, you're done. Pardon me. Once the parameters are set, there's no further action. It is one shot, less than 1 minute per weld, regardless of size or thickness, and is repeatable. And for tubulars, there's no root weld. For space is not important because we have no liquid on the inside to go through. For the OD and ID, they're identical, and we can regulate the profile to be flat. Next, please. These are samples of the welds done today. As is, please note the OD and the ID for the folks in manufacturing and the corrosion specialists. There's no preheat, there's no post-weld heat treatment. As is, the minute it's done, boom, that's it. What you see is what you get. Next, please. So these are the X-rays that I did in 2012 or 13. As is, from the X-ray people, 7 out of 7, no porosity, no inclusions, no slags, perfect, flawless. Next, please. And this is a cross section on just a regular grade X65 line pipe, nothing spectacular about the metallurgy, but this is a cross section. There's no fusion line in the middle. There's no heat effective zone. There's heat transition zone, no question, but there's no heat affected zone. And the 3 samples on the right are from Bruce Nuclear Power, given to me with permission to publish. Next, please. So to go back to the basics of what this is all about, recall in high school, we're told when you weld, keep both parts absolutely stationary, don't move it, and then put your stick in there and fill the gap. And afterwards, don't touch it, let it cool. But the problem there is we have 2 heat affected zones on either side of the weld, and that's a weakness. We'll come back more to that later on. So the brilliance of this technique is this inventor said, one part, keep it locked tight shut. Put a heating paddle between the work faces. Traditional thinking up to today mostly has been we heat the girth around on the outside. But the brilliance of this invention is you heat between the work faces. Up to a certain temperature, pull the heating paddle out, push the other part in and rotate, or rotate and push the other part in. By movement, you break the crystalline structure. That's why the crystals are so fine. And you relieve all the pressure. For pipeline and the hydrogen embrittlement that's coming up for the European and the US market, that is a critical, significant difference. So next, please. So at the end result, when you take the heating paddle out, you move it in, you rotate. And it's just a little bit of a rotation. You don't need a whole lot. And it's not friction, because friction, you go by a million miles an hour, dangerous, but there's just slight movement. Next, please. So for the metallurgist, this is one of the finer details of the crystalline structure. To most of us, it doesn't mean that much, but it is significant. The crystalline structure on the left is the base metal. The bottom left is the base metal into the heat transition zone. And the middle picture is the middle of the heat transition zone. But the most important is the bottom right. It is the beginning of the heat transition into the recrystallized zone. There is not that much difference. The crystals are fine grained. I have more on that, but if you're interested, we can get more into that. Next, please. Fundamentally, this is the difference between what was invented and the fuse ring technique. the old method, as mentioned, one side is stationary, put a heating paddle between the work faces, pull it out, push the other part in and rotate. The fuse ring concept and the is what happens when you come to the last joint at an expansion joint or a valve for pipeline. Those are big stuff, you cannot move either end. Or in a nuclear reactor where the feeder tube comes in and the manifold is this side, you cannot rotate either side. What do? My proposal was you put a coupler in between the two sides, heat both faces, pull the heating paddles out, rotate the coupler and push. The two ends, one of them might move laterally, but they'll never twist. So you rotate the coupler instead and push the one end in that can move laterally. And the USPTO says, yes, son, we agree. And they gave me a couple of numbers, granted. Next, please. With this technique, we can work for three-dimensional structures. Tubular pieces can be assembled in 3 dimensions for space assembly using fuse ring technique. Fuse ring can be used to complete circular rings for, say, space station. We can assemble very large structures using this technique. Solid-state fusion and fuse ring technique allows welded construction on the moon, Mars, and beyond. Next, please. So fuse ring joints, I've moved beyond that. Further IPs have resolved the problem. The puzzle has been resolved. We can use this technique to join flat, curved, and tubular geometry, regardless of size or thickness. So the applications are pipeline, refinery, nuclear refurbishment, shipbuilding, pharmaceutical, and food. Pharma and food is important because we offer a smooth ID, and that manufacturing sector needs and demands a flawless ID because they cannot have any germs or any bacteria buildup. And we can well shut spent fuel container lids next to fuel pellets safely because the technique is automated and it resists embrittlement on the inside and the outside against the hydrogen embrittlement. The third one, we can join 3, 4, 5-inch thick hull with no flaw. Submarines can dive deeper with certainty because we have no heat affected zone. And it can join irradiated material because it's automated, it's one shot, and it's solid state. No human ever needs to be near the process. For dissimilar material, intermediary between very dissimilar materials, the IPs are published for the automotive, for nuclear, different parts. But the last part, the most recent IP filing is rail. The hardness of this technique is much more homogeneous and it takes less energy. Next, please. So to make some money to pay for all the IPs and the presentations, rail is the lowest hanging fruit. They have pain. Fuse ring is the solution. And as a comparison, today's technology on the left is linear friction sponsored by the government because they're looking for better methods to join rail. And I'll explain that in a little bit. The top right picture is flash butt. It is the accepted technology for the last 50 years because that's the best we can do. We accept it and we live by it. We live with it and we work around it. Linear friction is the new exploration area. The heat penetration is less, but the forging force is huge. And so far, they have not been able to overcome that forging force, so it has not been able to be portable. The fuse ring offer, our heat penetration is in millimeters, singular digits, millimeters. The remaining forces, the shear and the forging, are less than 5%. It's insignificant. So it can be portable and the entire process can be electric. Next, please. This is the picture on the left is a picture of rail with two heat affected zone today. And if you look at the picture on the right, the two dips are the heat affected zone and the softness that goes with a traditional heat affected zone flash butt welding. They go about almost an inch either side of the weld face. We accept it around the world. In the global economy, the global rail industry accepts these two dips because it's been fine all these years. But now rail load, speed, and intensity is increasing. Every load is heavier, faster, and they're coming in faster in between the travel. So repair and maintenance is getting to be a significant issue. If I may just point out, a smaller picture on the bottom left is a hardness mapping of the fuse ring solid state technique. We don't have the two dips. The heat affected zone and the hardness mapping is much, much more homogeneous. We don't have this particular dip issue. Next, please. So just in brief summary, fuse ring is in discussion with US and European companies to demo, mature, and scale this technique. The number one, as mentioned, the lowest hanging fruit is rail, because they have pain, I have solution. Second is a pipeline for hydrogen. Hydrogen embrittlement is a big, big issue around the world. And as far as I know, the Europeans are quite a bit ahead of us on the renewable pipeline infrastructure, because they're studying a lot. And I've attended some of them, and it's a serious concern. And the last one is a proposal to send a demo weld unit onto ISS for aluminum. We've done steel and titanium. Technique, quality, perfect, flawless, same of what you see. But aluminum, I don't believe anyone has tried this on Earth yet. So I would like to propose a miniature that fits inside Bishop as mentioned, and probably something in a few kilowatts power. And the size will be maybe 1 inch OD by 1/8 of an inch wall thickness. It can be done. I've been asked, can we do more with this demo? But I said, let's just do one thing right once. Make it historic. And that'll be it. Come back and do another one, but we can do more after that. Because if I screw up the first demo, if the first weld in 50 years fails, then we might not try welding again for the next 50 years. So make it significant, make it work, make it simple, and then we can plan further, bigger, more complex demos. So for the last two slides, next please. It's really, I don't know who's in the audience. So really just to highlight that for heavy industry, heat affected zone is a big issue. We monitor, we inspect, and I'll be presenting to ASME Robotics in about 2.5 weeks on this very issue. We inspect and re-inspect because we're not certain, and we need to be 100%, 110% certain. And the heat affected zone, the breakage is universal around the world because this is the way it's done, and this is the way they've accepted it. But I'm saying there's a better way. And this is a study by Enbridge. Next, please. And the last slide is a report by Exxon. I think we have an Exxon R&D person here in the audience. I'm not sure. But anyways, using your studies, the girth weld problem is undermatched. The line pipe, the heat affected zone, the softening, as with the rail, are critical issues. So we offer a better technique, a better way to do things, but we are up against very well-established traditional industries that has a built-in interest to keep things the way they are. But that's reality, and that's what we're working with. Michael, that's all I got. Thank you for your time.
Thank you, Paul. Really appreciate that. You know, most folks on this call, most folks in the industry do not have your kind of industrial background, right? So in a way, part of what we're trying to do with this event is intentionally to reach out to folks that are not typically in our sphere and find out what innovations they've got, right? I don't know if you were in the chat earlier, but there was somebody who was asking about heat dissipation in space. For these enormous space-based solar power systems, figuring out how to get the heat off of those systems is really complicated. There is going to be some sort of radiative environment. Somehow you're going to have to hook these radiators together, right? Ultimately, you're not going to build what you want to build in space without figuring out the basic requirements of welding. So thank you for that.
You bet. I'm learning too, because I spoke with Ajit, I think I can mention his name, with Nano, and I learned a lot from him, because when you have an experiment in space, I didn't realize the ISS has power limitations. I always thought, all those solar panels got tons of power, but you don't.
No.
And I don't want to be the first to black out the station. So
that would be bad.
That will go into the history books. Paul Chang, blacked out ISS, bad boy.
Right. All right, we're gonna move back to Dallas. I really appreciate that you were here. Please stick around. Leo, you've already introduced Dallas, so we're just going to start chatting. Is that correct?
Yes, that's correct.
All right, cool. All right. Dallas, I kind of want to bring us up to some current events. Last week was a pretty interesting week.
Yeah.
What made last week interesting for you?
Well, last week NASA came out with their transportation services procurement opportunity for the moon, called LETS, Lunar Exploration Transportation Services. To put that in context, the award they gave to SpaceX on the 16th was for a demonstration mission and a first lunar landing with crew from NRHO Gateway. NASA accelerated this LETS opportunity so that they can have multiple providers or multiple bidders, hopefully, for the transportation services contract to the lunar surface. Much like they have multiple providers for commercial cargo to space station and commercial crew to space station once Boeing flies their second demonstration mission. So the announcement last week was a request for information for companies to respond to 8 questions that NASA posed to industry. If there's a competition, would you compete? What's a hurdle to competing? Other similar questions. What skills and expertise might you need and facilities might you need from NASA? What tasks would you ask NASA to support?
Dallas,
Yes.
I apologize. This is my mistake. I have the schedule wrong.
Oh no!
So stick with this. Randy's gonna come in. Leo, please take it away. Sorry, Dallas, I didn't mean to mess that all up, but my internal team is reminding me I've made an error here.
No, I'll get my references in order before we start again.
All right,
That's
sorry.
okay, but
Leo, it's all you. Sorry, Randy.
Totally fine. Yes, we'll actually be listening more on Michael and Dallas speak right after our next speaker. Our next speaker is Randy Giganti. Randy is a long-term space activist with 30 years experience in building satellites and providing communication services to commercial and government customers, including the Navy, Marines, and the Air Force. He has served on the board of the National Space Society and is currently representing the National Space Society on the board of the Alliance for Space Development. Hi, Randy, how are you?
Great, can you hear me?
Wait, yep, can hear you really good, and I'm so sorry about that earlier.
I'm here to work in wherever you can here.
Thank you so much to The screen is yours.
All right, can you see my screen?
Yep, looks perfect. Thank you.
Okay, so I've been trying to update what we're going to discuss here based on what we've heard today. Quite a bit of information, particularly from Peter Garrettson, and I know you're going to hear a lot from John Mankins tomorrow about some of the more futuristic, more current stuff. But we've talked a lot about public-private partnerships in particular, and just wanted to highlight before we get to the details. The National Space Society has a public-private partnership COTS type program paper out as of a year ago on our website, and one of the many things that's on our website that we're going to be talking about shortly here. So thank you for inviting me today, and on behalf of Michelle Hanlon, who is the president currently of NSS, and also of For All Moonkind, I want to express my appreciation for the foundation for joining the Alliance for Space Development, which was founded by both National Space Society and the Space Frontier Foundation. The Alliance works with Congress and the administration to fund space development and settlement and to embed these goals in the law of the land. I serve on the NSS Policy Committee, which is headed by Jeremy Wainscott. Jeremy also previously served as president of the Alliance, so there's a close relationship between the two groups. I got involved with solar power satellites many years ago when I was first in business school. I was getting my MBA in Philadelphia and working with several space organizations, including Gerard O'Neill's organization, the Space Studies Institute, based in nearby Princeton. I worked with SSI on fundraising and also participated in several of their conferences on space manufacturing, even did a poster paper on solar power satellites, surprisingly enough. As a chemical engineer, though, by training, I was most attracted to the potential for building structures in space from lunar materials. At that time, finding water on the moon at the Institute was considered the holy grail. If you got that, everything was possible. And now here we know water is abundant on the moon, and we are planning to go to the lunar South Pole with people to understand just best how to extract it and how much really there is there. So with regard to space solar power, today's theme, the National Space Society, as you see from this paper, has been at the forefront of supporting this clean energy technology for decades. Let's see here. Screen. I'm going to try to use everything just from our website. The whole idea here is to see the tools that are available here for you to access to make your interest in space solar power a little more useful. We've been supporting this clean energy technology for decades and continue to work hard to ensure that members of Congress and the executive branch understand the potential of space solar power. And whichever nation harnesses this technology first will not only have a huge lead in energy distribution, but can share the technology with nations all across the globe. Again, imagine the huge advances we can make. You've heard already today, clean power, a pristine environment, and energy pouring into the most impoverished parts of the world. The benefits are almost beyond imagining. Unlike ground-based solar panels, space power will be unaffected by weather. Unlike nuclear power, there are no dangerous byproducts. And unlike the burning of fossil fuels, space solar power is kind to our environment. The theme you'll see in what we're about to show here. Other presenters, like I said, John Mankins will discuss some of the latest information. What I'd like to focus on for the next few minutes is why we are doing this in the first place. Constantly have these discussions with friends and colleagues and family members, and it's really hard to get beyond the concepts of, is this a death ray? How is this possible? How can you do such large things in space? So we really have to have tools to break through that barrier first and foremost. So we've developed at the National Space Society a short video tool, 3 minutes long, but can be broken down for various applications, which we use to talk to congressional staffers, investors, and environmental groups on the importance of space solar power. Fabio or Mike, if you could show the video now, we'd appreciate it.
Fabio, that's the video. Thank you.
Dear Earth, we're sorry for all the things we've done to you. We're sorry for coal plants, oil spills, nuclear waste, dirty factories, auto emissions, wildfires, and climate change. We really didn't understand. We didn't mean to hurt you, but our needs got the best of us. Now we know there's a better way, one that will give us everything we need without harming you ever again. Can we start over? We have a new plan, and we really mean it this time. We promise. It's all about electricity. We know, we've tried that before. Coal, oil, gas. Those were the choices for a different time. But we promise to do better because we have a new source of power at our fingertips. Space solar power. The sun provides clean and virtually limitless power 24 hours a day. It is a huge, inexhaustible source of energy that will be kind to you, Mother Earth. The ways we currently harness solar power are a great start, but only provide energy for part of the day and are limited by weather and other conditions here on Earth. And your atmosphere, while we cherish it, reflects about a third of the sun's energy back into space. Solar power generated in space and sent back to Earth frees us from these limitations and will allow us to provide virtually unlimited amounts of energy to the entire planet, night and day. Space solar power is clean, abundant, and the costs of collecting and transmitting it back to you, dear Earth, are negligible. And space solar power is virtually emissions-free and kind to you. We have the rockets and the proven technology we need to start building space solar power now. We may even be able to utilize the resources of your neighbor, the moon, to build these orbiting power stations. We really want to do the right thing, Mother Earth. We're ready if you are. Space solar power will help us to repair the climate and make you healthier than ever. So what do you say, Earth? Ready to give us a second chance? Space solar power is the answer. To learn more and donate, go to go.nss.org/SSP.
Okay, can you hear me again? Okay, here we go. So, can you hear me, Mike? Okay, so
Thank you.
that's again is just a tool, but it's a very effective tool from what I've seen so far. We've done a lot of just tests with different groups. Certainly with younger people, it has a much better effect than with people of our generation. But it is a very effective tool to get. The key is just to get the interest, and it's right on our webpage here, the course Space Solar Power. But that's just the first hook. The question then is what do you do when you've got someone's attention? And so what we created, I think, was talked about earlier today, was the Space Solar Power Library on the National Space Society website. Let's see here. So if you get basically all the research from back to the 70s, you can see we go back way back to earlier than this is the original studies in the 70s as well. But I'm going to highlight just 3 of the many different papers here, just as 3 good examples, because I think it illustrates how you can use this database for your own needs. The first is a solar power satellite built of lunar materials. You see it right down here at the bottom. And let's see here. I'll show you. So basically, I have a hard copy in my, let's see if I can show you. One of the first papers I got back in 1985 was this was commissioned by the Space Studies Institute, and it really still is topical today in terms of exactly what some of the questions we've seen in chat. The primary conclusion at the time was it was possible to design a solar power satellite with 99% lunar materials using existing technologies in 1985 and reduce the cost by 98.7% from the previous Earth baseline. And that was something that was one of the core beliefs of the Institute for decades, because it was something that was really hard to get across to the average person. So radiators for heat dissipation, and particularly heat pipes, were a clear focal point in the study, as we've talked about today, the heat dissipation. I believe one of the things I looked at just today is like a huge, cooling is like 90% of the weight of the mass in the original study. But it didn't mean it couldn't be done, because most of that could come from lunar materials. The second document I would like to highlight is also on this list right in front of you here, is Towards an Early Profitable Power Sat Part 2, which takes advantage of the massive reduction in launch costs via the Falcon Heavy. Let's see here. There we go. You can see that. Okay. So close this up. There we go. So one of the keys there is that it's not just the microwaves that can be used to beam this energy back to the Earth. You can also use fiber lasers that also help you solve some of those, again, those thermal problems. It's still hypothetical, but the key advantage there is that you could actually get a demonstration plant up there about 6 megawatts of power using existing off-the-shelf types of technologies. And you could do that with just a single Falcon Heavy launch. And this is when the Falcon Heavy hadn't even launched yet. So it was certainly very much ahead of its time. But it's something, again, that's in this database that you can go back to to see what was happening just 10 years ago. And finally, most recent document, I think, is, let's see here, if I can go back to that. That's all from the producer standpoint. From the user standpoint, that's really what you'll hear more. You've heard some today, and you'll hear more tomorrow. This is from the Naval Research Labs. This to me, a very good document, because it was comprehensive in terms of how much detail it provided about where we were in terms of state of the art. It's called Opportunities and Challenges for Space Solar for Remote Installations. It states that there are no fundamental breakthroughs required to implement even large-scale solar deployments, and it goes through a detailed analysis of the technology readiness of each level of the technologies. And specifically, the lowest level of readiness is not the thermal radiation. It's more the experience of building these huge structures in space, primarily, and also the actual demonstration of power beaming. So the power, on a scale of technology readiness of 1 to 9, again, these are at a level of 5. Here you go. So this is typically, just to give you an example of the details gone into it. And this is actually a document that's been used to brief members of Congress, this and its successors, to say, look, this is how much has been done, and this is how mature the technology is. Again, something to refer back to when you're looking at the latest technology. I chose these papers, again, as an example of what someone interested in space solar power should review before proceeding with their own activities, whether it be developing new space policy or designing new ways to build large structures in space. I've talked to many people over the past few years. No matter what their hard level of understanding, whether they're a casual space enthusiast or a hardcore engineer, they find it easier to believe in building large space habitats than building large solar power satellites beaming unlimited power to the Earth. When you read just a small portion of this research, you realize that space solar power is not just a dream. It is a core technology whose application is critical to solving both our problems on Earth and our ability to expand into space. So what can you do to help with this vision? Besides, of course, joining the National Space Society, you can advocate with the congressperson and senators to expand the existing research being done, currently now only by the Department of Defense, and even that at very, as we've heard today, in very low levels. What NSS advocates, again, is a test module in Earth orbit providing actual power to a remote location on the ground. The cost of this would be roughly in the $500 million range, spent over several years. It's a small number in the overall budget, whether it be NASA or the Department of Defense, but it certainly would be leaps and bounds beyond what we spent so far. Space solar power is a concept whose time has come, but the U.S. is still just taking small steps to embrace it. We need to take much bigger ones soon to realize its potential. And so I ask you to come join NSS or one of the members of the Alliance, like the Foundation for the Future, and realize the vision of a hopeful human future that this is based on. Thank you.
Randy, thank you so much. I really want to reiterate that the National Space Society has been at the forefront of this idea for literal decades. I mean, just let that sink in for a second. They took a pretty unusual position back 30 years ago in their support of this idea, and you wouldn't have had the resources of Coyote, Garretson, and Quast had not the National Space Society provided a beachhead for them to do the work that they had to do. So really, truly, hats off to the National Space Society. They've been a literal and figurative pioneer in this field for a really long time. So for those are the folks that are with the NSS on this call internal to the chat. I'm glad that y'all are here. But really, this is a message to the folks on YouTube and Facebook that are watching this channel that had not heard this organization. It's a solid powerhouse in the community and an asset. So thanks, Randy. I'm going to turn this back over to Leo to do some of the Q&A, but just for my own, heartfelt thanks, I just want to let you know, thanks a lot for the NSS. And, thanks for Michelle for pointing you our direction on this one. Thank you.
Thank you so much, Randy. I have a question. Space is the next civilization. We as humans must go out into space to continue to break barriers and evolve. But as we continue the acceleration of space access for everyone, we must also combat the climate crisis here on Earth. What are some of the biggest uncertainties we have to overcome to make the momentum of space-based solar power a reality?
That's a question for me?
Yes.
So as we mentioned in the video shows, it's really about getting the people to believe in it. It's just amazing. You can show all the numbers in the world to someone, and they still don't believe it until you're actually going to do it. Any more than they believe Musk could land 2 rockets on reusable rockets until they saw it. It's just, we have to do it, and that's what we've been trying to fight. As Peter Garretson and others have been fighting for years, trying to convince everyone that this is feasible. It's not a scientific problem. It's an engineering problem, and we have some of the best engineers in the world. We don't have enough of them, but we do have very smart engineers that could pull this off very quickly if this became a general understanding that this was what we needed to solve the climate crisis, and mainly to create a hopeful human future where there's unlimited growth rather than limits to growth.
That's actually very true. Lieutenant General Quast earlier stated in his panel that there are many men and women who can advance the technology of power, transportation, and communication to accelerate space-based solar power to solve our climate crisis. In your opinion or in your thoughts, how can the commercial sector help to advance these technologies?
The commercial sector is, again, looking to make a profit. So that's the question is there the case to invest in it today? And talking to even people of the faithful, venture capitalists, and even leaders of the National Space Society said, would I invest my money today in a solar power satellite, my own personal money? Probably not, because I just don't see the return on investment. But do I think it's really critical to do? Yes. So that's been the constant hurdle is that we all know this has to be done, but we don't see how to make a profit of it if we're investing our own money today. We need to have some of the technical risk reduced. I think there's less technical risk personally than people believe. I built solar power arrays for communication satellites for years, and just expanding them is what I see this as. It's a natural expansion. The beaming part, it's been proven that the Japanese have proven it, other people have proven it. It's a question of the degree, not whether it works or not. It's how efficient is it? And certainly it's going to work in space, and we just have to do it, and we have to believe that we have to believe our own numbers. We can't just say, well, the numbers work, but I just can't start it. But again, it's the first. That's that first solar power satellite. I guess fundamentally it's because originally in the original studies, because of the limits of physics, you could not go below a certain size, and I think that's what hampered us for decades, is because we believe we couldn't make a small one. and the big one was too expensive. We really needed to make a small one 20 years ago.
True.
Just to prove it worked.
Yeah, what do you think are some solutions for driving down the cost and getting space-based solar power panels into space?
I hope companies like Made in Space or Redwire, they're going to show us how to do it with more quickly. But the most of it previously was the launch costs, and then of course for me again the holy grail is lunar materials. Taking a mine to a refined product, that is certainly a big step in terms of creating that kind of infrastructure in space. So I do agree that the first one should be built from materials from the Earth, but we should be very quickly getting ready to build them from materials coming from space. And that requires more companies getting involved in the cislunar infrastructure and reducing the risk of using those lunar materials while using those lunar materials for other applications, whether it be energy or just radiation shielding, whatever you need to get that first market. But the real market is to supply solar power satellites from the moon.
Okay. And we have actually Tim Chrisman, who is currently in Akron, Ohio, leveraging opportunities of a new space economy. For those who are watching to learn a little bit about the NSS, what would the economic impact be to small towns like Akron based on a new space economy with the help of the National Space Society?
Well, I hope that we'll be getting a lot more people interested in the potential for green energy and whether it be building rectennas on. I mean, I did most of my career was building the receiving stations for communications. So building those relatively simple structures for creating a huge amount of power for their local communities, to me, that's something that anyone could do at any location on the planet to learn how to do those types of things. And but again, ultimately, it's unlimited energy allows you to do a lot of things that you wouldn't consider today, because energy is finite.
Yeah, I really loved the video that you showed us. I thought it was captivating, and it was one of those things where it's like it kind of it's inspiring, but also it shows the urgency and just how critical it is to get the momentum and the acceleration of space-based solar power. And I loved what you said, that something like that resonates a lot with like the younger generation. Can you talk a little bit of how space activism changed in the last 30 years, and what are some key beliefs or perspectives that you learned early on in your career that are more prevalent as space access for everyone continues to accelerate?
That's good. Space activism is certainly is we've had we have, it's called March Storm every year. We have a lot of people of our age group in the 50-60 range, and we have a lot of people that are students coming out of college. So it's quite an interesting dichotomy to see the different perspectives. And again, it's unfortunate to see that the interest level and political activism has gone down over the past five or 10 years. And I don't think it's just related to the previous president, but it is related to the different perspectives of the generations. But I'm really encouraged that with this type of a theme of melding saving the planet with expanding humanity beyond the planet, that we can find something that resonates with all generations. And I think that this does, if we communicate it in this type of a way, rather than getting tied up in the engineering and technical details of which rocket and what the thrust is and things like that.
Yes, very much so. I mean, we're trying to, here at Foundation for the Future, we're doing our workforce program. So we're trying to go, like Lila said earlier, from K to orbit. We want to start educating and inspiring, kids as early as kindergarten level on to pretty much get them prepared and give them all the skills and education and everything that they need in order to succeed, in order to make this space access much more available and prevalent as generations to come, but starting now, because it is a huge crisis, like with our climate, and space-based solar power is incredibly just urgent to have to get that started, as soon as possible, and with the help of all of these corporations and companies, and being here in this conversation is the start for a lot of people. So I think we're almost out of time. I just wanted to say, Randy, thank you so much for being here with us, for your amazing presentation, and for being a part of the conversations for the future. So if you can, just go ahead and put in your LinkedIn information on the chat to continue networking, so people can see where to find you, and more information on the National Space Society. And for everyone listening, thank you for joining us for this Conversations for the Future, powered by Foundation for the Future. Conversations for the Future is a nonpartisan event about near-Earth space infrastructure from now to 2035. Foundation for the Future is dedicated to the creation of a public-private partnership for space infrastructure development. To support this cause or to sponsor one of our events, please visit our website at www.f4f.space. That's the number 4. And we are grateful for the support of our corporate and individual partners. Now, without further ado, we're going to welcome back Dallas Bienhoff and Michael Lane, which I will give a proper introduction to this time. I know you've seen him, you've heard him. He's been here since the beginning of today, but I don't think no one's ever actually given him a proper intro. So Mr. Lane founded the LiftPort group with the idea that an elevator to space could and should be built commercially. The concept for LiftPort was simple: to develop the subsystems and precursor technologies needed for the elevator, and to commercialize these as a method of payment for the larger, longer-term project of building the elevator. Areas of focus for Michael are robotics, nanotech, and material sciences, finances, and media. So thank you so much, Michael and Dallas. The screen is yours.
Howdy, thanks a lot. I apologize for the schedule confusion a moment ago. I want to jump into some current events with Dallas. You were talking about last week. I actually want to go into that a little bit further, but I think it needs some context. So go back maybe 2 weeks, 3 weeks to NASA's HLS decision, and your opinions on that, right? Like, you've been at this for a really long time. You've seen an awful lot of stuff happen over your 30 plus year career. A lot is happening right now in a way that has never happened since I've been doing this stuff. So just give us a rundown of what you think the last 3 weeks looks like.
Well, maybe I'll go back a little further, Michael.
Okay, sure. Yeah.
And go back to the beginning of the human landing system activity, which began maybe 2 years ago, maybe 3, with some preliminary risk reduction studies and concept studies that that were pursued by several companies, multiple companies, that led into the next procurement, which was HLS for the demonstration mission, the first for option A, which SpaceX, Blue Origin, and Dynetics were awarded contracts to pursue.
Let's break that down just for a second longer, right? 3 big companies. One is kind of an amalgam of other large companies.
Right.
Has that ever happened before? Anything like that?
Maybe not to that scale, but there are always partnerships, competitors that join together to pursue a big project that they can't take on alone.
Okay.
But to the scale that Blue Origin put together the national team with Lockheed Martin, Northrop Grumman, Draper themselves. I think those are the main players. And then Dynetics had, I think they had, I want to say 12 to 25 different partners.
Huge. It's a huge number.
Yeah. But I think they brought in folks with specific expertise that they didn't have themselves. So,
right.
You build an alliance that covers your weaknesses if you're the prime. Mm-hmm. And so that wasn't, to me, that was a way of doing business. It wasn't a positive or necessarily a negative.
But it is different though. It highlights that there's kind of a shift in process. Is that fair?
Well, in one sense, but we still had SpaceX going alone. Boeing went alone, on their proposal. And when it come time to bid for option A, and so, it's the way we do business.
Right.
So NASA awarded SpaceX, Dynetics, Blue Origin, National Team, these contracts to design their architecture for a demonstration mission and a first lunar landing, with the hopes of awarding multiple, i.e. more than one, but probably less than three, awards for a demonstration mission by 2024. And and those studies went on and went through preliminary design reviews, and with SpaceX's approach, demonstration missions that were self-funded, demonstration attempts, I should say, for launching the starships and bringing them back down. 3 weeks ago now, on April 16th, NASA announced that they had selected only SpaceX to go forward for the demonstration mission and the first landing from NRHO Gateway down to the moon for people. And in the announcement, or in the source selection statement, they said that SpaceX had requested $2.9 billion to do that. And the Blue Origin bid was significantly higher, and the Dynetics bid was significantly higher than the Blue Origin bid. And they didn't have enough money to fund two. So they funded one. A week went by, 10 days went by, and both SpaceX and Dynetics have challenged or protested that award. And NASA has, as is typical, suspended the SpaceX award, i.e. they're not going to give SpaceX NASA money to do what they had proposed to do in their winning proposal. Doesn't mean SpaceX stops because they're spending their own money. And matter of fact, SN15 may launch today or tomorrow.
It's scrubbed for today.
Oh, okay.
As of a couple hours ago, I haven't reviewed it, but I am watching it.
So, and then on Thursday or Friday of last week, NASA issued a request for information. And what that request is, it's entitled Enabling Industry Readiness for Commercial Lunar Space Transportation Systems. So they want to know, NASA wants to know, what is the interest in the community for bidding on the transportation services part of human landing systems, or Artemis? And again, this is akin to the commercial crew opportunity, where NASA paid multiple companies initially to develop concepts, and then they picked two to go forward to implement, Boeing and SpaceX. And that was for the demonstration missions. And then they had a competition for actual transportation missions to the station. And so this is following that similar path. And in this request for information, NASA says, we want to know if there's interest for providing routine cadence of human transportation from the gateway to the lunar surface and back to the gateway. So it's not from Earth orbit, it's not from anywhere else. It's from the gateway to the moon, to the gateway. It's for humans. It's not for cargo. It's for humans.
Right.
These questions were asked and answered during the industry forum on Monday. And this is this RFI request.
The industry forum yesterday, Monday.
Yes, Monday.
Right.
Yes,
this is happening very fast. This is happening in real time, right?
In real time.
Yeah.
And so this request for information is to help shape a precursor procurement under the next step 2, broad agency announcement, to do some risk reduction, some requirements definition for sustainable crew transportation that will lead to the Lunar Exploration Transportation Services award of one or more providers.
So hold on a second, right? This is NASA speak, and it's deadly dull, and they're taking possibly the most exciting thing they have done in decades, and they're putting in the language that is frankly like sleep inducing. But what they're really asking for is they're going to the commercial sector and saying, we want to figure out how the commercial sector get people from the gateway to the moon and back, right?
Correct.
And this is their process. So even though it's deadly dull, the process, the result is super, super important.
It is, and it's you know, NASA is gonna provide money to develop the systems, not necessarily all, but some.
Yep.
And the companies that bid really have to figure out how they can turn a profit by spending their own money to compensate for what NASA does not provide, and to make sure that they make money, they recoup their investment in 2 to 6 launches over 10 years. Which means you really need to know if there are other customers out there.
Right.
And you know,
it's a customer discovery exercise, right? And it's multiple organizations, right? So 2 to 6 missions over, what'd you say, a 10-year period, right?
10 years.
All right. How many missions, and I know the answer to this, I'm doing this, I'm feeding you this. How many missions were in the Apollo missions? How many?
There were, to the moon, there was 11 to 16. So actually 6 actually went toward the moon. 7 went toward the moon because 6 landed.
So this is equal to and in addition to the original Apollo effort.
But not as fast.
And it's different in that it's got more, there's more money, right? There's more money allocated if you start thinking about all of the parts.
I don't think there's more money allocated. There's more money allocated due to inflation.
Okay.
But I don't think NASA is spending more money than they did on Apollo, purchase power wise.
It feels different. I'll look into that a little bit.
So yeah, and so NASA wants to offer companies the opportunity to do some risk reduction, i.e. solve some problems that they identified in the source selection statement with Dynetics or SpaceX's proposal, or not SpaceX, Blue Origin's proposal, like propellant transfer or propulsion systems, or you're too heavy versus what we think it should be. You know, your system doesn't close, i.e. it won't perform the mission like you say it will.
Right.
And so this request for information leads up to a multiple award of up to $15 million or a 7 to 12 month study period, leading up to the procurement of transportation services, which would be the development and building of a system that could do this demonstration mission and a landing, much like SpaceX has been awarded already. So they're asking questions like, and I've got it in front of me now so I can actually get the questions right. If NASA were to do this $15 million opportunity, I'm paraphrasing, would you be interested in competing?
Yeah.
Well, okay, yes, why not? You know, 15 million, sure. For 7 to 12 months, that'll support a few people. Would your firm be interested in competing for the transportation services acquisition for recurring services to the moon? Okay, so If I'm SpaceX, or not, I keep saying SpaceX, if I'm Blue Origin or Dynetics or Boeing or somebody else, the answer is probably, yeah, we would be interested in competing. Okay, so no caveats at the moment.
Right.
So NASA says we're interested in, we're considering making up to $15 million awards of approximately 7 to 12 months. Comment on the viability of this amount and time span. Can you spend that much money? Can you do enough things in 7 to 12 months to help you prepare for LETs? Okay.
Okay.
We're going to provide, we, NASA, are going to provide subject matter experts, equivalent personnel to assist you, industry, in doing your efforts. Comment on what skills and expertise would benefit your firm. Okay. What skills do you lack? What expertise does NASA have that you could use to help in your bid? And by the way, use our people.
Right.
And that gets counted into the value of what you propose.
That's the Space Act agreement that's kind of presupposed.
Space Act, right? Or task, they call them task agreements when they're under opportunities like this, but yeah.
Yeah.
And then another question is, NASA is considering providing unique resources, i.e. what specific facilities could you use that we have to help you spend during your time on these 7 to 12 months? Like maybe a large vacuum chamber.
Right. Yeah. Shake and bake.
Wind tunnel. Like that. You know, maybe a suborbital test flight.
They're asking for a wish list of all of the NASA resources that you might need to.
Right.
Yeah.
Would maturing the HLS sustaining requirements, i.e. what does it take to continue to put people on the moon? Would it help you if we did that before the solicitation of the procurement? Should you know the requirements before you start?
Right.
I think yes.
Yes, it would be good, right?
Be good. And don't change them after we start, by the way.
Right. Yeah.
What other tasks might benefit your firm? And then what other factors could enable industry to compete for the acquisition that could be incorporated into the BAA, this new opportunity, this $15 million opportunity? And I think that last question is probably the most difficult one for NASA to meet. Because my reaction is, if you want me to compete, you really have to level the playing field,
right, between
where we are today and where SpaceX is being paid to get to for the competition. You know, and that means you got to kind of commit to giving everybody that wins an award under the transportation services contract $2.9 billion.
That would be nice.
At a minimum, to offset, to level the playing field that SpaceX has.
So I'm going to read in, Dr. Dodson asked a question here a moment ago about, and I'm going to come back to that in a second. I'm going to read his question.
Well, those are my opinions, by the way.
No, right. Absolutely. We're all using that opinions. Is the hope within NASA that the initial selection of only a single partner, SpaceX, will push Congress toward greater appropriation to accommodate selection of at least one more? Is this a bit of maneuvering or brinkmanship? Well, I'm personally going to answer yes, I think it is, but I want you to answer that question in the context of what you just said a moment ago, where is this RFI trying to establish a basis for the rest of the commercial community? Are those two things linked? I don't know that they are, but I have a hunch that they might be.
Let's see. I'm going to start again, kind of at the beginning of this award. The award that SpaceX got is for a demonstration mission, i.e., not occupied,
right,
and an occupied lunar landing. they don't have a lock on getting a services award. The services award opportunity that's coming up is a way, the path that was always in place to get competition for services. So while NASA had hoped to be able to afford 2 demonstration missions, so you have a greater chance of one succeeding, there was always the plan to get multiple players or multiple bidders for the services award. Multiple people have said the same sentiment that you said, that maybe this was NASA leveraging, giving one award to get Congress to give them more money to give a second award. That's possible. But if I'm a buyer and there's a product, say an iPhone,
right,
I can get for $500 from somebody, and I can get that same iPhone from somebody else for $1,000, which one am I going to buy?
Right.
I'm going to buy the 500 one, as long as I know it's a legal source.
Right.
And so I don't really see, and Congress in their confirmation of or hearing on Bill Nelson as administrator, some of the panel members asked that question.
Okay.
Is Mr. Nelson, does he approve of the selection? Is he going to stand by the selection? Is he going to seek competition, et cetera? And then other panel members think that only NASA should own and operate that system, whatever it is.
Nelson was very against the commercial development of space for a long time. I'm really curious to see how the new administrator.
I think he expressed support for what's going on, and the administration is expressing support for continuing what's going on in the space community. So for that, I'm relieved that we're not taking another left turn.
Right.
And restarting whatever it is we're going to do next, as opposed to what we're doing now. So I don't, with this transportation services opportunity around the corner, i.e. a year from now, at the inside, I don't see a need for NASA to make a second award for option A, the demonstration mission. They will get that under the LETs.
Okay.
The one thing that can't be done with this is shorten the time span that, or lengthen the time span that these new players will have to build and operate their system to compete on an even keel with where SpaceX is going to be, having a year head start, and actually more than a year, but they've been spending their own money. So that's, more power to them.
Right.
So I don't know where it's going to end up, but I presume that SpaceX will continue. SpaceX will finally be allowed to spend NASA money and implement the contract. And there will be at least one, if not 2 other bidders for the service contract when it comes due.
So Charles asked a question about how many lunar landings are anticipated over what time frame.
Okay, so
a lot of stuff heading towards the moon.
Yeah, in the briefing that NASA gave yesterday, and it's all available now on their website, on their Next Step 2 website. I haven't downloaded it yet, but it's allegedly there. NASA said we want to do 2 to 6 missions between 2023 and 2033. We know what we want to do. We don't know what we can do because we don't have the budget to do anything. And that 2 to 6, I interpreted from what I heard. I haven't gone back and proved it yet. I interpreted that that's 2 to 6 per service provider awardee over 10 years. So, you
So
know,
multiple awardees then.
multiple awardees.
All right.
And
Is that 2? Is that 3? Is that 4? What I'm trying to figure out is X times 2 to 6. I'm trying to figure out how many full missions we're talking about.
there,
Is there a guess?
there should be at least 2 awardees.
Okay.
There may be 3. I don't know.
So,
They usually say 1 or more.
Okay.
And I think in the original, in the award that was in the request for proposal that was just awarded to SpaceX.
So
it said like there's 1 mission a year to the moon.
Okay.
Because that's what SLS Orion can support.
Okay.
1 mission a year to the moon. So if there are 3 providers and you're talking 10 years, you're going to get maybe 3 missions in 10 years from NASA.
Right.
So where do you get the other missions to make your money back?
Right. Commercial. You find clients. You get.
Exactly. You gotta have people signing on the dotted line saying, "Yea, verily, I will fly if you're available for something less than this price."
So Kevin in the chat got to where I was trying to get to.
Okay.
2 missions times 1 to 4 players means maybe 4 to 12 missions.
I would say no more than 10.
No more than 10. Okay.
And two to 3 of those years are going to be for development and certification that your system's ready to fly. So there may be 7 total from NASA.
Okay.
From NASA. For 2 to 3 to 1, 2, or 3 players.
For human missions, but robotic missions, quite a few more robotic missions, correct?
Well, and those are covered under the Commercial Lunar Payload Services contract, which SpaceX has 1, Blue Origin has 1, and 12 others have 1 for varying degrees of payload from 50 kilograms up to.
Astrobotic has stuff. Maston has stuff. Yeah.
But their payload sizes are 50 to 300 kilograms total, except for Blue Origin and SpaceX. You know, SpaceX can do 100 ton allegedly, and Blue Origin can probably do 4 to 6 with the Blue Moon as a truck,
right,
and go in one way.
So I hate to do this, but we do have to wrap up here in a moment. In summary, we're looking at something in the neighborhood of, in your opinion, 7 human crewed missions. And then if you add in various CLIPS missions.
They're like 2 a year.
2 a year. 2 a year. I mean, just let that sink in for a second, right? Commercial missions to the moon, 2 missions, at least 2 missions a year for a decade.
Right.
I mean, we're talking about 20-ish, 25-ish missions to the moon really soon. Like that changed. That's what I meant earlier about, I made a mistake when I said budget, but what I should have said was activity. There's a whole lot more activity.
Right. And the CLIPS program, Commercial Lunar Payload Services program, most of those landers have multiple payloads, multiple customers, with only 1 or 2 of them being a NASA customer.
Correct. I know that Astrobotic has been selling or attempting to sell services to the moon for at least a decade now. They have a roster of a lot of potential or likely or confirmed clients.
Right.
And
they have 2 awards for landings. One is a condominium lander, if you will.
Right. Lots of what do you mean by that is lots of little payloads in one box. Yeah.
Right. On one lander, you know, spread around. And then they have the Viper, which is the explorer for lunar ice, on another one. And Intuitive Machines, I think, has 2 landings.
Yep.
Aston has 1. I think there are a total of 6 awards at the moment.
again, let that sink in a second. I mean, that is a different kind of world than we are used to from the Apollo days. If you compare it to the Apollo days.
And even the last decade, we couldn't go to the moon. NASA
Right.
wasn't going to the moon.
Nope. Nope. I'm personally I've been at this for a long time. I am more excited about what we're doing in space than I have been in my whole career. So it's exciting to me. I think the potential for humanity is off the charts. So,
and look where we've been. Look where we've been since the Vision, 2004. We're going to the moon and on to Mars.
Yep.
The Vision, which was
Right.
the same as the Space Exploration Initiative in the 80s and 90s.
Right.
Oh, we're not going to the moon. We're going near the moon and maybe go after an asteroid and bring it back to the moon.
Right.
So we're not doing that. We're going back to the moon to stay and on to Mars. I'm glad we're still on the back to the moon and on to Mars path.
Right.
Rather than, oh, we're going to go to Mars first, or we're going to go to Venus first, or something else, rather than continuing the path we're on.
Yep.
Very pleased for that.
I agree. I mean, there's been bait and switch a dozen times in my career, but this one feels real.
Right.
And that it's got 1,000 companies that are raising capital to do different parts of this overall infrastructure. I think that's important too. So fingers crossed. All right, Dallas, thank you so much. Appreciate your time and your insights. Your wisdom is very helpful to this community. I'm passing it over to Leo. Thanks a lot, sir. Appreciate it.
Bye.
Yes, thank you so much, Dallas. And thank you, Michael, for that amazing discussion. Again, I think I saw it earlier, Dallas, but if you could just go ahead and put your LinkedIn link back in the chat and comments so we can continue the networking benefits of this event. And again, thank you for joining us on Conversations for the Future, powered by Foundation for the Future. C4F, as we say, for Conversations to the Future, is a nonpartisan event about near-Earth space infrastructure from now to 2035. Foundation for the Future is dedicated to the creation of a public-private partnership from space infrastructure development. To support this cause or to sponsor one of our events, please visit our website at www.f4f.space, that's the number 4. And we are grateful for the support of our corporate and individual partners. Now, without further ado, we have our Foundation for the Future founder, Tim Chrisman, who is on location at Akron, Ohio, where he will be talking about the Space Corporation Act, which is currently being seen at Congress as we speak. Tim, are you here?
Sorry about that, Leo. Yes, I am.
No worries.
I've been on location in so many places today that I have no location. That is
You're everywhere and nowhere all at once.
Exactly. But yeah, so I'm going to take some time here this afternoon to talk a little bit about the Space Corporation Act that we have in front of Congress right now, where we're at with that, and sort of the glide path to victory, so to speak. So I'm going to share this presentation here, and we will go from there. So I start this presentation with the sort of imagery of crossing the chasm, and I do that intentionally because it's a marketing term, and we'll get into that a little more later, but it really evokes the feeling of where we're at as a community. And it's been a thing in the space community for decades. We've heard a lot about different programs and processes that have been going on for decades, and it almost seems rinse and repeat. And in many ways, that's because there's a mismatch in expectations and mandates. So I'm a former Army officer. I'm always told, tell me why you're talking to me first. And so I'm sort of laying out the problem before I go into why we have the Space Corporation Act to start with. And most of this was a surprise to me when I went through and learned a lot about NASA in particular, because as an outsider to the space community, I kind of had the stereotypical assumption that NASA equals space. If it's in space, it must be NASA. And then once Space Force started emerging, then the obvious assumption was, well, now Space Force does all of the military things and breaks stuff in space. But realistically, there is a huge amount of work being done in space or for space and around space. It doesn't involve NASA or Space Force. But for the purposes of this, there is a case to be made that we ask NASA to push the frontiers of knowledge. That's their literal mandate from Congress. But who then follows behind and develops that? Space Force has been given the mandate to secure the space lanes, so to speak. But what are they securing? Who's creating that stuff that they're protecting? Because protecting space just to protect space is not any use at all. And then we've heard a lot, and it continues to be true, that this private sector drives innovation and moves fast, breaks things, and makes great things happen. But how do they have the basic backbone to do that? Jeff Bezos once said he didn't build Amazon on his own. He had roads, rails, and the US Postal Service to help him, and he couldn't have done it without that. And the same can be said for the space economy. Who is making the Postal Service for space? So now let me give you a quick orientation to this idea of crossing the chasm. Apologies if you've read either Gartner's book or anything by G.A. Moore. But the general idea is when there is a hyped up set of expectations, you're going to disappoint. It's basic human nature. Expectations don't match reality. We get upset. And so that has been a cycle the space community has been in. I grew up reading Tom Swift Jr. books, and those were written at a time when space seemed exciting, adventurous, and new, and they mentioned dates in those books that we're living in now. And I have none of those things that Tom Swift had, or maybe I do. I guess I should go look. But the point remains, we've gone through several of these cycles where we've gotten excited. We landed on the moon, and then what? We had a space shuttle, and then what? And what we at the foundation want to do is bridge that chasm between the current excitement and hype around the private space economy and what we need to do to gain and maintain the attention of the rest of society. Because honestly, the vast majority of people we interact with that are everyday Americans don't believe space is real. Oh, they believe it's there. We very rarely encounter flat earthers, but they don't believe it's something to ever realize as a place to go invest in or build lives in. And so we have to bridge that gap. And we do that through, as Jeff Bezos pointed out, things like the Postal Service. And so that's why we talk infrastructure. And we talk infrastructure not just because civil engineers tell us to, but those, I'm told by civil engineers, are reliable people to talk to about infrastructure. No, we talk about infrastructure because that is a place for government to put its money that has an outsized effect on the growth of an economy. Dozens of studies over the years have shown there are places where government spending is useful. And when I say useful, I mean it returns more money to the economy than the government spends. There are places where it's useful and there are places where it's not. Infrastructure is one of those places where it is most effective. Estimates range from 50 to 150% return on investment for every dollar that the US government invests in basic infrastructure. And that we see right now in the news animating the conversation around the infrastructure bill proposed by the new administration. Now, that bill, last I checked, and based on some anecdotal evidence and analysis done, has about $60 million worth of projects for space. That was million with an M. And yes, you are thinking the same infrastructure bill. I am the $2+ trillion bill. There is basically nothing investing in space. And our proposal really comes down to this. Decades ago, we invested as a country in GPS. We spent nothing. $12 billion. It was for a defense application. And it returns, that system returns almost that same amount every day to the US economy. And its cumulative return on investment is something on the order of $1.5 trillion. That is amazing. And so when we talk to Congress and others, our proposition is very simple. We need to make space boring. We need to make everything about it, going to, coming from, going through, safe, routine, and a background sort of idea, kind of like the commute home, where you don't even remember what you passed if someone were to ask you. It wasn't that you were sleeping, it was that your brain turned off because you've seen it so many times it doesn't matter. Now, in an environment where trillions of dollars are being spent, there's aggressive lobbying being done for this infrastructure bill and the subsequent iterations of it. Why do we think what we're proposing should even be listened to, much less will catch the attention of policymakers? Our answer is usually pretty simple, and it is, we can do this for virtually free. This was done in the 60s through the creation of the Commercial Satellite Corporation, where the US government chartered a corporation. If you run your own business, you had to incorporate your company in a state. A lot of financial companies do it in Delaware. Turns out they have really good court systems and favorable tax law. I wish I had known that when I incorporated my company. But in this case, it was an act of Congress. A literal law established this private corporation that went on to be listed on a stock exchange. Cost virtually no money. There were some upfront setup costs to pay basically incorporators to develop the plan. But otherwise, once it listed on an exchange and raised capital, that was it. And it had a mandate to create a commercial satellite communications network to serve the US government worldwide. And it did just that and was a phenomenal success, being sold, I believe, in 1999 for several $billion. And our proposal to Congress is it's time for ComSat 2. This one with a broader mandate and more aggressive timeline. Mandate to create space infrastructure, expand sustainable employment throughout the US economy in such a way that we truly can realize that every job can be a space job. Just like in the 90s, when cyber evangelists were saying, look, the internet's a thing, it's just going to be internet jobs in the future. We laughed. Morgan Stanley and Goldman Sachs analysts are already starting to say the same thing about space. Maybe it's time we don't laugh. This corporation will also have a mandate to ease access to patient capital. Right now, the space economy is funded almost exclusively by government or venture capital. This, in essence, means it's funded by short-term sugar. It gets candy, it stimulates, goes wild, and then needs more in a relatively short amount of time. No other sector for infrastructure investment does this. Everything from roads, bridges, ports to schools is invested in by private equity companies with 10 to 30-year investment time horizons. And they are very successful in that endeavor. Space is not a domain where those organizations invest right now because it's seen as too risky and too volatile. And so this corporation that we are proposing to Congress would ease access to that capital by buying down risk. It would eliminate, or at least reduce, we like to be aspirational, reduce the uncertainty of the political cycle, further buying down risk. So as we've heard, it's no more go to the moon, no go to Mars, no go to an asteroid, no go to the moon, no go nowhere. And that's what ends up happening, is going nowhere. And so what this would do is smooth that out by providing multi-decade long investment packages to sustain momentum for key projects that do the first 2 points: expand employment and create the basic backbone infrastructure. Well, how would this look? How would it do it? Well, for starters, it would be a for-profit company. Government does a lot of things well. It makes driver's license. It does not move fast, and it often is very risk averse. So a situation like this calls for a merging of the best of the private sector and government. The private sector can innovate, adapt, and overcome very quickly. The government has extremely patient capital. We're there to merge that. And we're going to do that through giving this corporation the authority to work with the US Treasury Department to issue loan guarantees for bundled projects. Right now, InQtel, the intelligence community's venture capital arm, bundles its investments with other VC and investment firms, basically at a 20-to-1 ratio. So this organization shows up, finds a company that's developing a technology it likes, and it then invests a relatively small amount, serving more as the sort of risk buy down or good housekeeping seal of approval. And the rest of the private equity market then shows up with the rest of the capital. The Space Corporation would aim to do the same thing, putting out a relatively small amount of capital to bundle with those large institutional investors that have trillions of dollars under management. This corporation would also have the authority to issue treasury bonds. Again, this would be in consultation with Treasury to fund the creation of long-term projects backed by the full faith and credit of the US government, providing essentially free access to capital for companies that are thereby going out and actually building projects of national interest and of social benefit. And this corporation would also have the authority to develop SBIR-style loans to innovate and provide rapid access to novel new technologies and fund workforce development. Here, I normally go into fairly detailed, at least for me, I'm not really big into details, explanation on the different categories of investments for the Space Corporation. We tend to bundle them in 3 categories. The first being access, or going to, from, and through space. I like to talk about how this whole bill is on iteration 33 or 34. And one of the changes we made was access used to be to space. And we had a number of people point out, cool, we can get to space. Right now, bringing things back from space is exceptionally hard. It's basically just falling in a metal container, hopefully into the water. And that's about it. Once Starship is able to basically do 100 tons to and from orbit, all of a sudden, the game completely changes in terms of what you can bring back from space. Now, mining in space doesn't just have to be used there, it can be brought back. The same with anything else made in space. And also through space. Turns out people like knowing where they're going, and it's a little known fact that GPS points down. You don't think about that because we're all down. But out of orbit, you do need a new form of navigation and timing. And so those are the sorts of investment categories when we talk about this on Capitol Hill that we mention. The second category is the sustainment, or providing a subdivision in space where entrepreneurs, people, and companies can plug, pay, and play, whether it's commercial stations in LEO, manufacturing hubs at Lagrange points, or funding the creation of strategic fuel reserves for Space Force, NASA, or others. These are the sorts of investments that sort of jumpstart a virtuous cycle whereby companies now need to make things in space, driving down the price of making it, and rinse and repeat. You get the picture. The final category is probably the most important in our discussions on Capitol Hill. And it's the ones focused down. We call it support because we needed a word and it's worked. But the general idea is the industrial base on the ground to build a space economy and those things in space that provide material benefits to the ground, space-based solar power. These are investments that we throughout the country can see tangible results of, and that can be quick wins to build momentum around longer term projects. As we've heard today, the main problem with space-based solar power is profitability. And it's not a technology issue. There's some validation that needs to go on, but for the most part, it's can you make the money? Well, you can't in a venture capital arena where you're having to be bought out in 5 to 7 years. But if it's a 30-year investment time horizon, that changes everything. So as we move out and are on Capitol Hill, talking, socializing this, we come back and we talk to you all in these events about what's going on. We're often asked, cool, what is it you're doing on Capitol Hill and how long is this going to take? Well, there's two parts to the advocacy we're doing. Part one is where we're at now, and that's where we essentially have 535 customers. Every member of Congress is one of our customers. They all have staff that we interact with, but ultimately we need about a dozen of them. And we need that amount because we need people who are willing to step up and be pathfinders. We're willing to say, yes, this idea is good. I'm going to push it through whatever committee I'm on. I'm going to attach it to whatever bill needs to be passed anyway. And then we can move forward. Unfortunately, we're competing with roughly 14,000 bills that are introduced every Congress. So far, I think we're up to about 7,000 already. And that's a lot of noise to ask Congresspeople and their staff to filter through. Additionally, we're in an environment where something on the order of $4 trillion is going out the door in a matter of months. That produces a sort of risk aversion to new money outlays or anything that appears to ask for additional appropriations. And so our pitch comes down essentially to you can create a tool that will unleash an entire sector of the economy for less than the price of a cup of coffee every day. It's not a great pitch, but it at least gets attention, and then we can deliver the rest of what we're talking about. And that's where phase two comes in. Once we've created this organization, once we're standing up the Space Corporation, then we have to authorize at least some sort of operational expense for the setup of the corporation. Obviously, the more that's appropriated, the less dependent the Space Corporation would be on any capital raise in the markets. But ultimately, that's a heavier lift. And we're targeting a smaller subset of Congress, those members of the House and Senate Appropriations Committees who essentially have the ability to kill or create funding proposals. Now, we don't know what the competition is for the Space Corporation when it gets to this part, but quite likely it will be competing with major projects that have key constituencies across the country. It'll be in a time when new earmarks are coming back. These are the sort of member-driven investments that had a number of scandals in the past, but essentially give the ability for Congress people to direct funding for their districts. We're also in an environment where if I say something and I have the wrong letter after my name, those with the other letter decide I am the spawn of Satan. Now, space is unique in this hyper-partisan environment. Bill Nelson was just sworn in as the new NASA administrator, and Jim Bridenstine was right there with him, as were other members of the former NASA team. And Bill said this when he was asked about it. He said, "Space is nonpartisan. Jim did amazing work while he was here. I hope to be able to continue that." That's the sort of thing we want to hear from public servants. It shouldn't be a constant knife fight. We want people to say, this was good, this was bad, this is how I'm going to build on it, instead of trying to go back and forth bickering. But ultimately, our value proposition in this phase is we're a pay it and forget it sort of proposal. This is not a coming back to Treasury constantly. This is a once and done sort of COVID stimulus sort of bill, although basically with a fraction of the price tag. And then you now have tools that unlock national security and innovation, like what we talked about with General Quast earlier. So that gets us to you. How can you help? Well, as we've mentioned a couple times today, we have an open letter to Congress that we're circulating in the space community right now. Companies like Lockheed and Boeing are reviewing it. Several dozen companies have already signed on. If you run or are a senior member of a space organization that we've not yet talked to, and you're interested in throwing your weight behind this open letter, please reach out to me, reach out to Lila, reach out to any of the team. The letter essentially says, we need to invest in space infrastructure. Here's a proposal to do just that. You should consider it, Congress. It doesn't say I'm selling my firstborn child to support this bill. No, we know that whatever is done in terms of investing in space infrastructure is better than where we're at. And that's what we're trying to get to. The second thing you can do is contact your congressperson. We need help advocating to congresspeople and their staff. We need pathfinders in every state who are willing to stand up and say, yes, I'll talk to my congressperson. If needed, I'll write to them. So again, if you're interested in that, please let me know. The final one is we need a broad financial base to support us as we go forward. And so whether it's corporate membership, where you are able to sponsor events and the foundation as a whole, or charitable donations. Since we are a 501c3, we're able to provide tax benefits to donors that then enable our activity, whether it's workforce development, scholarships, or advocacy. Ultimately, these three all work together because the only way we're making space real is by exceeding the threshold of credibility to such an extent that we are seen as super credible, and then we can then reach across the chasm and make space real for the rest of us. I'll end there and leave the last 40 seconds for questions. I yield the balance of my time, Leah.
We have Gary who asked, who introduced the Space Corporation Act? Like, how did this come about? Can you talk a little bit just in the last couple of seconds? If you can, I know like, there's not a lot of time, but a little bit more of like the inspiration behind such a critical act such as this one.
Yeah, so the Space Corporation Act is pending introduction in the House and Senate. We have about 80 members of Congress who have indicated their willingness to co-sponsor the bill once it's introduced. And we're in negotiations with a couple dozen to be what's called original sponsors, or the ones that put it in, introduce it, and then shepherd it through its committee and hearing processes. Some background on the bill. It emerged over the last year or so by taking the Commercial Satellite Corporation Act, taking the Tennessee Valley Authority Act, and merging those together with other congressional acts for the Overseas Private Investment Corporation, and sort of making a blend of the best tools that have been used for ambitious infrastructure projects, while then whittling away the regulatory or other irrelevant pieces.
Awesome. Thank you so much, Tim. I think we're actually on the dot, but thank you for talking about the Space Corporation Act. For everyone watching and listening, you can find more information about this very critical and important act by going to the Foundation for the Future's website at www.f4f.space. As Tim mentioned, the Space Corporation Act gives access to everyone, not just private establishments, to space. This is why we talk infrastructure and its importance and benefits that it gives us to continue to advance. Throughout Conversations for the Future today and tomorrow, we will be talking more about the acceleration of space infrastructure with the help of this bill. We will also host Infrastructure for the Future, a Foundation for the Future, with co-host Kevin O'Connell, former Director of Office of Space Commerce. Infrastructure for the Future will continue the conversation and critical discussion of having America lead in space again. Don't miss this event Monday, May 10th by RSVPing on Foundation for the Future's website at f4f.space to watch it live. And as always, thank you for joining us for Conversations for the Future, powered by Foundation for the Future. Conversations for the Future is a nonpartisan event about near Earth space infrastructure from now to 2035. F4F is dedicated to the creation of a public-private partnership for space infrastructure development. To support this cause or to sponsor one of our events, please visit our website at www.f4f.space. That's the number 4. We're grateful for the support of our corporate and individual partners. And now, without further ado, we will have a panel with Will Henry. Will Henry is a filmmaker and writer, best known for producing and writing the documentary film, The High Frontier, the untold story of Gerard K. O'Neill, which is what this panel will be about. Will is the creative director at Multiverse Media, a media group focused on space exploration, science, and technology. Just to give a little bit of intro, The High Frontier is a documentary film about the life and influence of Gerard K. O'Neill, told through the eyes of his peers, family, and the younger generation he inspired during the 1970s and 80s, who are now leaders in the modern day space race. Through old stories of Gary, as Jerry, as many called him, and the social impact he made on the world, this documentary pays tribute to the unsung hero of today's space race, while hoping to inspire all ages and walks of life to reignite our planet's space venturing spirit. Hi, Will, how are you today?
Hey, how you doing? I'm great. Thanks for having me.
Thank you. Let's start with you and give us a little bit of an intro for us and more of an insight on the documentary.
Yeah, well, I think you kind of nailed all the things I would have said. So the information's already there, I think, in a way. But yeah, my name is Will Henry. I was the writer and producer on The High Frontier, which just came out. It's now on Google Play, Fandango Now, Apple TV, all these other platforms as well. I'll put in the chat. It was a film that was executive produced and financed by Dylan Taylor of Voyager Space Holdings. And we partnered with the team over at Subtractive in Santa Monica, California, which is a space production company. It was a really awesome project. It took us about 3 years to make, and we got to do something that I think Jerry O'Neill would have been very proud of seeing after all this time, which was recreating some of the O'Neill cylinders in 3D animation that he always wanted to see.
Very much so, which is one of the things that I was going to talk to you about, which, by the way, we have Lila Gislason, who is our co-founder at Foundation for the Future, who will be joining us here for this panel. I've watched this documentary, and I actually have it on Apple TV. And as I was watching it, one of the things that caught my eye immediately, or what made me ponder, was how much he probably would have been fascinated with just how much his influence has spread on not just the people who are in the industry for space, but also many people who are space enthusiasts as well, who see this and think to themselves, wow, like my children could probably live on this. This is a reality. Fortunately, he didn't get to see the advancements that we are, or where we are today, but putting that out in the format that you did in the documentary was not only compelling, but actually really, really, really beautiful.
Thank you.
How was it that you came about doing that?
Well, there's a lot of answers. And you're right. I think it's a little bit of a tearjerker to realize that Jerry will never get to see these because he passed in 1992. But he sacrificed a lot to make today possible. And I think in a lot of respects, we may not even be sitting here without his influence. A lot of the people who run the industry now are so-called Jerry's kids. And those are people who were initially inspired to work in the space industry by Gerard O'Neill, spent their entire life creating either private capital or new businesses, or were inventors, scientists, what have you, media people like myself, to go out there and create this vision of the future that would allow private citizens to succeed in space. And that's exactly what's happening. So I think he'd be very, in the words of Frank White, I think he'd be very, we're sorry he's missed it because it's really exciting. But the process of getting to doing it, I mean, there's a lot of answers for that. I think that, we went through many hoops to get this film made. But I think the common denominator of all of it was that this film would not have existed without the O'Neill family, the estate. They opened all the doors for us to be able to speak with all the people who are in the film. And many people, they also provided things like his unheard of and unpublished autobiography, and things that just the world had never seen and didn't know existed. And the film really exists because of the doors they opened for us and allowed us to do. And then we just took the money and invested it in smart ways and making it entertaining to watch too.
Yeah, very much so. Like when I was watching it, it was interesting to see how back in the day, people who were not just specifically in the industry, but also people who were fanatics of, at the time, like they were huge fans of sci-fi and whatnot, and how they were looking at this and thinking the things that I'm seeing on TV could happen in my lifetime. And very much so, I think that that's what we're doing at this moment, is we're talking about that. But none of that would have been possible without his amazing influences and what he was able to do at his time. Even though he thought at some point, I was watching it, he said that what he would like, pretty much everything could have been possible in the late 80s. And that obviously did not happen. And now we're talking about the near-term future and the advancements that we could do, which are every day now in this day and age, every year. I mean, even just like every other day or so, we're watching the news and we're seeing bigger and better advancements because of how, I guess, like all of these ideas that we have, and none of that, a lot of that wouldn't have been possible without his help, without what he did. So can you elaborate a little bit more about that?
Yeah, I mean, you're absolutely right. I don't think we would be where we are today without that inspiration. That definitely resonates in the movie. I also think that he knew that it was going to be private citizens who either made this happen or brought it to the government to make it happen. And yeah, he definitely thought it was going to happen by the 80s, but that was also with a lot of caveats. He knew that it likely would not happen by the 1980s. It was more of, if the government did backflips to get this done, then yeah, maybe we might have seen it in the 1980s. But he knew it wouldn't happen. But he did think that, you know, by today, 2021, that we'd at least have one up there, that we'd at least have one of those O'Neill cylinders up there. I think he'd be a little disappointed that it hasn't happened, but I also know that he was a very practical person. He was a little bit of a romantic at times, but he was a very practical person, and knew that things like this were going to happen, that there was going to be a pause for NASA. There was going to be political issues that got in the way of him achieving these ideas, which were really hard to sell on the masses. I mean, you listen to some of the interviews that didn't make the movie, and there was a hard religious line that also didn't want him to get this done, and it was pretty incredible that was a major portion of the political nature of the country at the time too, which is why he went out and tried to get Japan to get this done. So yeah, I mean, I'm not sure I'm quite answering the question perfectly, but you know, a lot of people look at the reason we made the film was that we had heard about Jerry O'Neill. We knew about the books, we knew about his legacy, but a lot of people didn't. And then I wasn't invited to this, but my boss was invited to the SpaceX, the booster landings, the first time he did the dual landings. And he was there, and he looked around and he realized that, you know, a lot of these people probably didn't know who Jerry O'Neill was. And he realized he needed to go out there and show that the future of space exploration and space business and space manufacturing doesn't start today. It didn't start with SpaceX. It didn't start with Blue Origin. It started, you know, even before Jerry, but Jerry is an iconic part of that journey that people don't know about. And we realized we had to make a movie about it.
Yeah, very much. So one of the things that captivated me was his resilience. Like you said, you know, what he was willing to do to make this a reality. And another thing that I really like, oh, what's that, Michael? Oh, that's
perfect.
Yeah,
it's the Bible that started everything.
It is. Yeah, a lot of people call it the handbook or the Bible for space. Well, space manufacturing, space business, space.
It hasn't had a cover. I don't know if I ever had a cover for it, but you know, Musk and Bezos and about a dozen other people reference it as kind of that must read book that kind of starts everything. And you know, the two people that I kind of credit that personally got me into space, Tomlinson and Diamandis, you know, they were there at the very beginning. So it's just kind of amazing to see how this has transpired. But you know, your point about not everybody knows where our foundations were crafted. I think that's kind of important. That's one of the reasons why we wanted you to join us today. I understand you've got a bit of a presentation. Do you have some show and tell for us?
I do. Yeah, I can jump right into that. Two quick little things I can add to what you just said, by the way. The book you have, if you had the cover, that thing would be worth a lot of money, because the cover is the original first edition, the one with like the really beautiful Rick Gittes artwork. If it's in good condition, that thing's worth a lot of money. That's the one I have, although mine's worth more for a different reason. Go ahead, sorry.
No, I think I do have the cover. I just don't think it's on my shelf because I reference it a lot. Yeah. But I actually got his wife to sign it, and she blushed when I asked. She's like, I didn't write it. I'm like, I know, but you were there in the beginning, and he died before I was even aware of this stuff. So I mean, I've got it signed for the wrong person, but for the right reasons. So
yeah, she was there every step of the way.
Yeah.
Credit where it's due, right?
Yeah, and when I mentioned that the movie would not exist without the family, that's entirely true. But I'd say a large portion of that was the widow, Tasha O'Neill. Nice. But and then the second thing I just wanted to say real quick was, you mentioned that Diamandis and Tomlinson got you kind of, you know, started. I forget what it started. Got you moving in this industry. Yeah. It's really cool to watch the movie too, because there's photos of Jerry, and in the background you can see like a young Peter Diamandis holding like the High Frontier, kind of like going through like a conference, and you'll never notice that unless you stop the movie on every single frame. But that was sort of the passion of making this movie, was putting all those Easter eggs in there.
You can't see, but I only wear 2 pins. One's Space Frontier Foundation, the other one's ISU. So
there you go.
Those are my roots.
There you go. Well, here, yeah, I'll jump right in. Let me just make sure. I want to make sure I'm going to share my screen correctly, because I have a few screens here.
Yeah, no problem. And also, while we wait for Will, Michael, you can go and look for the original cover.
Yeah, I mean, it's not like I was selling. Y'all don't know, but I have probably 50 signed books behind me. I'm a big nerd. That's my one collection that I really actively pursue is signed books by space nerds. So
you can donate the proceeds from your auction to Foundation for the Future.
There you go. Yeah, we should.
Well, this looks fabulous, Will. Whenever you're ready to present.
Yeah, absolutely, not a problem. So we kind of went over a few little bits here, but really, I mentioned I'm the writer and the producer of the film. I'll tell you a little bit more about the rest of the team later. This presentation will give you a little bit background on who Jerry was, his story. The original presentation that Layla saw when I did this was a little bit different, and it had a little bit more of the deep dive into the stuff we didn't even make into the movie, but for time I won't. I can direct you to places to go find that. But the other thing is I actually ended up I was able to go through our archives over the weekend, and I found some clips of Jerry speaking about space solar power and how this idea would have helped achieve space solar power. So I have a clip of all that. It looks awful just because it's from the archives, but I'll show you that as well. But here's our poster, obviously. So there's a whole story of Jerry O'Neill's life before we got to this point here at Princeton in 1969. There's a book about his whole life, and I'll talk about that later. But the story that I want to focus on and what the movie focuses on starts in 1969 at Princeton University, where ironically I grew up. So this was a time, it was the Vietnam War. It was a time when physicists were relatively vilified for the evils of war. And so Jerry frequently would try to teach his students that physics could be used for good and not necessarily for evil. And so one of the things he did, though, was actually he had a focus group where he would ask students who were performing a little bit faster than the rest of the class questions that were a bit far-reaching, things that were almost things that he wanted to research, he just didn't have the time for. And he would put his students on those problems. And one of those problems was, or rather one of those questions that he asked them to work on was very topical. We just landed on the moon. We were thinking about branching out and maybe setting up shop on another terrestrial surface. And he asked a question that a lot of people associate with Gerard O'Neill, which is considered having changed the world, I think, but also changing the future of space industry, but also everyone in his life and his career, which was that, is the surface of a planet the right place for an expanding technological civilization? So the students, and rather, by the way, what he was sort of implying there was, is there a better place than being on planets? Is there a way that we can make habitats or communities or places in space? And this was a bubbling idea at the time. So he really wanted to look into the first principles of physics and figure out if there was a better place. And they took a few weeks to look at it and came back, and the answer was no. Setting up shop basically on the surface of a planet was actually not the best place to do it. And quite frankly, we'd probably run out of money before we got the ability to do another one. So after some research, he built this whole compendium of how this would work. He tried to get it published for years and finally did in Physics Today in 1974, September 1974. And this was the first article. And for a lot of people in the movie, you'll see that, and by the way, I think there's a few people on this call today who are in the movie, which is really fun. Rick Tumlinson, who I think may be joining us later. And then I think I saw Al Globus and Gary Olson. They're both in the movie. So on the left here, you'll see what his first kind of mock-up was for, and it's definitely not done by him. He was a terrible artist. he was a mathematician. And so this was the original color version of it. And on the right was actually one of the slides he would use on his presentations. I found this in his home in Princeton. And it was sort of like a cutaway of how the math and physics of it would sort of work. And there's a lot more of these that I can share with you guys later. But here's how, if you haven't heard about these, if you have, stay tuned. But if you haven't, the functionality of these would be that we would put them in places called the Lagrangian points. These are stable gravitational points between the Earth and Moon. And the most popular ones were L4 and L5. Ironically, not ironically, that's where they came up with the L5 Society. And there would be 2 of them in space at a time, and they would be connected by these thin white lines you see on the bottom of the left photo here. They would rotate about 3 times a minute to create Earth normal gravity. There would be mirrors which would reflect sunlight. You'll see that there's these mirrors those are the mirrors that are sticking out there. There's 3 land areas and 3 glass, rather window areas. And then the large size would be large enough to create enough scattering to replicate the blue skies of Earth. They would be filled with breathable air. They would be having agricultural pods. This actual white sort of orb you see on the right side of the photo is the agricultural pod. So they would be able to have crops much like we do here on Earth, but they could also control the weather and the time of day, so they could grow crops a lot faster. The other part that was obviously big and important for today is that these would include space solar power panels, which would face the sun and absorb endless energy. So that's actually this brass donut you see on the back here, and that would, of course, power the station itself. But then a lot of the excess power would be, and I'm not sure if this is how it's done or what the idea is that this is how it'd be done today, but back in the day is that it would be sent back to the Earth using microwaves. And there would be almost no loss of power in sending it, and then we'd be able to use it here on Earth. And if you had enough of these, then that would be a viable industry to invest in. So obviously it would change activities, sports. A lot of the goal for some people was to actually make this a place for people who were elderly. Once we were able to actually build these and replicate them financially soundly, getting people up there who had either ailments or illnesses, or if they had bad backs, or they were just elderly, we could put them in places with lower gravity, and they'd be able to, people believe they would be able to live longer, but also they just have a better lifestyle because of the lower pressure on their bodies. But obviously, I mean, this would change sports. This would change a lot of things. You could have human powered flight. There's books written on this stuff. You can go find it. I'm sure you've seen it before. It's really fun. The size would also, the major thing people said why this wouldn't work is because of the cosmic rays, but he was able to prove with math that was not going to be a problem given the density and thickness of the shell. And then the initial idea that he had would be that these would hold tens of thousands of people, but it was, even by today's standards, we're thinking even millions. Blue Origin is thinking millions, because as you'll see later, that's the direction of where that company's heading at the moment. So these are some more artistic mock-ups. I'm sure you've seen them all before. There's a lot more in the movie that I don't want to ruin them for you here, but there's a lot more in the movie that you haven't seen before. So please go see it. Even ones that were drawn by Jerry himself. Actually, real quick before I get there, there's sort of like a how. There's 2 important parts here. There's a how and a why. I'm going to leave the how for you to go see the movie and see how this would be done, because there was a lot of what really got people's attention was that this was doable. This was a viable option. We could do it. There was no new physics needed to be invented. There's no new leaps and bounds that we had to get to that wasn't available today. And that was today in 1974, 5, 6. So obviously we still have that today, but I'll leave that for the movie. But it was more about the why for what I'm going to talk about today. And so there were 5 main things that he realized he could help alleviate on Earth, and realized that we would hit our limits to growth, which was the Club of Rome topic at the time, which was that we would hit a limit to growth, and we as a species would struggle to survive and may end up imploding in a metaphorical sense. So what it would help obviously alleviate is overpopulation. You make more land area, you make more places for people to live. It would also alleviate the hunger on planet Earth. It would also help with dwindling resources and energy, obviously space solar power being a big part of that. It would help with climate change, and all of these would help alleviate the effects of war. Jerry really believed that by doing this, we would see a future where wars would maybe just be too costly to even have. And me as a practical person, I'm not sure that would have been as achievable as he thought it would be, but it's a really beautiful vision to look forward to, and it's hopeful, and who knows. So he was frequently quoted as saying, "Opening the high frontier means making possible and ensuring the survival of the human race." And I really believe that 100% is true. And two, if Jerry didn't say that, we may not be living in a hopeful future that we are today. And I'm really, really thankful for that. So now I have a video of all those archive footage of him speaking about solar power and how it would work with his cylinders. So please excuse the bad sound and any of the time code you'll see here, but enjoy.
A program once at the level of producing a couple of satellite power stations per year would not stop there. We would then upgrade the manufacturing capability up to the point eventually of being able to satisfy all of the world's needs for low-cost, clean electrical power. This is a cylinder which has its axis pointing toward the sun always. That would be a solar power satellite. And this is one of the great big things I spoke about that might weigh as much as a big ocean liner, but could be built in space.
Really makes no difference once you get it there, what it weighs, right?
That's right. That's right. So we've calculated, in fact, that a program like that, if all of the study reports and so on do hold up as they seem to be, could even be supplying in a very clean way practically all of the energy we would need within another few decades.
Absolutely fascinating.
And maybe even to build solar power satellites, which would, if they work out, if they are economically competitive, supply the entire Earth with clean and free and reliable solar energy. What about the source of energy in space? It's the free energy of the sun, that nuclear reactor conveniently placed for us nearly 100 million miles away. The sunlight, in the form that it comes out in space, is constant and very, very powerful. And when a space colony is set up in the proper way, the sun is always in the same location relative to it, so that not just in the vicinity of the Earth, but much farther out in the solar system, it's possible to have light-gathering mirrors, which can produce the same solar intensity that we have here at the distance that the Earth is from the sun. So we can provide our energy at any location that we like within the solar system, even as far out as the planet Pluto and beyond.
Great. So obviously things started taking off for him in those mid-70s. And there's a lot of factors that got him to end up writing the book, The High Frontier. But in 1976, it was the end of 1976, 1977, he released The High Frontier, which was basically, there's a few really important parts about that. But really what it was a mathematical, it was simple mathematics and physics for everyday people to see how we could do this and convince them to take this seriously. It was also filled with a lot of fictional accounts of what it would have been like to be one of those people going up there and either building or being a part of it or coming there and back and going back and forth. And what it would be like to, grow a family in space. And I don't mean grow as a family and have, children. And so this book, however, was really the thing that started it all. A lot of people started picking up this book, and if you talk to anyone who was inspired by him at any point, they either had the book, they either were given the book, or they bought the book, and it changed their lives forever. What's really awesome about this book is that it still holds up today. And we actually just released a new edition of it, which I'll get to it later. But you can still read this book, and it's the same mathematics, physics, and vision that companies like Blue Origin are using today. So I highly recommend you read it. And in the words of Jim Muncy, anyone can read the book. It'll change the way they look at space forever. And I highly recommend, if you haven't, to go read it. So right after that, he held some space manufacturing conferences, and those were a really awesome time. And I wish I had time to talk about them too, but I don't. But what was really important was that someone showed up to one of those conferences from the New York Times, published them on the front page of the New York Times, and it really changed everything for them overnight. They had to disconnect their phone, they had to change their phone number, and it really just put him into the limelight. And at the time, a lot of major shows brought him on, and it was really fun. He was on Beyond 2000. He was on Johnny Carson, 60 Minutes. He was on In Search of with Leonard Nimoy. He was on PBS Nova. He was on Larry King's radio show in like the first couple of years, which was really cool. And then obviously he was in print all over the world. And I think we had something like 500 plus print pieces to work with when we made the film, and we only ended up using like 35, but we could have just put so many. And this was really important time for him too, because he was not only a worker on this, he was an activist. And he endlessly worked with grassroots campaigns. He worked with the government. He was on the National Committee of Space under Reagan. And he was giving talks all around the world at universities and on news channels and even in other languages. But most importantly, around this time, he founded the Space Studies Institute. And he founded it with his wife at the time in Princeton. And it was really to bring the masses of people who now looked up to him to work on this together, to prove to government and to private citizens with financial capital that this could be done. And so this is sort of where the story really kind of explodes. And so I think it's a good time for me to also now show you the trailer. So we'll jump right back into another video. If you haven't seen it, I hope it inspires you.
Time. These are the most dangerous decades in all of human history. We have the ability to destroy ourselves, and yet we have not broken free of the limitations of that fifth biosphere of the Earth. Now, some serious scientists are talking about whole colonies in space. Not on the moon, Mars, or Jupiter, but on man-made planets, and populated not by scientists and astronauts alone, but by hundreds of thousands of just plain folks looking to get away from an overcrowded Earth, running short of energy, water, and clean air.
The human race must leave and occupy other places in space. Do you really believe we can be there soon?
With the technology that we have now, we could do it, and maybe by the late 1980s.
Talking about outer space and colonizing outer space is always intriguing. And here's a gentleman who knows about it. Would you welcome, please, Gerard K. O'Neill.
Will, I think we lost volume.
I've got it. Let me try see if I can, Will, just pause that for a second. We don't have volume there.
Is a planetary surface.
Oh,
sorry.
The volume cut out on your video. Can you?
Oh, sorry. I think it's because I muted myself thinking I had like a double audio. Sorry, hold on.
All right.
Was it like right around here?
Right out there, right at the Johnny Carson was introducing.
Okay,
right.
so sorry. I thought I was giving you like 3 audios. So I muted. Okay. Oh, no.
And can you turn it up a little too?
Yes, I can.
Thank you.
Planet at the present time. These are the most dangerous decades in all of human history. We have the ability to destroy ourselves, and yet we have not broken free of the limitations of that fifth biosphere of the Earth. Now, some serious scientists are talking about whole colonies in space. Not on the moon, Mars, or Jupiter, but on man-made planets, and populated not by scientists and astronauts alone, but by hundreds of thousands of just plain folks looking to get away from an overcrowded Earth, running short of energy, water, and clean air.
The human race must leave and occupy other places in space. Do you really believe we can be there soon?
With the technology that we have now, we could do it, and maybe by the late 1980s.
Talking about outer space and colonizing outer space is always intriguing. And here's a gentleman who knows about it. Would you welcome, please, Gerard K. O'Neill.
O'Neill rolls out this book called The High Frontier that shows how to do it step by step. And it's go time. Anyone can read the book. That will change how you think about space forever.
It's possible to make habitats which are relatively big enough to be very Earth-like.
90% of people on Earth in 100 years would move out into space. We call the Earth the old country.
Jerry O'Neill asked, is a planetary surface the right place for an expanding industrial civilization?
The episode of human life being confined to Earth is coming to an end. Space will be the next civilization.
Industries and colonies in space may sound incredible, but we who are working toward them know that most of the building blocks are already in place.
Jerry O'Neill is a physicist with a brilliant reputation among his colleagues. O'Neill might have stayed in that abstract world, but he has always been intrigued by space.
Jerry had a dream of going into space, and he went through the whole program, all the rigorous, grueling physical and psychological tests.
I was really worried that O'Neill's influence and his greatness has not been publicly understood. But then if somebody with the wherewithal of Jeff Bezos actually tries to implement it, that's transformational.
It's this generation's job to build that road to space.
Professor O'Neill was very formative for me. I read The High Frontier in high school, and as soon as I read it, it made sense to me.
Space isn't just something that's just the engineers show up to. You know, this is something for artists and writers and business people.
We were a bunch of young, intuitive punks. We're all Jerry's kids. We're all, in one way or another, caught up in this idea.
3, 2, 1, 0.
Yes, it was crazy. Yes, it was science fiction. Yes, it was way out there. But the steps were there. It just was hard work. And all of us were willing to do the hard work.
We, you and I, are the only people who will ever have the privilege of saying, we explored the solar system first.
This concept is so enormous in its scale and the change of human events that's going to happen inevitably as a result of this.
It's very important that it be about everybody, that we stay true to Jerry's vision. We're all Jerry's kids, and that's something to be excited by and a legacy that we can all live into.
Life is extraordinarily rare, extraordinarily precious. Opening the high frontier means making possible and ensuring the survival of the human race.
Okay, could you guys hear that okay? Because I think it's coming through my mic.
Yeah, it was good, Henry.
Okay, cool.
Before we continue on, I just noticed that Rick Tomlinson is here. He will be joining our panel. Really quick intro. Rick is named one of the world's top visionaries and one of the top 100 most influential people in the space field by Space News. Rick is credited with helping start what is called the New Space Revolution. He is considered one of the best public speakers in the space field, and his writings and quotes show up around the world from the New York Times to the People's Daily. Rick is a space luminary who paid tribute to Gerard O'Neill in The High Frontier. How are you, Rick?
I'm doing well, and I always hate hearing that bio, but yes, doing well. I am, especially in conjunction with something about Jerry O'Neill. I'm that big compared to somebody like Jerry.
Rick was also an associate producer on the film, by the way.
Let's let Will finish up his stuff, and then we'll let Rick share some of his thoughts. This is fantastic, y'all. I'm so excited about this.
Okay, so in wrapping up here, so this was our team. As I mentioned, Dylan of Voyager was our executive producer. And then the two gentlemen below in black and white were for Subtractive Inc., who are the space company I mentioned in Santa Monica. They were our director, editor, and producer, as well as myself. We had an incredible, obviously I've already mentioned this, but we had an incredible lineup of people in the movie. We had people eager to, like I said, we had to have a lot of doors open to speak to some of these people. But once we did, we had people doing backflips to also be in the movie. And if you, obviously I mentioned some people are also in this chat are also in the movie. But if you know, I'm sure you know half the people on this list. You got to watch the movie just for that part, watching them talk about their hero, because a lot of the people everyone in the movie pretty much took on their career because of the inspiration of Jerry O'Neill. And so it was a really nice testament to have them all come back together for that. A few quick highlights about the making of this movie. We have thousands of hours of archive footage from friends, family, universities, museums, studios, and even literally from the trash. We found things in the trash. We went through 1,000 magazines and books that were we were told mentioned Jerry O'Neill. We went page by page looking through them. We bought old tape decks and out of commission video devices just to watch old videos we thought might have content of Jerry, and many of them did not, but some of them did. We went through hundreds of hours of radio talk shows, speeches, and new recordings were listened to and digitized. We also had about 1,000 beyond repair slides. We were told they were beyond repair, but we were able to refurbish them for the movie. We also digitized, this was really fun because people don't like, a lot of times, a lot of artists don't like their work being altered. And we got permissions from Don Davis, Rick Gittes, Robert McCall, Ron Miller, Pat Rawlings, and many more to take their work, use it in the movie, and animate it, which is relatively unheard of, but yet again, another testament to their inspiration of O'Neill. And then we also commissioned 2 well-known 3D artists to create fly-through animations of being in a cylinder, which I wish Jerry could have seen. And then just a quick last moment here, last mention here is that O'Neill's writing and vision still holds up. I mentioned that before. It really does. Please go read The High Frontier. I think you'll find it incredibly inspirational. And it's just as relevant as it was then as it is today. And we call this a Dust to Diamonds project for all the reasons I just listed there. We took trash literally and made it into a really beautiful tearjerker movie. But however, I do think that, of all of Jerry's achievements, the one that was the greatest achievement was his Jerry's Kids. And those are the people who spent their younger lives, Rick included in this, younger lives inspired by Jerry O'Neill, followed him, and then decided to take on their careers and build their so-called empires and study their fields of expertise for the dream of making his vision a reality. And almost all of them have. And they all call themselves Jerry's Kids, myself included in that. So it's now available on these 5 platforms. It will be available on Amazon in the coming months. They're having a really fun issue with our movie, so hopefully you'll see it there soon. But the best and easiest places to find it are on iTunes, Apple TV, and Google Play. We also released 2 books along with the movie. The one on the left here is the original, The High Frontier. This is the movie edition copy. It's the actual 3rd edition inside, but we rebranded it with our own artwork from the film. And then the book on the right actually was written by our executive producer, Dylan Taylor. This is the full life story of O'Neill. Like I said, there was so much about his early life that we couldn't include, and that's, things like his childhood, his time in the Navy, and then his journey to becoming a world-class physicist. He was up for a Nobel Prize, and all the way through the High Frontier era and on to his passing in 1992. Both of these are in our merch store, which I'll put a link to in the chat bar here. Also, here's some really cool swag if you want to go get some cool shirts, hats, cups, jackets, sweaters, even the film poster. They're all really awesome. I have all of them. And by the way, you can get 10% off if you want using the code Frontier. I'll also put that in the chat. And then here's some helpful links. Top link will give you everything. That's the merch. That's the links to the film. And then about the filmmakers and the people in the film. High Frontier merch, obviously, that's where you can go get them. And then you can follow us on all social media handles using @HighFrontierDoc. And that is the end of my story. I'll turn it over to Rick.
That is so amazing. Yeah, so that one.
There you go.
Or to do the thing in the movie like this, right? So
right.
Yeah, and I'm so honored because they're both, I think I have them both signed by the man. Gosh, I don't know. So first of all, the reason I'm late is ADHD and the fact that I accidentally, because of time zones, double booked myself. So I just left the graduating class of the Berkeley Space Technology Department. Now, I love y'all, but they are my heroes, right? Because they're the ones taking over. They're the new Jerry's Kids. And by the way, I explained Jerry O'Neill to them, as I do to everybody, almost every lecture I give anywhere in the world. And what's really important about this, Mike, how long do I have, by the way? Or Leo, I'm sorry, whoever.
We've got about 5-10 minutes.
Yeah,
some wrap up.
You have like 5 to 10 minutes, Rick. But please, like, we want to learn more about this because it's amazing and it's completely inspirational.
Yeah, sure. I just want to be really, I want to.
And I want to specifically, I want to hear about, your early days with the man himself, and then how that got you where you are.
Yeah. I'm one of the look, the whole term Jerry's Kids is like, we're the, the island of misfit toys, right? That's the whole point. And anybody watching this who doesn't know what that refers to, was the comedian Jerry Lewis used to hold a telethon in support of the disabled. And it's a play on words. We're in the age of political correctness. There is no negativity in terms of anybody who's disabled or anything, but we were very much both outside of our own cultures at the time, and his name was Jerry. So it just popped up. Many years ago, I actually had mentioned it to a friend of mine, Dylan Taylor, many years ago, telling him the whole story and all of this. And of course, Dylan being Dylan, anybody who knows Dylan, an amazing human being. He pops up about a year later going, I'm making a documentary. I'm going to call it Jerry's Kids. And I'm sure Will has talked about this, but it became The High Frontier, which is probably a better name because otherwise people would have had rather interesting expectations going into it.
Yeah, I think so.
Yeah. So anyway, look, the thing about Dr. O'Neill, and anybody who's seen me talk about this, there were 3 kinds of people in the space field, the space taxonomy. There are and by the way, I like to simplify things so that I can understand them because I consider myself my own lowest common denominator. So in my taxonomy, there are what I call the von Braunians, which were the old space program. Und wir build the rockets for you. They'll be very big, they'll be very loud, and we will go into space. And you'll be proud of how we spend your tax dollars. That was the aerospace industrial complex. Then we have Sagan, billions and billions of stars. Isn't space amazing? Look at it, but don't touch it. That's sort of your astronomy community. And Jerry O'Neill, again, who was just a nice guy. He did have that weird Beatle haircut, the whole time. It was a little odd, but he just had a quiet voice. And the thing about Jerry was that, and his philosophy was use the tools of free enterprise, democracy, and space resources to expand humanity in space.
Yeah.
Now, his pet personal thing was rotating habitats in space. I believe if he had stuck around for a while, he would have adopted, as I have, and I am redefining it. I do this as consciously, to include in the term O'Neillians anybody who is focused on the expansion of life and humanity into space. Those are O'Neillians. Like it or not, I don't care if you like the brand, I'm going to hang it on you, right? You're an O'Neillian if you want to expand life and humanity into space. I do that by declaration. I declare. Now, at the time, talking about misfits, I was a college dropout. I was partying my ass off. I mean, the first time I ever heard about Jerry, and I forget, Will forgive me because I forget which clips may or may not have shown up in the film, but I was stoned off my ass in college, sitting on the floor of the student union, and there was a guy named Timothy Leary talking about space colonies, which we now call settlements. A little while later, I ran into a guy named Gene Roddenberry who gave me an inspirational backstage. I had 5 minutes alone with him. He said, "Go for it." Basically, he said, "It doesn't matter who you are." And I challenged him. I said, "Yeah, but I've dropped out. I yell at my teachers. I drop classes. I'm a pain in the ass, whatever." And he said, "You know what I used to do?" And I said, "No." And he said, "I used to be an LAPD officer. And I used to cruise around in my black and white with the scripts laying here for a show that was called, what was it called? Wagon Trains to Space. Later became Star Trek. And then he gave me a little lecture about just stay with it. don't give up. And so I did. And I started volunteering. I did the L5 Society. We had the aircraft carrier Intrepid. We were the only L5 chapter with an aircraft carrier in New York City. Um, and then I volunteered over time because these people kept showing up from the Space Studies Institute, and they were serious. And these were some serious people working on some serious stuff. And I volunteered. I basically said, I will sweep the floors, and he let me in. And he and his right-hand man, Freeman Dyson, were two of the most kind, generous, and giving people that I've met in my life. For somebody like myself, unlike some of my compatriots who came from Ivy League schools, who came from my dad, working class, he had 3 jobs. Again, I was not of the cut. I was not Harvard. I was not whatever. Nonetheless, Jerry and Freeman gave me room to be who I was, or what I call and what I adopted as a term, permission to dream. Permission to dream, by the way, is not something granted externally to you. It is something you grant yourself. And I later created a project with George Whitesides later and called Permission to Dream. And we used to give telescopes like the one you have next to you, Leo, to kids around the world. And so he and Dr. Dyson and the people in the Space Studies Institute of the time, which is a very different organization now, but at the time, they were very open. They were very inviting. In other words, I walk into the room in the Princeton auditorium, which all by itself was blowing my mind. I'm in here, what? And I'm looking around, and there are other people that are just as crazy as I am. And so he did this amazing thing that it's really a formula. I don't think he did it consciously, but it was a formula. He wrote a book about his vision. He put it out there. He made it rain humans with imagination. And then he created a bucket called the Space Studies Institute to catch that. And then he used that to water this movement. And the movement became the one you see today. And whether it's the International Space University, whether it's the National Space Society, the Mars Society, Elon, Jeff, they all come from Jerry, whether they admit it or not, right? I mean, for example, Space Frontier Foundation helped write the white papers, or actually wrote the original white paper, a guy named Charles Miller with us, wrote the white paper that led to a thing called COTS-CC Dev, which became the funding mechanism by which SpaceX and the others got started. There was a guy named Henry Vanderbilt, Space Access Society. He was over out there. He was fighting it along the cause. He's almost as cuddly as I am, Henry is, but that's a whole different story. And these people were fighting because Jerry had given them a vision, an endpoint, a place to go with their imaginations, with their passions, with their ideas. And so we fought. Now, some of us did I used to call it the cocktail circuit. That would be like my friends Diamandis and Bob Richards and these guys, and they went off with their Halliburtons and cell phones that were this big and went to, and did really well in that world. There were friends like Jim Muncie and Gary Olson and all these people and Charles Miller and us, and we became the radicals, and we went boom with the aerospace establishment head on, and we fought them for 25 years. I testified in 95 on behalf. It wasn't like I was some genius. I was testifying for the cause, and I called for all transportation to and from the station to be commercially provided, all expansion and replacement of the station to be commercially provided, all energy for the station to eventually be commercially provided. Right? It only took us 25 years or 21 years to get the first one done. And get that SpaceX flight up there carrying payloads.
Yeah.
It's been a long, long battle. But I think all historical shifts and changes take a long time. Only in when you're looking backwards into history, it looks like a blink of an eye. This thing happened, boom, and everything changed. Of course, any student of history, which I'm sure everybody who's watching this is to some degree, understands that history is a confluence. It's a manifold. It's the coming together of a matrix of different people picking up on, developing, adding to, taking away from, subtracting, remixing, blending, recreating, and forging something brand new out of what wasn't there before. And that's what has happened here. And that is the catalytic moment, the catalytic energy, the catalytic input that Jerry O'Neill gave us, all of us. And we've all come out of it and gone in all these crazy directions. And it's so funny, it's like, I don't know if you've ever seen Life of Brian, but there's a moment in Life of Brian where the young guy who grew up in the stable next to Jesus shows up, and there's the radicals that are trying to overthrow Rome, and he starts to sit down with them, and they're like, well, we're the Palestinian Liberation Front, and the Palestinian Front for Liberation is over there, and those guys are over there, and they're over there, and and we all hate each other, but we really hate Rome more, right? And that's what we've done. We all go off in our little causes, but at the core of it is this gentleman, Gerard K. O'Neill. And it's stunning to me when I look back at my arc of my life that I could get anything, that I could get into a track that's anything like this. Because I get to hang out with people in another life that would have been my heroes are now my peers. People who are doing things that are transforming civilization itself at its very core. And by the effective success of what they do will change what it means to be a human being itself in the next 50 years, or we will all die. But if they succeed, and I get to be around them, and maybe once in a while slip an idea into their ear as to maybe the way we should do it. So Jerry gave me that. He opened that airlock for me and let me in, right? Now, I know I have a lot of friends who are trying to push me out the other airlock, but that's because I'm so cuddly. But it really is a case of he could have written a book and been righteous about the fact that he wrote a book and nobody listened. He'd be that guy in the restaurant, like, I wrote a book once, nobody listened to me, we're still using horses, and I had this idea called a car, He could have been that guy, but he wasn't. It was because that he opened it up to give it away. He gave it as a gift. This guy was on the path to winning the Nobel Prize for the Super Collider, and he gave it up so that we could create a future like no one had ever imagined in human history. And I use that sometimes when I'm in front of audiences. I'm like, so what are you going to give up? What price are you willing to pay? Now, I will say this. The volunteers, the people that are out there, and this is something that does make me crazy at times, that the Elons, the Jeffs, the, God forbid, Peter Diamandis, and all these other people out there claim to have done it, or it gets heaped on them whether they claim it or not. They're the ones doing it all because we like celebrities. There's probably no more than, I would say, 10 to 20,000 core people over the last 30 years at the center of this revolution. They're the ones who've done it. I consider Jeff and Elon what I call the billionaire cavalry, right? We were already engaged. And what happened was they showed up, we were engaged with Jerry's principles, space resources, creating the path. And these people showed up and we were able to go like them, and they were like, I've got money, you can't stop me. Well, and I'll move towards the end of this. The revolution is fully engaged. By the way, this was from the first project of the Space Frontier Foundation in 1988.
Wow.
What do you got, L5 or Space Frontier? Yep. I have them all. I've got them all. I've got a whole collection of buttons. And by the way, I was out looking at buildings in Van Horn near Blue Origin. I just bought the last 100 acres between Van Horn and the Blue Origin launch site. And I'm thinking about setting up a SpaceX swag stand, like with velvet blankets of Elon, so Jeff has to see it. No, I'm kidding. I'm kidding. I'm kidding. What I'm thinking about is, wouldn't it be great if we could get like a place there or Mojave where everybody could send all of this stuff and we could just start saving it. The filing cabinet that's off camera here that's filled with failed business plans.
I have boxes and boxes of stuff. My whole office is an artifact to this 20-year history. So
perfect. Yeah, exactly right. So anyway, that's really it. I think that I want to thank Will, because I know when he got started and the path that he had to traverse, he didn't kill anybody, which is a good sign. He was able to navigate this thing. He had, and I was about to say with grace, that would be Will and grace, but he had all the way through. He showed a lot of class. I definitely want to call out Kyle and Ryan. Subtractive. They're my brothers from another mother. I actually have a room there in their studio. Talk about swag. That's an editing room that's full of my books that I didn't have enough space for when I moved to Texas. So it's the Rick Tumlinson Memorial Library. But they are creative geniuses, and they're doing a lot of great work. The only reason I got an associate producer thing on this was that I helped source a couple of things, and they're paying me back for showing embarrassing pictures of me in the documentary. So,
well, I mean, the truth though is the kernel that's the most important part to me is that this would not have happened if you didn't have that conversation with Dylan, and that's all it took. And you put a fork in history and made something else happen that was just as important.
I talk to people all the time. It's the fact that Dylan did it, right?
Dylan was listening.
Yeah.
He took action.
Yep.
Words are rare.
Gentlemen, thank you so much. We need to wrap up the day. Super happy about this. It's been a terrific day. We're going to turn it over to Leo and Tom for a few moments. And thanks everybody for joining us.
Yes.
Thanks for having us.
What are you saying, Rick?
I'm saying buy the book.
Buy the book.
Of course, buy the book.
Of course, buy the book.
Yes, very much so. Thank you so much, Will and Rick, for that amazing presentation. For Will and Rick for being with us today in Conversations for the Future. For those of you who have not seen this amazing movie and to learn more of Gerard O'Neill's integral importance to the space industry, please go to thehighfrontiermovie.com. I believe we'll put the links on the chat so you could see where you can find that and where you can watch it on various platforms as well. Will and Rick, if you could also just be kind enough to just put your LinkedIn link on the chat and comments to continue the networking benefits for this event. And for everyone listening, thank you for joining us for Foundation for the Future, powered by Foundation for the Future. Conversations for the Future is a nonpartisan event about near-Earth space infrastructure from now to 2035. Foundation for the Future is dedicated to the creation of a public-private partnership for space infrastructure development. And to support this cause or to sponsor one of our events, please visit our website at f4f.space. That's the number 4. We are grateful for the support of our corporate and individual partners. And now, without further ado, as Michael said, we have Tom Olson here with us today. Thomas Andrew Olson has been the program director of the New Space Business Plan competition since 2011. One of the last decade, the business plan competition has awarded over $350 to deserving space-related early-stage companies. He is the founder of the Center for Space Commerce and Finance, which sponsors the business plan competition, which he will be talking with us about today. Hi, Tom, how are you?
Okay, I thought someone had to unmute me. I have to unmute myself. Okay. Actually, it's $350,000 in.
Yes, I'm sorry, that was a typo. I'm so sorry.
I put K after it because I thought someone else would put it, write it in differently. But that's my bad. Thanks for sticking around after what was always a rousing sermon from Reverend Rick. And I always enjoy them too. I'm inspired by them as well, mainly because I'm also a Jerry's kid going, way back to the 70s. I helped found an L5 chapter at my university back in the late 70s. I've been bouncing in and out of this for a long time. I found a niche on this in the early 2000s when I first met Michael at a space conference. We realized the business side was just starting to be looked at around the edges. And we realized there were people, there are all these just hundreds and hundreds of brilliant engineers showing up in these things. They all had these wild ideas and they were waving their arms and isn't it cool? And space is cool. Give us money. I realized none of these guys have any business background. None of them. Something had to be done. And while guys like Michael and myself and a lot of other people I could name, we're looking at this thing. A lot of us barely had more business experience at the time than some of the other people that are out there with engineering hats on waving their arms. But we took advantage of whatever niche we could find and worked our butts off to try to add some value in that regard. One of the things I helped do almost immediately was found what became the business track at the International Space Development Conference in the early 2000s, and they're still running that, I think. In 2008, I joined the Entrepreneurship and Investment Committee for the International Astronautical Congress, and we put on 3 tracks a year at the IAC towards those same things. We all look at this, it's really the business side. And then in between, I joined this outfit called the Space Frontier Foundation, and they started doing this thing called the New Space Business Plan Competition, originally sponsored by Highland Prize Trust. Not a lot of money, and a lot of interesting ideas were being promoted out there. And I more or less took it over formally in 2011 when we got the first of 3 NASA grants to do some bigger prize money. And these programs went very, very well. There's a lot of interesting companies out there that actually not only won some nice funding as part of this, but they also got a lot of notice in the audience and from the investor community. And it did lead to some rather substantial fundraising events for a lot of companies that went through our program. We designed a program, we didn't want it to be just a pitch event. We wanted to be far beyond that. We did something prior to the event known as a boot camp, where they spent the entire day, the finalists would, after they did their applications, and we would go through every aspect of their presentation and their business model and ask them all sorts of really hard questions that a potential investor might ask of them to kind of get them ready to present. And this has gone along very, very well for a long time now. We all, and a lot of us in the space community, not just us, we all kind of flattened out in 2020 because of the COVID thing, and everything that we do was always associated with a conference, and they just weren't having any in 2020, and so everybody kind of flattened out. And then near the end of the year, I'm almost ready to give it up, and I hear from Michael Lane, and he says, "You got to talk to these guys at Foundation for the Future." And I had a talk with Tim Chrisman, and then I basically got an offer through our own nonprofit organization now called the Center for Space Commerce and Finance. I'll give you a link later in the chat, and you guys can check that out, to put on a series of potentially 3 different all virtual new space business plan competition events in 2021. And the first one, and that's why I'm here, this is kind of the preview of coming attractions. For tomorrow, we have found 7 amazing finalist teams that we spent the last couple of weeks working with, all in Zoom, all online, working through their presentations and working through their business models. And I think we've got a group of finalists that are the match of any other group we've had in the past when we were doing these live shows at conferences. It's going to be a lot of fun. Each finalist company gets to do their pitch for about 8 minutes, after which they will be peppered with questions by 3 judges we've selected from the investor community. That are going to be joining us. We'll be getting those intros tomorrow. I just want to very quickly, if I can do this, if I can't, oh, there it is. I just want to read off the names of the companies. The companies presenting tomorrow will be Life Ship, they do, they're sending DNA to the moon, essentially. Spaceway is building some things for the Internet of Things. Irradiance wants to do something with space solar power. Venture Ingredients wants to manufacture food in orbit. Orbital Space Satellite Services is promoting the space program in the United Arab Emirates. Mars Society Kenya is doing a similar thing. And Astroport is building landing pads and other types of concrete out of lunar and other space-based materials. So those are the people you're going to see tomorrow. It starts exactly right at 9:30 sharp. We'll have, again, 8 minutes per team for pitch, followed by 7 minutes from the judges, and we go on to the next team, and we'll get through all 7 of them by 11:30 p.m., after which the judges and I will caucus in a breakout room, and we'll be announcing the winner of the competition tomorrow afternoon late, about between 3:30 and 4, if I recall. The winner of the competition does receive bragging rights and a $5,000 prize that's being sponsored by Foundation for the Future. With my thanks and with their thanks. It's a wonderful thing they're doing, and if this goes well tomorrow, we're going to be doing 2 more of them. One as part of the August event, and another in part in November. I'll be giving you our webpage, and we also are on the Center for Space Commerce and Finance is also on Facebook and Twitter and LinkedIn. So we'll be putting in notices there as well. So look for this. Looking forward to it tomorrow, and we will see you then. If anybody has a question, I've got a minute.
Tom, thanks a lot. I posted your links to both the center and to the business plan competition. If you want to throw in your LinkedIn connections so that people can reach you. Thanks a lot. We're really looking forward to tomorrow. It's going to be a great competition.
Yeah, thank you so much, Tom.
And just guys, go for it.
Yeah, definitely. Thank you, Tom. And for everybody watching and listening, as Tom said, the new Space Business Plan competition starts tomorrow. Don't miss this Shark Tank style competition. C for F, or as we say, Conversations for the Future, will share the stage with budding space entrepreneurs vying to win the new Space Business Plan competition and win the $5,000 prize, as Tom said. All of this happening at 9 a.m. sharp, so don't miss it. Tom, if you would like to, and if you would be so kind to, please put your LinkedIn link and any more information on how people can get more information on the business plan competition tomorrow in the comments, and to continue the networking benefits for this event. And for everybody listening, thank you for joining us here at Conversations for the Future, powered by Foundation for the Future. We have Lila Gislison and Tim Chrisman closing this event. Lila, how are you?
I am great, Leo. Thanks for asking. I had so much fun today. This was a very dynamic Conversations for the Future. Loved learning more about Gerard O'Neill. I'm just inspired by such visionaries who are so ahead of their time. And yeah, thank you, Will Henry and Rick also for sharing more about that. We had a great lineup of speakers. One thing I did want to take a moment to plug, I think because we had Randy from NSS speak today, I think it's appropriate. It is the National Space Society's Ad Astra magazine. And I wanted to point out something kind of cool. Actually, Will Henry and I were on a call earlier last week, and I pointed out that there was both an article here about Gerard O'Neill and his life, and talks about the film a little bit. And then right next to it, there is this really cool advertisement for the Foundation for the Future. So yeah, check that out if you are a subscriber and member to the National Space Society. Also, this is on the shelves, I think at bookstores for the first time ever also. So you can pick it up at a Barnes & Noble or wherever you like to buy your magazines. So really cool stuff. So yeah, Tim was in Akron today. We'll go back to him a little bit, but I just want to make sure that you guys tune in tomorrow. We've got another phenomenal lineup of speakers, lots of panels, and then as Tom said, the business plan competition. I think that's going to be a lot of fun. And then we also have kind of a networking event towards the end. As I mentioned before, so many wonderful conversations actually happen after this event. We've just been honored by the number of connections made, you know, just with people who've attended. And yeah, just doors opened and things happening. So again, thank you all. Please do tune in tomorrow. If you haven't registered, if you're watching in the live stream, go to our website now and you can register for tomorrow's event, and you can join us for the breakout sessions. And then at the end of tomorrow, we will also be doing kind of a networking happy hour, if you will. So please tune in for that. So Tim, I'm excited to hear how it's been in Akron. Excited to hear you've been making connections and having conversations. What are the highlights so far?
I feel like the highlights are still yet to come. Tomorrow when we're in Bounce Hub, a local makerspace where we can sort of engage with and talk to the local innovative community, I think is going to be our highlight. It's been very enlightening and inspiring to see the sort of relics of Akron's storied past and how there's growth and movement in the community to revitalize and rebuild out of what once was. And it's exciting to see that and see the momentum that's starting to build here. And so I'm really excited to see tomorrow who we are able to find and talk to.
I can't wait. It's gonna be amazing. So, Lila, you actually mentioned a couple really exciting things that happened today. What are you looking forward to tomorrow for? Something that'll because this has been exciting. I mean, I had a lot of fun in this event today, and tomorrow is just going to be just as much fun. Can't wait to see Tim live at the Bounce House. So anything else that you might want to tell the watchers, the people who are watching, who are listening for this event, on what they can look out for tomorrow that might be really exciting?
Well, I think, again, I already mentioned it, but the business plan competition, I think is going to be a lot of fun. We've got a lot of great speakers. Go to our website to see the lineup. Panels, you know, again, I love it when the conversations are happening. Ideas are being exchanged, and, you know, sometimes you've got people who have different views or who are from different industries completely, and then just to get a kind of a merged perspective is fascinating to me. So I look forward to that, but really just yeah, just sitting back and enjoying the show. So thank you, Leo and Michael and Tim and Lee for putting on a great show today.
Right on. Thank you very much, y'all. Appreciate it. See you tomorrow. See you in the morning.
Well, that was fun.
That was fun.
Lee, the hair didn't come in time, or you put your daughter up to it.
It didn't come.
Was that her natural hair?